Hi, I'm Adiraj, and I run one of the top-ranked OpenClaw consultancies on the internet. Every week, I get on calls with founders and operators who want to deploy OpenClaw in their business, but have no idea where to start. Same conversation every time, like what is it? What does it cost? Where do I even start? So instead of having that intro call for the 100th time, I sat down and recorded everything I'd want them to know before we even talk. You're about to watch the full 16-part free course on building a production OpenClaw agent. By the end of it, you'll have a fully deployed autonomous agent running 24/7, doing real work for you while you sleep. Subscribe and let's get into it. Picture this, it's 7 a.m. and you haven't touched your phone yet. You haven't opened up a single tab, you haven't typed anything, and your AI has already gone through your emails, it's figured out which ones actually need your attention today, checked your calendar, pulled the weather, and grabbed the 3 most important news stories for what you're working on, and it sent all of that straight to your WhatsApp, cleaned, formatted, and ready for you right when you wake up. No prompt, no opening up ChatGPT, and no typing anything at all. It just did it because that's what it does every morning automatically while you're asleep. That's not something I'm describing from 5 years in the future. That is something that you will have running on your own machine by the time that we finish this bootcamp. And today, day 1 is where we build a foundation for all of it. I'm Adiraj and welcome to the OpenClaw Bootcamp. This is a 16-day bootcamp and I want to be completely straight with you about what that means. It's not just theory videos where I talk at you and you passively watch. Every single day you're building something, you're configuring something, you're getting something real running on your actual machine. By day 16, you will have a fully autonomous AI agent that lives on your own server, talks to you through the apps that you already use, remembers everything that you've told it, and takes real actions in the real world on your behalf. But today is day 1, and day 1 is all about the mental model. We're not touching a terminal today. There's no installation, there's no code. Today, I want to make sure, but by the time this video ends, you understand exactly what OpenClaw is, why it's categorically different from every other AI tool that you've ever used, and what we're going to build together over the next 2 weeks. Because if you don't have this foundation locked in, everything else we do later won't make sense. So let's get into it. Here's what we're covering today across 6 sections. We start with the problem because before I tell you what OpenClaw is, I want to show you the exact gap it fills. Then we define OpenClaw properly. The mental model, the one-line definition, the origin story of how this thing came to exist. After that, we're going to go side by side. OpenClaw versus ChatGPT versus Claude, row by row, where those tools stop and where OpenClaw begins. Then we get into the architecture. So there's 4 layers, each one doing something specific. And then after that, I'm going to show you the real use cases. These are things that people are actually running today. And then we're going to wrap up with a full 16-day roadmap so you know exactly where we're going to go from here. Let's start with the problem, and I want to be specific here because this is not a rant about ChatGPT being bad, something more precise than that. So let's go through the left column. Memory is managed through their platform, not files that your agent can read and update directly. AI tools today are reactive. You have to go to them. That's the core of it. I'm not saying that they're dumb. I'm not saying that they don't work, but the entire model is built around you going to them. You're asking them something and then getting an answer and leaving. They're waiting for you and you initiate every single time. Now here's what this actually means in practice. These tools are mostly chat interfaces. They were designed to answer questions, not to run your life. So everything they do is bounded by that original design decision. Their tools are sandboxed because they weren't built to touch your real machine. Their proactive features require paid plans and live inside their ecosystem because they were bolted on later. You're locked to one provider's models because their whole product is their model. And when you close the tab, it's over, because there was never a background process to begin with. And that's not a knock at these AI tools. Tools like ChatGPT are excellent at what they were built to do. But what they were built to do is have a conversation with you, not work for you while you sleep. Now, take a look at the right column. This is what an actual agent looks like. It reaches out to you, it knows your context, it acts on your behalf using real tools on your real machine, it runs on whatever messaging app you already use, and it never turns off. That is a fundamentally different thing. It's not a better chatbot, it's a different category entirely. And that's what we're building. So what is OpenClaw? OpenClaw is an open source personal AI agent framework. Each word over here matters. It's open source. So that means that the entire code base is on GitHub as an MIT license. You can read it, modify it, and run it yourself. You don't need a subscription, and there's no company holding the keys to your agent. It's personal. So it's not an enterprise platform or a team tool, but one agent is tuned specifically to you. And it's a framework. It's not a finished product you download and use out of the box. It's a system of components that you configure, customize, and control. The more you put in, the more useful it becomes. Now, the one-line definition I want you to remember is OpenClaw equals gateway plus memory plus tools plus channels plus soul. Those 5 words are the 5 core components of this whole system. We're going to go through all 5 today, and every one of them gets its own day later in the bootcamp. The thing to hold on to right now is that OpenClaw is a daemon, a DAEMON. It's a persistent background process that runs on your machine or a server. It never resets, and it doesn't turn off when you close a browser tab. It just keeps running all day, all night, doing whatever you've told it to do. And that is the foundational difference between OpenClaw and everything else that you've used. Now, I want to give you a mental model that actually sticks. And yes, it's going to involve a lobster. Think of your OpenClaw agent as a pet lobster. Might sound weird, but stay with me here. The food is the AI model. So Claude, GPT-4, Llama 3, Gemini, doesn't matter which one you pick right now. The lobster eats whatever you put in the tank. You swap the model, the lobster doesn't change. The tank is the gateway. It's the always-on environment where your agent lives. It's running whether you're home or not. Your lobster doesn't die just because you went to work. Now, the rulebook is your soul markdown file, or soul.md file. It's a plain text markdown document that defines your agent's personality, its values, its hard limits, and how it responds to different kinds of messages. It's written in English, it's not written in code. Day 7 is entirely dedicated to building yours from scratch. Now, the memory is the logs. Every structure you have gets stored into structured files that the agent can search and reference later. If you told it 3 weeks ago you prefer short responses, it's still going to know that today. The tricks are the skills. These are things that your agent can actually do. Things like browse websites, send emails, run terminal commands, check your calendar. These skills are how the lobster reaches out of the tank and affects the real world. And the heartbeat is a schedule. The heartbeat markdown file, or heartbeat.md, tells your agent what to do automatically on a recurring basis. So every 30 minutes, every morning, every Friday at noon, that morning briefing I described at the start, that's one entry in your heartbeat markdown file. You set it once, it's going to run forever. OpenClaw started as something called ClawBot. It was a personal experiment. Someone wanted an AI assistant that actually remembered things across sessions. It's not a product, but it's just something hacked together in a terminal for personal use. It's a persistent AI that lived on their machine and then kept a memory. That got rewritten as MoltBot, which was a proper rebuild with a real gateway architecture, multi-channel support, and a workspace file system. It still wasn't public, but just a more mature personal tool. Then it went open source as OpenClaw, and it absolutely exploded. Over 336k GitHub stars, it's the fastest organic star growth in the platform's history. It became the de facto standard for anyone who wanted to run their own personal AI agent. Today, the ecosystem is massive. iOS and Android native nodes, a Mac OS menu bar app, a full workflow pipeline system. It even has a skills marketplace with hundreds of community-built plugins and support for 35 plus AI model providers. OpenClaw is not a toy project that someone threw together on GitHub and abandoned. It's been battle tested by a massive community. It has serious momentum, and it's genuinely mature software. Everything we build in this bootcamp is on top of a very solid foundation. All right, OpenClaw versus ChatGPT versus Claude. Let's go through this row by row. So memory your agent owns and controls. OpenClaw's memory is file-based and lives on your machine. Your agent reads those files, updates them, and searches them. You can literally open any one of them in VS Code right now. ChatGPT and Claude both have memory that works well within their platforms, but it does sit on their servers and is managed through their interface. Now, proactively messages you. OpenClaw does this through a heartbeat, so it's running on your own machine with no subscription required. ChatGPT now has tasks for paid subscribers, which is real and worth acknowledging, but it's their infrastructure. It requires a paid plan and only works within ChatGPT's channels. Claude has scheduling and co-work for power users, but neither is same as a daemon on your own hardware, triggering actions across any channels that you've configured. It runs 24/7 as a true daemon. Now, OpenClaw is always on, running on your hardware regardless of whether any app is open. ChatGPT has scheduled tasks that fire on their servers, but you're dependent on their infrastructure. Claude has no true daemon mode. So it works on WhatsApp and Telegram. OpenClaw has native support for both. ChatGPT has an official WhatsApp integration, but no Telegram. Claude has no native support for either. Custom personality. OpenClaw gives you a sole markdown file in plain English, full control, and full transparency. Chat will give you a system prompt. Claude gives you custom instructions. Both are functional, but both are limited compared to what you can configure over here. Read shell access. OpenClaw has the exact tool, which is real commands, it's a real system, across all your channels. Chat will run code in a sandbox container with no access to your actual machine. Claude has this through Claude Code and through the developer interface, not through the chat interface. Now, in terms of swapping models, OpenClaw supports 35 plus providers. Chat is OpenAI only, Claude is Anthropic only, and OpenClaw is MIT licensed. So you own the whole stack. The others are closed products. Now, I want to be clear, ChatGPT and Claude are excellent products, but they're platforms and you're renting capability on their infrastructure on their terms. OpenClaw is architecturally different because you own the whole stack. Here's the single most important thing I'm going to say today. ChatGPT and Claude are conversations. OpenClaw is an employee. Conversations end and employees keep on working. When you use chat, you're doing the work, you're deciding what to ask, when to ask it, and you're taking the output and doing something with it. And then you're doing it all again tomorrow. The AI is a tool and you're the one wielding it every single time. But an employee is different. You tell them what matters to you, explain how you like things done, and give them access to the right systems, and they just handle it. They're not going to wait for you to prompt them every morning. They don't forget what you told them last week. They just work, and that's a shift that OpenClaw makes possible. The numbers on the screen reflect how seriously people have taken this. 24/7 runtime, 35 plus providers, over 300,000 GitHub stars. This is not a niche experiment anymore, but this is where serious builders are spending their time. OpenClaw has 4 layers stacked on top of each other in a specific way. Understanding each one is the key to understanding how this whole thing works. Layer 1 is our gateway. It's the daemon, it's the long-lived background process running on your machine or server. Everything goes through it. It listens on port 18789, manages the agent runtime, it's going to handle the heartbeat scheduler and own the WebSocket connections to every channel that you've set up. You can think of it like the brainstem. It doesn't think because that is the AI model's job. Everything that flows into and out of the system passes through it. Okay, layer 2 is channels. How you communicate with your agent. So think like WhatsApp, Telegram, Discord, iMessage, Slack. Every message you send on any platform routes through the gateway. The agent doesn't care which channel the message came from. Layer 3 is the memory and soul. This is the workspace directory on a disk with 7 files that define your agent's entire existence. Who it is, what it knows, how it behaves, what it does automatically. Everything is a plain text file. Nothing is hidden in a database that you can't access. So there's total transparency and total control. Now our 4th layer is tools and skills. This is how your agent interacts with the real world. Think like browser automation, shell execution, web search, file system access, can access Gmail, calendar, and a growing marketplace of community-built skills. Tools are how your agent goes from answering questions to actually doing the thing. Every day of this bootcamp maps to one or more of these 4 layers, so keep them as your reference point throughout. All right, now check out this diagram on the screen. At the top, you've got your channels. You've got WhatsApp, Telegram, Discord, iMessage, web chat, all pointing down to a single box in the middle. It's the gateway. This one process handles all incoming messages from every channel, routing them to the agent runtime, managing the heartbeat scheduler, and then streaming responses back out to wherever they need to go. Everything flows through it. Now below the gateway, you've got the subsystems that it manages. These are the memory, the tools, the workspace files, and the heartbeat scheduler. These don't run independently, and they're all orchestrated by the gateway. Now at the bottom, you've got the AI models. Claude, GPT-4o, Llama 3, Gemini, all completely interchangeable. The gateway calls whichever one you've configured, passes it the conversation context, along with the relevant workspace files, gets a response, and then can route it to the right channel. The thing that matters the most here is that you start the gateway once, it can run forever. You don't open an app because the gateway is just always there, always listening, and always ready. That's what makes the whole system persistent. Channels are one of the things about OpenClaw that people consistently underestimate until they actually experience it. The idea is simple. You shouldn't have to go to a special app to talk to your AI. Your AI should be wherever you already are. WhatsApp has a full DM and group chat support through the Bailey's protocol, and so you can use your actual WhatsApp number, not a separate account. Telegram is the absolute easiest to set up. You just create a bot token, paste it into your config, it's done in 5 minutes. Discord's going to give you server integration with mention-based activation. iMessage works natively on macOS. Slack and Mattermost are both supported for team contacts. There's also a built-in web chat interface at port 18789. And the iOS and Android native nodes give you full mobile support, including voice input, camera access, and location. On day 5, we're going to set up Telegram together live. You'll send your first message to your agent from your phone and get a real response back. And that moment is genuinely satisfying because it clicks that this is not just a demo, it's a real thing running on your machine, responding in the app you use every day. Memory is where OpenClaw gets really interesting and where it's the most different from every other AI tool out there. This system has 4 tiers and they are not all equal. At the top, you have T0. This is your sole memory, which includes your sole markdown file. Never changes unless you manually edit it. It's a bedrock identity of your agent, so who it is, what it values, how it talks, what it will and won't do. Always in context, no matter what the conversation is. Below that is T1. It's your core memory. This is your memory markdown file. So this is key facts you've either added manually or the agent has promoted from past conversations because they matter long term. These are things like your name, your time zone, your current projects, and your preferences. These are always in context as well. Then you have T2, which is your working memory. These are the daily log files, the recent conversations, and the tasks and context. This fades naturally over time as old logs scroll out of context, but for anything in the last week or two, the agent has full access. And finally, T3, which is session memory. This is the active conversation and it exists while you're talking, but it's cleared when the chat ends. But the top 3 tiers don't get cleared. T0, T1, and T2 persist across every session and every day. Days 9 or 10 are entirely dedicated to memory. For now, just know that it's file-based, searchable, and completely under your control. Tools are layer 4, and this is what takes OpenClaw from being a very good chatbot to being an agent that actually does things in the world. The browser tool gives your agent full browser automation, so you can do things like visit URLs, click buttons, fill forms, scrape content, and log into websites. If you can do it in a browser, your agent can do it in a browser. The exec tool is the most powerful one, and it's the one to think about the most carefully. This is where real shell commands on your actual machine, they're not sandboxed and they're not simulations. We're going to cover the full safety story on day 13 when we do Docker, but with this tool, your agent can do virtually anything a developer can do from a terminal. The web search is pluggable, so Brave, Perplexity, Gemini, or Grok, depending on what you prefer, and the file system tool lets your agent read, write, and organize files on your local machine or server. Gmail and Calendar connect via OAuth and give your agent real access to your actual inbox and schedule. And the Skills Marketplace is a growing library of community-built extensions. These include things like GitHub, Obsidian, Notion, Spotify, server health checks, and database queries. Days 11 and 12 are dedicated to tools and integrations. That is when things are going to get. Now, real-world use cases. These are 5 real things people are actually building and running with OpenClaw right now. The morning briefing agent is the most common one and the one I described when starting out this video. You define the task in the heartbeat markdown file that runs every morning, and so your agent's going to check your calendar, pull relevant news, grab the weather and summarize important emails, and then send that all to Telegram or WhatsApp before you're even out of bed. You set it up once and you never have to think about it again. The personal memory vault stores every conversation, idea, and decision in structured searchable files, so you can ask your agent, what did I decide about pricing back in January? Going to find it. Genuinely useful in a way that no chat interface can replicate. The Inbox Zero Manager can read your emails via the Gmail skill, categorize them by urgency, draft responses for the ones that need replies, and give you a clean daily summary of what actually needs your attention. So you get 200 emails down to the 5 things that actually matter. The Dev Assistant is for the developers, so you can send WhatsApp a message like fix the bug in the auth module and push it to staging, and then your agent writes the code, runs the tests, commits it to Git, and then it's going to deploy it. It's a real workflow that real people are running today. Then you have the research engine, which searches the web overnight, reads through relevant pages and papers, pulls the key findings, and then saves a structured summary to your Obsidian Vault. You can wake up with a complete research brief your agent put together while you slept. And so you'll have everything you need to build all 5 of these by day 16. Who is this for? If you're a developer, OpenClaw is one of the most powerful things you can add to your workflow right now. The exec tool alone is transformative. You can literally deploy code from your phone, automate your development workflow, and hook into any API through a custom skill, and so the ceiling is very high. If you're a professional or entrepreneur who doesn't write code, this is still very much for you. The Gmail skill, calendar integration, or the heartbeat briefing system, none of those require a single line of code. You can configure them in plain English in Markdown files. If you can write an email, you can configure these tools. If you're someone obsessed with AI who wants to go as deep as possible on how autonomous agents actually work, this is the most hands-on exploration of that topic that you're going to find. Multi-agent systems, local LLMs, and the full SOL architecture is all in here. And if privacy is a serious concern, OpenClaw can run entirely offline on your own hardware with free local models through Ollama. Your conversations never leave your machine, and you don't need API keys or any subscriptions. Whoever you are, there's a version of this setup that works for your situation. Now the prerequisites. So you need Node.js version 22.14 or higher. 24 is recommended if you're installing fresh. We installed this together at the start of day 2, so don't worry about it right now. You're going to need an AI API key from at least one provider, like Anthropic, OpenAI, and Google. They all have free trial credits when you sign up. If you want the fully free route with the local models, day 3 covers Ollama setup completely. You need Mac OS, Linux, or Windows with WSL2. And if you're running on Windows, set up WSL2 before day 2. Literally, a one-time setup makes everything significantly smoother. And if you need a code or text editor, you'll see me using anti-gravity, but VS Code is perfectly fine because most of what you'll do in this bootcamp is editing Markdown files. So that's the complete list. There's no prior AI experience required. A laptop and an internet connection is literally everything you need. Here's a preview of what day 2 actually looks like because I want you to see how accessible this is. Literally takes 4 commands. That's the entire install. You run the curl command to pull down the install script. You run the onboard wizard with the install daemon flag, and it walks you through a 2-minute setup. You run the gateway status command to confirm everything is running. Then you open your dashboard. That's it. After those 4 commands, you have a live running OpenClaw agent with a web interface that you can talk to right in your browser. On day 2, we go through every step in detail, including what to do if something doesn't work, Mac, Linux, and Windows separately. By the end of tomorrow, every single person watching will have their agent running and will have sent their first message. The barrier to entry here is genuinely low, 4 commands and a 2-minute wizard. Now we're at the roadmap. So days 1 through 4 are your foundation. Day 1 is today, which is the mental model and overview. Day 2 is installation and your first live conversation. 3 is the AI models, so choosing between them, setting up free local models with Ollama, understanding the trade-offs. 4 is cost optimization, so you're not burning money on paid API providers, very important. Days 5 through 8 are the personality and behavior layer. 5 is the channels, so we connect Telegram and optionally WhatsApp. 6 is the workspace files, so every file in your agent's workspace and what it does. 7 is the soul markdown. We build your agent's identity from scratch together. 8 is going to be the heartbeat markdown file, your first scheduled automation, which is a morning briefing actually running. Days 9 and 10 are the full memory deep dive. 2 days for this. 4 to your system in practice, managing your markdown file effectively, and using advanced recall patterns. Days 11 through 12 are tools and integrations. So we're covering Gmail, Calendar, and the browser tool and the exec tool with proper safety practices. Days 13 and 14 are deployment, so Docker first, and then a VPS, so your agent runs 24/7, regardless of whether your laptop is open. Day 15 is agentic coding, so connecting OpenClaw to Claude Code, so your agent can write, test, and ship real software. And day 16 is multi-agent, so a team of specialized agents working together, delegating to each other, operating completely autonomously. Each day builds upon the one before it, stay consistent, and the progression feels very natural. There's 6 key things to lock in from today. 1 is OpenClaw is a persistent agent daemon, it can run 24 hours a day and act on your behalf with or without you present. 2, it works through the apps you already use. WhatsApp, Telegram, Discord, there's no new app required. Your agent comes to where you are. 3, every behavior is a file on the disk, a soul markdown file, a heartbeat markdown file, or a memory file. There's no black boxes, nothing is hidden from you, and there's total transparency. 4, the gateway, as I explained, is the brainstem. It's one process on port 18789 that orchestrates everything. 5, memory has 4 tiers, soul, working, core, and session. The first 3 persist forever, and only session clears between conversations. 6, OpenClaw supports 35 plus AI models, including completely free local models like Ollama. You are not locked into any company or any subscription. Hold those 6 things and you will have the complete mental model. Everything else in this bootcamp is just detail layered on top. Before we wrap up, I want to lock in the vocab because you're going to hear me say these terms constantly, and I'd rather you know exactly what they mean than have to guess from context later. The gateway is the heartbeat of the whole system. It's the daemon process running on port 18789 that everything else connects to. Channels plug into it, tools are managed by it, every AI call goes through it. When someone says spin up your gateway, they just mean start that background process. Everything else follows. Channels are how you talk to your agents, places like WhatsApp, Telegram, and Discord. The important thing to understand is that from the agent's perspective, they're completely interchangeable. A message is just a message. It doesn't matter where it came from. The soul markdown and heartbeat markdown file are the 2 files that define who your agent is and what it does when you're not around. Soul is the character, so the personalities, the values, and the hard limits, all written in plain English. Heartbeat is a schedule, so these are the recurring tasks that fire automatically whether you're at your desk or asleep. These two files together are what make your agent feel like it's actually yours. Skills are how the community extends OpenClaw. So Gmail, Obsidian, GitHub, and Spotify, all these things, someone has built a skill for it. You can add a few lines to your config, and your agent can use it. The marketplace is growing every single week. A node is any device you connect to the gateway to give your agent hardware access. Some examples of nodes are your phone, your laptop, and a Raspberry Pi. Your phone as a node means that your agent can see through your camera, hear through your mic, and know where you are. That unlocks a whole category of use cases. The workspace is a folder on a disk that contains all 7 config files defining your agent. And exec is the one tool we'll keep coming back to. It's the ability to run real shell commands on your real machine. It's the most powerful thing in the whole system. It's the one thing that requires the most respect. Now, I want to take this time to deal with 4 things I see come up constantly because getting these wrong will slow you down. The first is this is just ChatGPT wrapper. It's not. OpenClaw has no opinion about which model you use. Chat is one of the 35 plus options, and you don't even have to use it. You can run this entire system on a free local model with zero connection to OpenAI. The architecture is completely model agnostic by design. The second is I need to know how to code. You mostly don't. The thing that trips people up is that OpenClaw looks like a developer tool from the outside, but the actual day-to-day experience is editing plain English Markdown files. Your sole Markdown is not a config file in some programming language. It reads like a document you'd write to brief a new employee. The command line interface commands throughout this bootcamp are one-liners you can copy and paste. The third is giving an AI shell access sounds dangerous. It's a fair concern, and I'm glad people are asking it. Now, the answer is yes, and that's why we make sure to set it up with the right guardrails. Until then, your agent doesn't have exec commands. When we do enable it, you'll have a confirm flag requiring approval before any command runs, Docker sandboxing, and explicit permission scopes. So don't skip day 13. The fourth is, can I really run this for free, offline forever? Yes. Ollama runs entirely on your hardware, it's free, and models like Llama 3 and Qwen handle most personal agent workloads without breaking a sweat. If you don't want a single dollar going to an API provider, Day 3 covers that path completely. One thing before the homework. Everything from this bootcamp, every template, every example file, every config snippet is going to live inside the sprint. I'm not going to make you build things from scratch if someone has already built a solid version. Most of the sole markdown files, the heartbeat schedules, and skill configs you'll use are already inside there, ready to copy and customize. That's also where the rest of the people going through this bootcamp are going to be. When you hit a wall, and you will hit a wall at some point, everyone does, that's where you're going to go. It's free to join, the link is in the description. So 5 things before day 2, and none of them take long. First of all, go start the repo, then join the sprint and introduce yourself, tell people what you're trying to build, you'll get a warm welcome, then run the node version in your terminal, make sure you're at a good version, 22.14 or higher, and then you're ready. Anything else we can handle together on day 2. You want to grab an API key from Anthropic, OpenAI, or Google. All 3 give you free trial credits upon signup. This is so you can actually get through day 2 without spending anything. If you want to go fully free, you can do that on day 3. The 5th one is the only one that actually matters. You want to write down what you want your agent to do for you. Don't be abstract here, be specific. What happens every morning that you wish just handled itself? What do you spend time on that's important but not particularly interesting? And what would you delegate first? Write it down tonight. From day 5 onwards, everything we build is pointed directly at whatever you write down right now. I want to leave you with one final thought. The next wave of productivity isn't about using better AI tools. It's about delegating to AI agents. Those sound similar, but they are not. When you use a tool, you're still the one driving. You decide what to ask, you take the output and figure out what to do with it. And you do this every single time. An agent is different. You set up the right systems, you give it the context it needs, and the work gets done regardless of whether you're there or not. The agent is active, and so you're free to go do something else. That shift from user to delegator is what the next 15 days are about. By the time we're done, you won't just understand it, but you'll have made it. And that's day 1. Tomorrow we install OpenClaw, we get your gateway running, and we send our first real message to our agent. And I'm gonna walk you through every edge case for Mac, Linux, and Windows so nobody gets left behind. Every person watching ends day 2 with a live agent. This was remotely useful. Subscribe so you catch day 2. Drop a comment with your use case, which is the thing that you want your agent to handle the most. I read all of them and they directly shape what this bootcamp's going to cover. Everything's at school.com/sprint, and I'll see you tomorrow. Let's build. Day 1 was all concept. We covered what OpenClaw is, how the architecture works, and why it's different from every other AI tool you've seen. That foundation mattered, but if I'm being honest, day 1 exists to set up today. Today is where it all becomes real. I'm Aliraj, and welcome to day 2 of the OpenClaw bootcamp. By the end of this session, you're going to have an actual running AI agent on your own machine. It's going to be your own agent connected to a real AI model with Telegram set up, so you can pull out your phone, send a message, and get a reply back. That's the finish line for today. Now let's go build it. Here's exactly what we're covering today so you know what's coming. We start with getting Node installed because that's the foundation everything else runs on. Then we run the OpenClaw installer, which is a single command, followed by the onboarding wizard, which is where you actually configure the tool for the first time. After that, we get the gateway running, open the dashboard, and send your first message to confirm the whole stack is actually working. Then we go a layer deeper. We walk through the workspace files the wizard created for you, look at the config file and what each section does, and then do a proper Telegram setup from creating the bot all the way to pairing your personal account. We close with the errors that actually trip people up and the security habits worth building now rather than after something goes wrong. A lot of ground, but we move through it efficiently. So there's 3 concrete outcomes for today. This is what success looks like by the end of this. First, number 1, OpenClaw is installed and you have the gateway running. Number 2 is now you've had your first real back and forth conversation with your agent through the dashboard. And 3, Telegram is connected so you can reach your agent from your phone wherever you are. The pipeline at the bottom shows the exact sequence: install Node, install OpenClaw, run onboarding, get the gateway running, send the first message, connect Telegram. Each step feeds directly into the next. Don't skip or reorder anything. Quick 60 seconds to make sure we're on the same page before we get into the technical steps. OpenClaw is a persistent agent daemon. That phrase matters because it's what makes it different. It's not a chatbot that lives inside the browser tab and forgets everything when you close it, runs in the background on your machine continuously, and responds to you through whatever channels you connect to it. Telegram, WhatsApp, Discord, iMessage. The behavior of that agent lives in plain marked down files sitting on your hard drive. You open up a text file, you edit it, and the agent's going to change. The config is just JSON. There's no cloud dashboard and no vendor lock-in. What you do today is the foundation. Every session from day 3 to day 16 builds directly on top of what you set up in the next hour. All right, so before anything else, let's check if your machine is actually ready. Open a terminal right now and run node-v. That's the only check that matters. If it prints version 24 or anything above version 22.14, you're good to go and you can skip to the next slide. If you get a version older than that, or if the terminal tells you that the command isn't found, I'm going to walk you through installation for every platform over the next 3 slides. On Mac OS, you're going to need version 12 or higher of the operating system. Node 24 is recommended, and Homebrew is the fastest path to get it. On Linux, Ubuntu 20, Debian 11, and Fedora all work. And on Windows, native Windows via PowerShell is fully supported, and WSL2 is the recommended path if you want access to the complete feature set. In terms of the disk space, you're going to need about 500 megabytes, and you almost certainly have that. 3 ways to install Node on macOS, and all 3 actually work, so use whichever fits how you already work. The recommended path is Homebrew. If you don't have Homebrew yet, it's one command from brew.sh, and it takes about 2 minutes. Once it's installed, running brew install node gets you Node 24 automatically. That's the method the OpenClaw docs point to. Now, if you'd rather download it directly, go to nodejs.org, grab the LTS build, run the package installer, and you're done. It's totally valid as well. If you already use a version manager like FNM or NVM, run FNM install 24, then FNM use 24, and you're set. The NVM equivalent works the exact same way. One thing I want to flag is if you do go the version manager route, make sure it gets initialized inside your shell config file, either zshell rc file or your bash rc file. If that initialization line isn't there, the new terminal sessions won't be able to find the OpenClaw command after you install it, which is one of the more confusing things to debug because the tool is technically installed, but it's just not on your path. I'm telling you now so you don't spend 20 minutes on it later. After any of these methods, confirm it with node-v. You want to see version 24. On Linux, the right method depends on your distro. For Ubuntu or Debian, use node source setup script. Those 2 commands on the screen specifically pull Node 24 and install it through apt. This is the correct approach. Don't use the Node version that ships with your distro's package manager because those are typically years behind and won't meet the minimum version requirement. Now for Fedora, use sudo dnf install.js. Those work fine. Or use FNM the same way you would on macOS. If you go with FNM, you get one consistent command across every platform, like FNM install 24, FNM use 24. It's a good tool and it's worth adding if you don't already have it. One thing to watch for after installation is if you later see a message saying OpenClaw command not found, run npm prefix -g to find out where npm puts globally installed packages. Take that path, add /bin to the end of it, and then add that full path to your path variable in your bash rc. That's almost always the fix. Let me clear something up before we go any further because there's a lot of wrong information about this online. OpenClaw runs natively on Windows, You do not need WSL 2. Native Windows through PowerShell is a fully supported first-class path. If you're on Windows and don't want to deal with WSL 2, that's completely fine. But that said, WSL 2 gives you a richer experience and access to the complete feature set. So my practical recommendation is use WSL 2 if you can, native Windows if you can't or prefer not to. For native Windows, the fastest method is running winget install openjs.node.js.lts from PowerShell. Chocolatey works too if that's already part of your setup. Or grab the installer directly from nodejs.org. For WSL2, you want to open up PowerShell as an administrator, run WSL install, reboot, and then you get an Ubuntu environment. Inside that Ubuntu terminal, install Node directly through FNM, exactly the same way you would on Linux. One thing worth knowing is that the OpenClaw install script in the next step detects which environment you're running automatically. You don't have to configure anything separately. All right, at this point, Node is confirmed. Now we can install OpenClaw itself, and this is genuinely a single command. On macOS, Linux, or inside WSL2, the command is the curl install script you see on screen. It downloads and runs the official installer. On native Windows through PowerShell, you use the PowerShell version instead, which is also shown on screen. What either of these actually does under the hood is run npm to install OpenClaw globally, which is what gives you the OpenClaw command everywhere inside your terminal. There are other install paths if you have specific infrastructure requirements, like Docker, Nix, or just running npm install directly, but the script handles edge cases automatically, and it's the fastest way to get running. After it finishes, you want to run OpenClaw -- version to confirm that it worked. You should see a version number printed. If you see command not found instead, that's a path issue and it's covered on the troubleshooting slide. This is a step that trips a lot of people up, and I want to get very clear about it. The installer you just ran and the setup wizard are two completely separate steps. Installing the binary does not configure it. You have to run the onboarding wizard separately. The command is OpenClaw onboard with the install daemon flag. The install daemon flag is what registers the gateway as a background service on your system, so it starts automatically every time you log in. You want that behavior, so make sure to include the flag. The wizard walks you through 4 things in sequence. First, model selection and authentication. You pick which AI provider you want to use and paste in your API key. We cover exactly how to do that on the next few slides. Second is workspace setup. The wizard sets the path for the workspace, which defaults to a folder called workspace inside the .openclaw directory inside your home folder, and it creates all the starting files you need, like Sol, Agents, and user markdown files, as well as everything else. Third, there's channels. So the wizard will offer to connect Telegram, WhatsApp, or Discord right now. You can do it here or skip it and come back to it later. For today, I'd suggest skipping it because we walk through Telegram properly as its own dedicated step later in the session. Fourth and finally, the daemon installation and health check. The wizard registers the gateway as a service and then runs a live check to confirm everything is working correctly before it exits. The whole thing takes somewhere between 2 and 5 minutes. The wizard is going to ask you which AI provider you want to use. Now let me give you a real framework for thinking about this rather than just giving you all the options. For most people just starting out, Claude Sonnet from Anthropic is the recommendation. It has the strongest reasoning, writing, and coding performance of anything currently available, and for light daily use, costs just a few cents a day. That's generally not a meaningful expense, but if you're already heavily embedded in the OpenAI ecosystem and you have a paid account, GPT-4o is also a solid choice. It's particularly strong at vision and multimodal tasks. If you're thinking about using OpenClaw for a lot of automated background tasks that run frequently, Gemini 1.5 Flash from Google has a very low cost per token. It's worth considering if volume is a factor. And if you don't want to use any external API at all, Llama lets you run models like Llama 3 and Qwen entirely on your own hardware with no API calls and no monthly cost. Day 3 is entirely devoted to Llama, so if that interests you, then hang on. The important thing to know is that you are not locked into whatever you pick right now. You can switch providers anytime you're running OpenClaw configure again, or by just editing the config file directly. Just pick something and then get moving. So what is an API key? An API key is your credential with the AI provider. When your agent sends a message to Claude or GPT-4 or Gemini, the API key is what tells a provider who you are and whose account to bill. Think of it like a password that authorizes your usage. 3 key things worth understanding here. First, it's your key, so it's your bill. You pay the provider directly, there's no markup or middleman. Anthropic's going to charge you, or OpenAI charges you, based on how much your agent uses their model. Second, your key stays on your machine. When you paste it into the onboarding wizard, it gets stored inside a credentials folder inside the .openclaw directory. It's not going to leave your machine. It doesn't get sent anywhere else, right? Third, free tiers do exist. Both Anthropic and Google, I believe, do give free credits on new accounts, and you don't need a credit card to get started on either platform. Ollama is also always free. One security point that is a non-negotiable here, you want to treat your API key exactly like a password. Don't paste it into a chat, don't put it in a screenshot, don't ever commit it to a Git repository. If you accidentally expose one, go to the provider's console and rotate it immediately. If you're going with Anthropic, here is the exact process. Step 1 is you want to go to console.anthropic.com, create an account if you don't already have one. New accounts get free credits with no payment method required to get started. Step 2, click Get API Keys in the left sidebar and then click Create Key. You want to give it a name like OpenClaw so future you knows what it's for when you're looking at a list of keys 6 months from now. Step 3 is copy the key immediately after it's created. You can start with sk-ant. This is the only moment you will ever see the full key. If you close that page without copying it, you can't retrieve it again, and you'll have to create a new one. Step 4 is go to billing and then set a monthly spending limit before you do anything else. $5, $10 is a reasonable starting cap. The reason this matters is if a heartbeat task ever gets into a loop or runs more than you expected, this cap is what keeps you from seeing a surprise bill. It takes 30 seconds to set. Step 5 is when the onboarding wizard asks for your API key, just paste that in there. That's the only place it needs to go. If you're going with OpenAI, the flow is platform.openai.com, sign in, click API keys on the left sidebar, create a new secret key. The key is going to start with SK, copy it immediately and make sure that you add a payment method and set a usage limit in the billing settings. If you're going with Google Gemini, go to aistudio.google.com, click Get API Key in the top navigation, create a new key. Last time I checked, the free tier was pretty generous for personal use. The key is going to start with AIZA, copy it before you close the page. You only need one key, so use whichever one matches the provider you chose during onboarding. If you decide later that you want to switch providers, you can run OpenClaw configure and swap it out. We're also going to look at the config file in a few slides, which is another place you can make that change. Onboarding is done. Now let's understand the gateway because this is the process you'll be coming back to constantly. If you included the install daemon flag when you ran onboarding, the gateway is already registered as a background service and it started automatically. You don't need to do anything manually at this point, but here are the commands you need to have ready. To start the gateway manually, just run OpenClaw gateway. To register it as a service that starts automatically on login, run OpenClaw gateway install. To check whether it's currently running, check run OpenClaw gateway status. To open the control UI dashboard in your browser, run OpenClaw dashboard. And to see recent logs, run OpenClaw logs. The gateway runs on port 18789 by default, and the dashboard is only accessible at that address on your local machine. It's not exposed to the internet, which is exactly how it should be. We talk about why that matters later during security. When you run OpenClaw gateway status, the slide shows you what a healthy output should look like. Let's read through what you're looking for. You want to see two specific things: port 18789 in the bind line and runtime running. That combination tells you that the gateway process is up, the dashboard is accessible, and your agent is ready to receive messages. Two things that indicate a problem here. If you see runtime unknown, the process isn't running. Start it with OpenClaw gateway or register it as a service with the OpenClaw gateway install. If you see missing config, it means the onboarding wizard didn't complete properly. Run OpenClaw doctor and it'll tell you exactly what step was missed. That line that says service launch agent loaded means the daemon is registered as a system service. On macOS, it uses a launch agent. On Linux, it uses system.md. On Windows, it uses a different mechanism, but the status output looks the same regardless of the platform. When something looks wrong and you're not sure why, the first command to run is always OpenClaw doctor. Checks every dependency, every config value, and every running service, and tells you in plain language what's wrong. Run OpenClaw dashboard and your default browser opens to the control UI. This is your primary interface for everything OpenClaw is doing. The sidebar on the left is your navigation. Let me walk you through each tab so you know what's where. Chat is where you have your conversations with your agent. You get the full message history, streaming responses as they come in, and tool call logs appearing in line so you can see exactly what the agent is doing behind the scenes. Sessions show your conversation history across all past chats, usage stats per session, and a search function. Heartbeat is where you monitor your scheduled runs. You can see the output from last run, the countdown to the next one, and you can pause or resume the heartbeat from there. Memory lets you browse what your agent has stored about you and search across the memory files. Tools show which tools are currently active and has a log of recent tool calls. Skills is where you manage installed skill packs. Channels shows connection status for every channel you've configured, like WhatsApp, Telegram, Discord, and others. Config lets you edit the main config file, either through a form UI or directly as raw JSON, and the changes apply automatically without a restart. Spend a couple minutes just clicking through these tabs before we move forward. Familiarity now will pay off later. Go to the chat tab. This is where we actually confirm that the whole stack is working end to end. Send 3 messages in this order and don't skip any of them. First message is hello, what's your name, and what can you do? This is your baseline test. If you get a coherent response, it means the model connection is working, the agent started correctly, and successfully loaded the workspace files. Second message, search the web for today's top AI news. Watch what happens in the chat window. Before the agent gives you an answer, you'll see a tool call appear in line, showing you exactly what it did. That level of transparency, right? Being able to see the agent's actions as they happen is one of the things that genuinely separates OpenClaw from the other tools. Third message, tell your agent your name and where you live and ask it to remember it. Something like, my name is Adiraj and I live in LA. Please remember this. After you send it, click over to the memory tab in the dashboard. You should see a file there with today's date that contains what your agent just stored. That's the memory system working on its first run. If all three of those work, your installation is complete. Everything is talking to everything else the way it should. Let's walk through what's actually in there because those files are where you'll spend most of your time in this bootcamp. Soul defines your agent's persona, tone, and boundaries. It's loaded at the start of every single conversation. This is what makes your agent sound like an agent rather than just a generic assistant. The agent's markdown file contains the operating instructions, so the rules, priorities, how the agent should handle different situations. It's also loaded every session. User is the information about you specifically, so who you are, how the agent should address you, the context that helps it serve you better. Identity holds the agent's name, emoji, and overall vibe. This gets created during the bootstrap process when you first run onboarding. Tools is a notes file about your tools and conventions. It describes things but doesn't actually control which tools are available. Heartbeat is an optional short checklist your agent reads during scheduled heartbeat runs. More on that in the next 2 slides. The memory folder contains daily log files, named by date, 1 per day, append only. This is where you'll remember this message from the previous slide just landed. The memory markdown file is an optional curated long-term memory file for private information you want available during sessions. The boot markdown file is an optional startup checklist that starts every time the gateway restarts. You want to keep it very short. One thing that catches people off guard is that your main config file and your API keys are not in the workspace. The config is a file called openclaw.json, and the keys are sitting in a credentials folder, both directly in the .openclaw directory, one level above the workspace. Those are intentionally separate, and we're going to look at the config file right now. The config is a file called openclaw.json sitting in the .openclaw folder in your home directory. This is the master control file for how OpenClaw behaves, and it's worth understanding the structure. It uses a format called JSON5, which is basically JSON with 2 small improvements. You can write comments with double slashes, and you can use trailing commas. You can edit it directly in any text editor, use OpenClaw Configure for an interactive menu, or use the config tab in the dashboard. Looking at the structure on the screen, under Agents inside Defaults, you have the workspace path, the model configuration, and the heartbeat settings. The model field uses a provider/model name format. For Claude Sonnet from Anthropic, that looks like Anthropic/Claude-Sonnet-4-6 as a string. The heartbeat interval goes under the heartbeat.every, like 30M for every 30 minutes or 2H for every 2 hours. The channel section is where Telegram and the other integrations live. We look at the Telegram config in detail later. The gateway watches this file continuously and applies changes automatically when you hit save. Most edits don't require a restart at all. Never commit this file to a Git repository. It can hold credentials, so add it to your Git ignore. Your workspace files are safe to version control, but the config file is not. Out of everything in your workspace, the sole markdown file is the one file that has the most direct impact on your day-to-day experience with the agent, so let's spend a real minute on it. The sole markdown file is plain markdown. Your agent reads it at the start of every single conversation. It's how the agent knows how to present itself and what its limits are. Structure has 3 parts. A persona section that covers the agent's name, tone, and the general vibe, whether it should be direct and terse or warm and conversational, whether it should be casual or more formal. That's all configurable through what you write here. A communication style section covers how replies get formatted, when the agent should ask for clarification versus just acting. And the boundary section is where you put hard limits, things like what the agent will not do regardless of what's asked. The default sole markdown file that the wizard generates is functional but totally generic. It'll work, but it doesn't sound like anything specific. On day 7, we're going to rewrite it from scratch to match exactly how you want your agent to communicate. For today, all I want you to do is open up the file in a text editor, literally just read it. Start forming opinions about what you like and what you want to change. That preparation will make day 7 significantly more valuable. To open it, it's called soul.md in the workspace folder inside .openclaw. Any text editor is going to work. The changes take effect on the next conversation with no restart needed. The heartbeat is the file that gets the most misunderstood, and I want to clear it up now so it doesn't cause confusion later. The heartbeat.md is an optional guidance checklist. Your agent reads this file during a scheduled heartbeat runs. It's text for the agent to follow. It's not where you set the schedule, and it does not contain any scheduling configuration. The schedule lives in the config file in openclaw.json under the heartbeat.every field. That's where the 30M or 2 hours goes, not in this file. The content of this heartbeat file looks like what's on the screen. It's a short bullet list of instructions, something like check for any pending tasks in memory, or send a morning briefing if it's before 9 a.m., or stay silent if nothing needs attention. That's the right level of detail. And the most important thing that the docs say about this file is to keep it short. Every heartbeat run loads this file into the context window. A longer file means that more tokens are consumed on every single tick. If your heartbeat fires every 30 minutes, a bloated heartbeat markdown file compounds in cost very quickly. A few focused clear bullets is the right format. The heartbeat tab in your dashboard shows you the last run output and the countdown to the next one. You can pause and resume the heartbeat from there. Telegram setup has 3 steps. This is step 1, getting a token from botfather. Open Telegram and then search for botfather. The @ version, which is @botfather. There's only one and it has a blue verified checkmark next to its name. Send the /-newbot command to start the creation flow. Botfather will ask you for 2 things. First, a display name. This is what appears in the header in your chat. Call it whatever you want. Second, a username. This is the public handle people will use to find your bot. It has to be globally unique across all of Telegram, and it has to end with the word bot. Once you give it a valid name, Botfather will send you your bot token. It looks like a long string of numbers, a colon, and then a longer mix of letters and numbers. You want to copy that token before you close that conversation. Treat it exactly like a password. Anyone who has this token can control your bot, so don't share it or post it anywhere. That's step 1. Step 2 is add that token to your config. Open your openclaw.json file, the one in your .openclaw folder in your home directory, and add a channel section within the Telegram configuration shown on the screen. Bot token set to the token you just copied from Botfather, and the DM policy set to pairing. The last one controls who's allowed to message your bot, and we cover the pairing step right after this. There's 3 ways to actually make this edit. You can open the file in the text editor and add it directly. You can run OpenClaw configure for the interactive setup menu, or just use the config tab in the dashboard, which has a form UI for exactly this. There's no command called OpenClaw channels login Telegram. Telegram does not use an OAuth login flow like some of these other platforms do. The bot token JSON config is the entire setup process. If you've seen that command mentioned anywhere else, ignore it. You want to save the file and the change will apply immediately. The gateway is watching the config continuously. Step 3 is pair your own Telegram account with your bot. You want to make sure that the gateway is running, then open up Telegram, find your bot by its username, and then send it any message at all. Because you set DM policy to pairing, your bot's not going to respond to anyone whose account hasn't been explicitly approved. When an unrecognized account messages it, the bot replies with a pairing code and waits. That pairing code is what you're going to use to approve yourself. Go back to the terminal and run OpenClaw pairing list Telegram, and you'll see your pending request with that code. Then run OpenClaw pairing approve Telegram, followed by that code. After that, go back to Telegram and then send another message, and your agent's going to respond. That moment right there is genuinely worth a pause. That's your own AI agent running entirely on your own hardware, responding to you through an app that's already on your phone. It's your machine, your agent, and your data. Now on the access control side, the pairing codes expire after 1 hour, so don't wait too long after getting the code. The DM policy setting also supports allow list. If you want to specify a fixed list of allowed account IDs, and you can set it to open if you want anyone to be able to message the bot, and likewise disabled if you want to turn off direct messages entirely. Let's go through the errors that actually show up and the exact fix for each one. The address already in use error on port 18789 means something else on your machine is occupying that port. On Mac or Linux, run lsof-i:18789 to find which process is using it, then kill that process. Otherwise, you could change the gateway port setting in your config to something like 18790 and use that instead. If you get OpenClaw command not found, it's almost always a path issue. Run npm prefix -g to find where npm puts globally installed tools, take that output, add /bin to the end of it, and then put that whole path in your path variable in your shell config file, either in your .zshellrc or your .bashrc. Open a new terminal window and then try it again. A 401 authentication error means your API key is wrong, or there's extra white space around it. Rerun OpenClaw configure and paste the key fresh from the provider's console. Don't type it by hand, and double check for spaces at the beginning or end. If you see an error about the node version being too old, run node-v to check what you have. If it's below version 22.14, update with fnm install 24, and then reinstall OpenClaw with npm install -g OpenClaw at latest. A permissions denied error on npm usually means the global npm prefix has a permissions conflict. The fix is to switch to a user-owned location. So run npm config set prefix pointing to a .npm global folder in your home directory, and then add that to your folder's bin subdirectory to your path. And the universal first step whenever you see something you don't recognize is run OpenClaw Doctor. It's going to check every dependency, every config key, and every running service and tell you exactly what's wrong. You want to start building these habits now. Never commit OpenClaw JSON to Git. Add it to your .gitignore today, not when something goes wrong. Your workspace files, your soul, your agents, all of that is totally fine version control. The config file is not because it can hold credentials. Leave exec in confirm mode. By default, when your agent wants to run a shell command, it's going to ask for permission first. That confirmation step is not an inconvenience, it's a safety net between you and an automated process that has access to your terminal. We look at when and how to adjust this on day 13. Until then, leave it on. Keep DM policy set to pairing on Telegram. The pairing flow means that you manually approve each account. Anyone can find your bot's username, but only accounts you've explicitly approved get responses. Don't switch to open unless you fully understand what that means. Keep the gateway on localhost. Port 18789 is bound to your local machine only. Don't open it to the public internet. If you need to reach your agent from somewhere else, the right way is through an SSH terminal, not a public port forward. Set a spending limit with your AI provider. Every major provider has a monthly cap option. You want to set it to somewhere between $5 and $10 when you're first getting started. If a heartbeat task ever runs more than expected, that cap is what prevents that from becoming an unexpected charge. These are the commands you'll reach for constantly over the next 2 weeks. It's worth memorizing or at minimum bookmarking the slide. For Gateway, OpenClaw Gateway starts it manually. OpenClaw Gateway install registers it as a background service. OpenClaw Gateway status checks if it's running, and OpenClaw logs shows your recent log output. For the dashboard and chat, OpenClaw Dashboard opens the control UI in your browser. OpenClaw Chat drops you into terminal-based chat mode if you prefer that. For setup and config, OpenClaw Onboard is the full wizard, and OpenClaw Configure lets you update your configuration at any time without going through the whole wizard again. For Telegram pairing, OpenClaw Pairing lists Telegram, shows pending requests, and the OpenClaw Pairing approved Telegram, followed by the code, approves a specific account. For diagnostics, OpenClaw Doctor is your health check for everything, and OpenClaw Update upgrades you to the latest version. That's the core set. Everything else will come up naturally as we go deeper into specific topics over the next few days. 5 things before day 3, do not skip these. 1 is get to a working gateway status. Run OpenClaw Gateway status, and you want to see runtime running on port 18789. If it doesn't look right, then run OpenClaw Doctor and follow what it tells you. 2 is send those 3 test messages in the dashboard. Basic hello, a web search, and telling your agent something about yourself to store. Check the memory tab after the 3rd one to confirm it actually wrote something. 3 is connect Telegram and get a reply on your phone. You want to get the Botfather token, add it to the config file, pair your account using the pairing approve command, send a message, and then get a response. Do the full flow. 4 is you want to open the Soul Markdown file and the Agents Markdown file in a text editor and just read through them. You don't need to change anything just yet. Just read through them and start forming opinions. Day 7 is where we rewrite the Soul from scratch, and the more specific your ideas are going in, the better the result you'll get out. 5 is run OpenClaw Doctor and make sure that every check passes green. If anything fails, then copy the exact output and post it in the community at school.com/sprint. We'll get you the help you need on the exact same day. The next 13 lessons are built on top of what you do today, so don't move on without completing these. That's day 2. If you did the homework, you now have a real running agent. Most people who say they've tried AI agents have never actually gone this far. On day 3, we go deep on models and Ollama. OpenClaw supports more than 35 different AI providers, and we're going to look at what that actually means in practice when you choose one over another, and how to set up Ollama so your agent can run Llama 3 completely locally with no API at all. It's free, offline, running on your own machine. It's one of the most satisfying things in the whole bootcamp. Finish the homework and I'll see you on day 3. Welcome back. I'm Adhiraj, and this is day 3 of the OpenClaw bootcamp. By the end of this session, you'll understand every provider OpenClaw supports, know exactly which model to use for each type of task, and have Ollama running locally with a model that costs you nothing. Let's get into it. As always, I'm going to start off with a full picture of what we're going to cover today. We start off with why model agnostic matters as an architectural principle and what it means for you practically. Then we go provider by provider. So Anthropic's Claude models, OpenAI's GPT family, Google's Gemini lineup, and the Chinese models that are quietly rivaling the best American labs at a fraction of the cost. After that, we're going to shift gears entirely. We install Ollama, pull a local model, and wire it into OpenClaw. That's the hands-on portion for today, and it'll be pretty cool when you see your agent respond using a model running entirely on your own machine. We're going to close out with the hardware requirements, performance tuning, and then the cost-saving strategies that can cut your monthly bill by 70% or even more. There's homework at the end, so do it. Day 4 is about cost optimization, and it directly builds upon what you're going to set up today. So 3 outcomes by the time we finish. First, you're going to understand every model provider OpenClaw supports and what each one is actually good at. These are the real practical differences. Number 2 is Ollama is installed on your machine and a local model is responding to your agent. You'll have sent a message through the dashboard and have gotten a reply from something running entirely on your hardware. And third, you have a personal strategy for which model to use for which type of task. It's not going to be generic recommendations. These are going to be frameworks that account for your budget, your privacy needs, and what you're actually using your agent for. Now, quick recap to make sure we're building on the right foundation. On day 2, you installed OpenClaw and got the gateway running on port 18789. You opened the dashboard, sent your first messages, and verified that the memory system was working. You also connected Telegram through BotFiler and got a reply on your phone. Now what carries forward today is that your config file lives at the .openclaw directory inside openclaw.json. During onboarding, you set a model under Agents, defaults model primary. That model is what your agent has been using for every conversation so far. Today, we explore every other option available to you. By the end, you'll know how to swap between them with a single config change. Before we dive into the specific providers, I want you to understand why OpenClaw was built this way, because it's not a minor implementation detail. It's a strategic decision that affects your life as a user. OpenClaw's gateway sits between your agent and whatever model is doing the thinking. From the agent's perspective, it's going to send a request and get a response. Which provider handles that request, which specific model does that inference, that's all configuration. It's literally a line in a JSON file. Switching from Claw to GPT to locally running Llama model is one edit and a restart with no code changes and no workflow rebuilds. Now, why does this matter to us? Well, 3 reasons. First, there's no vendor lock-in. If Anthropic changes their pricing tomorrow, or even if OpenAI changes their terms of service, you can switch to something in 30 seconds. Your agent's memory, the soul, the skills, everything you've built stays exactly as is, only the brain's going to change. The second is intelligent routing. You can use different models for different types of tasks within the same agent. A cheap, fast model is going to handle your heartbeat monitoring. A powerful reasoning model handles complex analysis, whereas a local model can handle anything involving sensitive data. All can be configured on the exact same file. And third, for future-proofing. The AI model landscape is changing faster than anything else in tech or even the world right now. A model that's considered the best option today is going to get outperformed next month. Having your entire agent infrastructure locked to one provider is a liability. OpenClaw makes sure that your investment in configuration, memory, and skills is going to survive every model transition. Let me give you the full picture of what's available before we dive into each one. OpenClaw works with 4 categories of model providers: Anthropic, who are the creators of Claude, OpenAI, who made GPT, and Google with their Gemini family. And then we have the local models through Ollama. Ollama gives you access to over 100 model families running entirely on your own hardware. On top of those, there are Chinese models like DeepSeek, Kimi from Moonshot AI, and GLM-5 from GPU AI. These are delivering competitive quality at roughly 1/10 of the cost of the American providers, and that cost advantage matters a lot if you're running an agent with frequent heartbeat cycles. Now let's look at each one. Anthropic is where OpenClaw started. The name Claw in OpenClaw literally comes from Claude. That history means that the Claude integration is the most community tested and the most documented and the one with the fewest edge cases. As of March 2026, there are 3 current Claude models that you should know about. Claude Opus 4.6 is Anthropic's most capable model. It has a 1 million token context window, exceptional complex reasoning, and the most precise instruction following of anything in the lineup. The pricing is $5 per million input tokens and $25 per million output tokens. That's actually a significant drop from the earlier Opus models, which used to cost 15 and 75 respectively. Use Opus when the task is high value and the quality matters more than the cost. Things like complex analysis, nuanced writing, and sophisticated code generation. Now, Sonnet 4.6 sits right in the middle. So it's $3 input, $15 output per million tokens. It's the one I'd recommend for most interactive conversations. You get strong quality without paying the Opus premium. Run Sonnet for day-to-day conversations and reserve Opus for the hard stuff. And then we have Claude Haiku 4.5, which is the fast, cost-effective option. It has a $1 input and $5 output per million tokens. Despite this lower price point, Haiku performs genuinely well on structured tasks like data extraction, summarization, routine decisions, and following clear instructions. For heartbeat monitoring, where your agent is running the same type of check every 30 or 60 minutes, Haiku's cost to quality ratio is excellent. OpenAI has 4 models worth knowing about in the context of OpenClaw. GPT 5.4 just dropped early this month. It's their latest and most capable model. $250 input, $15 output per million tokens. It comes in standard, thinking, and pro variants. That's 33% fewer errors than GPT 5.2, which was already very strong. If you're picking an OpenAI model for complex reasoning or code generation, this is the current answer. GPT-5, which is the original version, was released last year in August 2025. It has $1.25 input, $10 output. Still available and still good, which is a pretty clever design choice. GPT-4o remains a reliable workhorse. $250 input, $10 output. It has strong general reasoning, provides reliable tool use, and also good code generation. Also, it's going to have a 120,000 token context window and multimodal capabilities that let your agent understand images through the vision skill. A lot of people are still running GPT-4o and getting great results. GPT-4o Mini is the budget option, and it's pretty good for what it costs. 15 cents input, 60 cents output per million tokens. That's roughly 16 times cheaper than 4o for tasks where you don't need frontier reasoning power. For heartbeat monitoring and structured automation tasks, Mini is hard to beat on the cost. Gemini 3.1 Pro is Google's latest flagship. It was released in February of this year, and it was specifically optimized for reasoning and agentic workflows. It has a 1 million token context window with adaptive thinking, meaning that it adjusts how deeply it reasons based on the complexity of what you ask it. On the Software Engineering Bench Verified, which is the standard benchmark for software engineering capability, it scored 80.6%. That's within a fraction of a point of Claude Opus 4.6. It's genuinely frontier class. Gemini 3 Flash is the speed optimized version. It gives you close to pro grade reasoning at a much lower latency and cost. If you're already in the Google Cloud ecosystem with Vertex AI, the integration is tighter than with other providers. One thing I want to be upfront about is that the Gemini integration with OpenClaw was contributed by the community, and it's generally considered more experimental than the Anthropic and OpenAI integrations. Those have just been battle tested for longer. It works, but I do recommend to test it thoroughly before running it in anything mission critical. 3 Chinese models have come up in 2026 that I want to draw some serious attention to. GLM5 from Jipu AI scored 77.8% on the Software Engineering Bench Verified. That's a 744 billion parameter model released under the MIT license, and its API pricing is $1 input, $3.20 output per million tokens. Compare that to Opus at 5 and 25. Then Kimi 2.5 from Moonshot AI hits 76.8% on the same bench. It has 1 trillion total parameters, but uses a mixture of experts architecture that only activates 32 billion per request. This makes it efficient enough to potentially run locally on high-end hardware. Then DeepSeek V3.2 scored 73% on the same bench and is frequently cited as the most cost-efficient option available. You can run 50,000 tokens per day with Claude, and that'll cost you $50 a month, whereas the same volume on DeepSeek is about $5. To put the software engineering bench numbers in context, Claude Opus 4.6 leads at 80.8%, GPT 5.2 is at 80%, and Gemini 3.1 Pro is at 80.6%. These Chinese models are within a few points of the best proprietary models in the world, and they're priced at just a fraction of the cost. For high-volume heartbeat tasks and multi-agent setups, that saving compounds fast. Now, what's the trade-off? Well, if you're in the US, you want to verify the latency to China-based API endpoints, and you want to check whether your use case has any compliance requirements around where that inference happens. So how do you actually decide? Here is a practical framework. For complex reasoning and analysis, which is the kind of task where you need the model to actually think carefully through something nuanced, the answer right now is GPT 5.4 or Claude Opus 4.6. These are just the front runners, and they justify their premium pricing for the work that actually matters. For heartbeat and background monitoring, where your agent is checking conditions and making routine decisions every 30 to 60 minutes, you want to run GPT-4o Mini or Claude Haiku 4.5. The quality difference for structured repetitive tasks is pretty much negligible, and the cost difference is enormous. For privacy-sensitive tasks like anything involving legal documents, health data, or financial analysis, or just any content you don't want leaving your machine, you want to use a local model. These are models like Llama or Mistral, and we're going to set that up in the next section. For code generation and debugging, GPT 5.4 and Claude Opus 4.6 are both absolutely excellent. For zero-cost deployments, Llama 3.170B running locally on high-end hardware gets you close to frontier quality with no recurring API charges at all. For multilingual tasks, Gemini 3.1 Pro has really strong international language support, and Qwen 2.5 through Ollama is excellent for Chinese and other Asian languages. So keep it simple and start with one model. Once your deployment is stable and you understand your actual usage patterns, gradually introduce model routing. The ability to do this without changing any code is one of OpenClaw's most practically valuable features. Let's put the numbers side by side so you can really see what's going on here. Claude Opus 4.6 is $5 input, $25 output per million tokens. Sonnet 4.6 is 3 and 15. Haiku 4.5 is 1 and 5. GPT 5.4 is 250 and 15. 4.0 is 250 and 10. And 4.0 Mini is 15 cents and 60 cents. And local models through Ollama surprise 0 and 0. No per token cost at all. It's literally just electricity, which for a Mac Mini running inference is roughly $1 to $2 a month. The numbers that jump out here to me are that the model selection matters enormously for cost. Running Claude Opus for 30-minute heartbeat cycles can generate significant monthly costs purely from automated background tasks. Switching to Haiku for those exact same tasks while keeping Opus for the interactive conversations where quality matters is where the savings are going to happen here. We're going to go deep on the specific strategy on day 4. One cautionary note is that a power user in the community reported burning through 180 million tokens in a few weeks after setting up aggressive heartbeat monitoring with an expensive model, and they did this because they accidentally created a feedback loop in their task config. With frontier pricing, that amounts to hundreds of dollars. And so the lesson here is set the spending limits with your API provider before you let your agent run unattended. Every provider offers monthly caps, so use them. Let me make this concrete with 3 usage patterns that you can actually relate to. First is the light user spending $5 to $15 a month. This is someone using OpenClaw for daily morning briefing, occasional questions throughout the day, maybe some light automations. You're probably running GPT-4o mini for most tasks, with GPT-4o for the complex ones. Heartbeats are going to run every 60 minutes, and if you already own the hardware that you're running it on, API cost is your only expense. Then comes a power user who's spending $30 to $60 a month. They have active heartbeat monitoring of servers, finances, and calendar. They have regular interactive use for work tasks, and they probably want to run Claude Haiku 4.5 for all the automated heartbeat work and Claude Opus 4.6 for the interactive conversations. The split between cheap model for automation and premium model for interaction is what's going to keep this reasonable. And then we have the fully local setup using Ollama, which is $0 in API costs. All you need is a Mac Mini with 16 gigabytes of RAM, running Llama 3.2 for everything. Your monthly cost is literally electricity, about $1 or $2, and the trade-off is that local models trail the frontier cloud models in just raw capability. This is especially on complex reasoning and nuanced writing. For a lot of use cases, that trade-off is absolutely worth it. Now, one thing worth emphasizing here is that OpenClaw itself is free and open source under the MIT license. There is no subscription needed to run OpenClaw. There's no freemium tier and no locked features. What you're paying for is the intelligence layer, and as you're about to see, even that can be zero. Let's talk about Ollama because this is where the day is going to get hands-on. Ollama is an open source tool for running large language models locally on your own hardware. Several tools exist for this, including running the Llama C++ file directly, LM Studio, and others. Ollama stands out for OpenClaw deployments for 3 specific reasons. First off, it's going to present an API that's compatible with OpenAI specification. That means that OpenClaw talks to Ollama using the exact same interface it uses for cloud providers. You don't need any special integrations here because the connection is literally one configuration change, which is what we're about to do. Second, the model management is dead simple. You run Ollama pull with a model name and it just downloads. You can run Ollama list and it's going to show you what you have. And then you can run Ollama run with a model name and then you're chatting with it. There's no manual quantization and no path configuration because Ollama is going to handle all of that for you. And third, performance is genuinely good. It's built on llama.cpp under the hood, which provides optimized inference with GPU acceleration. The speed difference between Ollama and a less optimized stack running the same model is measurable, and it's often 2 to 3 times faster in tokens per second. And the privacy story is absolute, right? When you use Ollama, there's 0 bytes of your conversation leave your machine. You don't need internet connection for your inference, and your data stays on your hardware completely. For lawyers, doctors, or financial professionals, or pretty much anyone handling confidential information, this is the requirement. Step 1 is install Ollama, and this is a 1-command process. On macOS or Linux, just open up your terminal and run the curl install script shown on the screen. It's going to download and install everything automatically. On macOS specifically, Ollama installs it as a menu bar application that manages the server lifecycle for you, so it starts and stops automatically. On Windows, you can download the installer from ollama.com, and Ollama is going to run as a background service on Windows with the same API, same models, and same port. After installation, verify with Ollama -- version, and you should see a version number. One thing to confirm here is Ollama starts an API server on localhost port 11434. You can verify it's running by hitting that URL with curl. If you get a JSON response listing out your models, the server is live and ready. If you don't, on Mac, check that the Ollama menu bar icon is active. On Linux, you might need to run Ollama serve manually in a separate terminal. Step 2 is download a model. So run Ollama pull llama 3.2 and wait for it to download. Llama 3.2 with 8 billion parameters is about 5 gigabytes. This is the model I recommend starting with because it hits the best balance of quality and resource requirements for most people's hardware. Now, once it's downloaded, you want to test it interactively by typing Llama run Llama 3.2 followed by a test prompt, something like hello, are you working? If you get a coherent response, then congrats, Llama is functioning correctly. While you're here, you might want to grab a couple of additional models to experiment with. You can do Ollama pull Mistral 7b instruct. This will get you Mistral's instruction tuned model, which is fast and good at following structured instructions. Ollama pull Phi4 mini latest will get you Microsoft's small model, which runs on very constrained hardware. You can run Ollama list at any time to see everything that you've downloaded. At this point, the API server should be live on localhost 11434 with all your models loaded and ready. Now let's connect it to OpenClaw. Step 3 is point OpenClaw at Ollama. So open up your config file, which is openclaw.json, and change the model primary field to Ollama/Llama 3.2. Then you want to add a base URL field pointing at http://localhost:11434. If you'd rather not edit JSON directly, just run OpenClaw configure and select Ollama as your provider through the interactive menu. It's going to write the config for you. After saving, restart the gateway and send a test message through the dashboard. If you get a response, then your agent is now running on a model that's entirely local. No API call went anywhere and no token was built to any provider. That response came from your own hardware. Now take a second to appreciate that. You now have a fully autonomous AI agent running on your machine, connected to Telegram, responding to your messages, and using an open source model that you control completely. Your hardware determines which models you can run and at what speed. A Raspberry Pi 5 with 8 gigs of RAM can run Phi4 Mini or Gemma 2P at 3 to 6 tokens per second. That's slow for interactive use, but functional for background heartbeat tasks where latency really doesn't matter. A Mac Mini M2 with 8 gigs of RAM runs Llama 3.28b at roughly 15 to 35 tokens per second, depending on the specific prompt and configuration. It's very usable for interactive conversations. A Mac Mini M4 with 16 gigs runs Quan 2.514b at 20 to 35 tokens per second. This is the configuration I recommend the most often for a dedicated, always-on AI appliance. The Mac Mini uses under 10 watts at idle, runs silently, and costs about $600 for the M4 base model. The hardware pays for itself against API costs within a single year. A Mac Studio M4 with 64 gigs runs Llama 3.1 70B at 15 to 25 tokens per second. It's near frontier quality and runs entirely local. A PC with an RTX 4090 and 24 gigs of VRAM runs the same 70 billion parameter model at 40 to 60 tokens per second with the right quantization. That's genuinely fast. Now the note at the bottom, the unified memory architecture means that the GPU and the CPU share the same memory pool. An M4 with 24 gigs can run a 20 billion parameter model with full GPU utilization. On a discrete GPU system with 12 gigs of VRAM, that same model wouldn't fit in a GPU memory at all. It's an actual architectural advantage for local inference. Now some performance tips. These are 4 things I prepared that meaningfully will improve your local model performance for OpenClaw use cases. First, you want to use Q5KM quantization when you have the choice. Quantization is how models are compressed to use less memory. Q5KM has roughly the quality of the full precision model at the speed of the most compressed version. It's pretty much the sweet spot. Second, you want to limit your context window size for heartbeat tasks. Local models get slower as the context window gets larger. For automated monitoring that doesn't need extensive conversation history, setting a smaller context window in the Ollama configuration will make each run much faster. Third, you want to keep Ollama running continuously. The first time you call a model after it hasn't been used, there's a 10 to 30 second loading period while Ollama loads the model into memory. Once it's loaded, the next calls end up being much faster. You want to set that Ollama keep alive environment variable to prevent the model from being unloaded between calls. This makes a massive difference in perceived responsiveness. And fourth, you want to reserve system RAM for the model. If you're running a large local model, close your memory-intensive applications. More free RAM means more of the model stays loaded in memory rather than being paged to the disk. This will dramatically affect your speed. The difference between a model running from RAM and a model partially swapped to disk is night and day. Now, here's a strategy that I recommend, and it's not all cloud or all local. It's a hybrid that uses each model type for what it's best at. For heartbeat tasks, you want to use a local model. These are structured repetitive checks that a capable 8 billion parameter model handles perfectly well. There's zero API cost for what is typically the highest volume source of token consumption for OpenClaw deployment. For sensitive data, you want to use a local model. These are legal documents, health information, stuff I covered previous in the video. You want to route to your local model regardless of those quality considerations, because that privacy guarantee of local inference is a true non-negotiable for this category. For complex interactive tasks like the stuff where you need the best reasoning available, use a cloud model. When you're asking your agent to analyze a complicated situation or generate nuanced code or even write something that needs to be genuinely good, route those requests to GPT 5.4 or Claude Opus 4.6. This pattern will get you the best of everything. Zero cost and complete privacy where it matters the most, frontier quality where it matters the most, and a monthly bill that is a fraction of what an all-cloud deployment would cost. Here are 4 strategies that you could use today. First off, you want to use cheap models for the heartbeat. This is the single biggest lever. Most automated monitoring tasks don't require frontier intelligence. Switching from Claude Opus 4.6 to Claude Haiku 4.5 for your heartbeat cycles takes your background cost from roughly $15 to $30 a month down to $3 to $5. 4.0 Mini is even cheaper. The quality difference for structured monitoring tasks is negligible. My next strategy is set the API spending limits immediately. Both OpenAI and Anthropic, and I'm sure Google, allow monthly caps. You want to set one at $5 to $10 before your agent starts running unattended. This is the thing that protects you from run rate costs if a task loops or if you accidentally configure something more aggressively than you had intended. Next, you want to extend your heartbeat interval. Going from 30-minute to 60-minute cycles cuts your background API usage by exactly 50%. For most monitoring tasks, checking every hour is totally sufficient. Ask yourself honestly, does my agent really need to check this thing twice an hour? And then we have strategy 4. You want to optimize prompt efficiency. Long system prompts and bloated memory files increase your token count on every single request. You want to periodically prune your memory files and tighten that system prompt of yours. This is housekeeping that will pay recurring dividends. Switching models in OpenClaw is absolutely trivial. There's 3 ways to do it. Through the command line interface, run OpenClaw configure and then select your new provider and model through the interactive menu, and it's going to rewrite the entire config for you. Through the config file directly, you want to open openclaw.json and change the model primary field. That provider is provider/model name. You want to save the file, and then the gateway picks up the change automatically, so there's no restart needed for most config changes. Now, through the dashboard, go to the config tab, and you can now use the form UI or the raw JSON editor, and the changes are going to hot reload. That's it, right? There's no migration scripts, no data exports, and no workflow changes. Just one field in a config file determines which brain your agent uses. Everything else stays the same. 5 things before day 4. Number 1 is you want to install Ollama and pull Llama 3.2. Run the install command for your platform, pull the model, and confirm it works by running Ollama run Llama 3.2 with a test prompt. You should see a response. 2 is you want to switch OpenClaw to use Ollama. Run OpenClaw configure or edit the config directly. Then set Ollama as the provider with Llama 3.2 as the model. Send a message to the dashboard and then confirm it responds using the local model. 3, you want to compare cloud versus local. So ask your agent the exact same question with your original cloud model and then with the local model. You'll notice differences in speed and in the quality of the response, and then take the time to think about which tasks you trust to each one. This is going to build the intuition you need for the hybrid strategy. 4th is you want to set a spending limit. So go to your API provider's console, whether that's Anthropic, OpenAI, or Google, and then set a monthly spending cap. $5 to $10 is a reasonable starting point, and you want to do this before day 4. And then 5 is check Ollama list and make sure that your models are there. If your hardware can handle it, try pulling one additional model that interests you. Mistral 7B Instruct if you want speed, Qwen 2.514B if you have 16 gigs of RAM and want better quality. Just experiment with it. That's day 3, and just think about where you were at the start of this session versus where you are now. You walked in knowing one model, the one you picked during onboarding, and you're walking out understanding the entire provider landscape with real pricing data, with software engineering bench scores that you can actually use to make decisions, and also with a local model running on your own hardware that costs you nothing. Your agent can now run on any model, cloud or local, free or paid, American or Chinese. You can switch between them with one line in a config file. That flexibility is not something that any other consumer AI tool will give you. On day 4, we're going to go deep on cost optimization. Now that you understand the models, we focus entirely on controlling what you spend. We cover 2-tier processing, heartbeat tuning, prompt efficiency, and strategies that will cut your monthly bill by 70% or more without meaningfully affecting the quality of your agent's output. And with that, I'll see you on day 4. Welcome back to day 4. I'm Adhiraj, and this is the OpenClaw bootcamp. Yesterday, you met every model provider that OpenClaw supports. You installed Ollama, ran a local model, compared cloud versus local, and built the mental framework for which model fits which job. That was the knowledge layer. Today, we turn that knowledge into money saved. We're talking about the difference between a $70 monthly bill and a $17 one, doing the exact same work with the same agent, same tasks, and same quality where it matters, just smarter configuration. Cost optimization is not about being cheap, it's about being intentional. Every token your agent sends costs something, and most people are paying 5 to 10 times more than they need to because they haven't thought about where those tokens are going. That will change by the end of today. We start with a core concept, 2-tier processing, using a cheap model for the background work, and a premium model for the things that actually need premium intelligence. Then we dig into the heartbeat math because that's where most of the money goes and most people don't realize it. After that, we tackle prompt bloat. Your system prompts and memory files are silently inflating every single API call, and we look at how to prune them. Then spending limits and monitoring, because even the best optimization doesn't help if you don't have the guardrails. We close with prompt caching, which is a genuinely powerful feature that most people don't know exists, and a final checklist that ties everything together. There's homework at the end that will actually save you money today. All right, so 3 things you're going to walk away with. First, a dual model configuration where your agent automatically uses cheap models for routine tasks and premium models for the conversations that matter. This is the single biggest cost lever, and we're going to set it up today. Second, a concrete understanding of exactly what you're spending and where. Not a vague sense that AI costs money, but specific numbers tied to specific behaviors in your configuration. Third, the ability to cut your monthly bill by 70% or more. That number sounds aggressive, but it's real. Most of the savings comes from one insight. Your heartbeat is probably running on a model that's 10 times more expensive than it needs to be. Quick foundation check. So on day 3, you learn the full model landscape. You install Ollama, pull Ollama 3.2, and send your first message through a model running entirely on your own hardware. You also set a spending limit with your API provider, which is going to be important context for what we're going to do today. The key insight from day 3 that carries forward is that model selection is the single largest variable in your monthly cost. Today, we're going to operationalize that insight. So here's what an unoptimized OpenClaw deployment actually costs. Take a typical setup. So ClawHub is 4.6 as your only model. You have the heartbeat running every 30 minutes. That's 48 heartbeat cycles every day. Each cycle uses roughly 1,000 tokens for the prompt and 500 tokens for the response. Now let's do the arithmetic. Input cost is 48 cycles times 1,000 tokens times $5 per million. That's 24 cents per day on input. Output cost is 48 cycles times 500 tokens times $25 per million. That's 60 cents per day on output. Total comes to 84 cents per day just for the heartbeat. Over a month, that's $25.25, and that's before you've even asked your agent a single question. If you add an interactive use, let's say 20 messages a day, averaging 2,000 tokens each, and you're looking at another $45 to $50 a month. Total lands around $70, and most of that is going to background tasks that you don't need a frontier model for. That's the problem, and now let's fix it. Before we optimize, you need to understand what you're actually paying for, because tokens is an abstraction that hides important details. Every API call has 2 costs. The input tokens are what you send, so that's your system prompt, the conversation history, any memory context, and your actual message. The output tokens are what your model gets back. So output tokens are always more expensive, typically 3 to 5 times the input price. Your system prompt and memory context gets sent with every single request. For heartbeat running 48 times a day, that's 144,000 overhead tokens per day that have nothing to do with the actual monitoring task. And this is why prompt efficiency matters so much for agents. In a normal chatbot conversation, the system prompt is rounding error, but in an agent running automated cycles every 30 minutes, it's the main cost driver. The idea is simple. Your agent has 2 types of work: background automation that runs on a schedule, and interactive conversations where you're actively talking to it. These have completely different quality requirements, and paying the same rate for both is like taking a limousine to your mailbox. For the heartbeat and background tasks, you want to use a cheap model, something like Claude Haiku 4.5 at $1 input, $5 output, or 4.0 Mini at 15 cents and 60 cents. These models handle structured monitoring tasks like checking server status, scanning RSS feeds, reviewing calendar changes with more than enough capability. For interactive conversations, like the ones where you need the model to actually think carefully, you want to use Claude Opus 4.6 or Sonnet 4.6. The premium price buys you premium reasoning, and for these tasks, it's worth every cent. Now, the math is pretty dramatic here. The $25 monthly heartbeat cost on Opus drops to about $5.04 on Haiku. With the same checks, the same frequency, you get 80% savings. If you add in the interactive savings from using Sonnet instead of Opus for routine conversations, and then you're looking at a total bill that's a fraction of what you started with. Let's go ahead and set this up. So open up your config file at .openclaw/openclaw.json. Under Agents, Defaults, and Model, you already have the primary key from day 2 setup. We're adding a secondary key right next to it. Your primary stays as your premium model, something like Claude Opus 4.6 or that Sonnet 4.6, and your secondary becomes a cheap model like Claude Haiku 4.5 or 4.0 Mini. So the config looks like this, right? Under Agents, Defaults, Model, you have primary set to your premium model, and then secondary set to your budget model. OpenClaw will route heartbeat and background tasks to the secondary model and interactive conversations to the primary. You want to save the file and restart the gateway. From this moment, every heartbeat cycle uses your cheap model, and every time you message your agent directly, it can respond with a premium one. With just one config change, you've already saved a ton of money. Now let's put real numbers to this so you can see exactly what the two-tier strategy saves you. For a 30-minute heartbeat cycle, that's 48 calls per day. Assuming 1,000 input tokens and 500 output tokens per call, with Haiku at 1 and 5 per million tokens, that's an 80% reduction from just switching the heartbeat model. And the quality difference for something like check if my server is responding or scan my RSS feeds for keywords is negligible. These are structured, repetitive tasks, and Haiku can handle them perfectly. If you extend to a 60-minute heartbeat cycle, which is pretty sufficient for most monitoring, you cut the Haiku cost in half, down to about $2.52 a month for all your background automation. That's pretty much free. Here is the exact config for adjusting your heartbeat interval. In OpenClaw.json, under the Agents, Defaults, and Heartbeat, set the every field to your desired interval. The default from day 2 setup was 30 minutes, but for most users, 60 minutes is the sweet spot. You'll still get timely monitoring, and your agent checks everything once an hour, but you've cut your heartbeat API costs in half. Now think about what your heartbeat is actually monitoring. If it's server uptime, an hour between checks is fine. It's RSS feeds, news doesn't become stale in 30 minutes. It's calendar changes, your meetings aren't moving around that fast. Be honest about what frequency you actually need. Most people who run 30-minute heartbeats do it because that was the default, not because their use case demands it. Here's a cost driver that's completely invisible until you look for it. I'm talking about prompt bloat. Every time your agent makes an API call, it sends your full system prompt, the relevant memory context, and conversation history. If your sole markdown file has 3,000 tokens over time, as you've added those personality notes, instructions, and preferences, that's 3,000 tokens of input on every single call. For 48 heartbeat cycles a day, that's 144,000 extra input tokens daily. On Opus, that overhead alone costs 72 cents per day, or $21.60 per month, just from a bloated system prompt. On Haiku, it's 14 cents a day, or $4.32 a month, still significant. Now the fix is simple. Audit your sole markdown file periodically. Remove instructions that your agent has already internalized into its memory. You want to cut those verbose explanations down to concise directives. Every 100 tokens you trim is going to save you real money every day, compounded across every automated cycle. Think of it like this. Your sole.md is a tax on every API call, so you want to keep it as lean as possible. Same principle applies to your agent's memory files. OpenClaw's memory system accumulates context over time. That's by design, and it's how your agent gets smarter about your preferences and situation. But old, outdated memory entries still get loaded as context, and they cost tokens on every call. You want to run OpenClaw memory stats to see how much memory context your agent is carrying. If it's grown beyond a few thousand tokens, it's time to prune. You want to look for duplicate entries where the agent has learned the same thing twice. Also, you want to look for outdated information that's no longer relevant, or overly verbose entries that could be condensed. A memory entry that says a user prefers responses in bullet points format with technical details included and examples where possible, especially for code-related questions, can become just prefers bullet points, technical detail, and code examples. It's the same information, but much fewer tokens. Lean memory means faster responses and lower costs on every single interaction, whether automated or manual. Even with all the optimization in the world, you still need guardrails. You want to set spending limits before your agent runs unattended. On Anthropic's console, you want to set a monthly usage limit. When you hit it, the API calls will stop. Simple and pretty effective. You start it at $10 to $20 while you're learning. On OpenAI's platform, you can set a monthly spend threshold, and they'll email you when you cross it. OpenAI's spend limits are alert only. They do not guarantee a hard stop on API usage. Users have been charged well over their set thresholds. So don't rely on OpenAI's limit as a safety net the way that you can with Anthropic's hard cap. You want to monitor your usage actively and set the threshold at $10 to $15 initially so you can catch runway usage early. Both providers also offer per project API keys with individual limits. If you're running multiple agents or experiments, create separate keys so one runway process can't eat the budget for everything else. Let's put the full picture in one place so you can make informed decisions. Cloud Opus 4.6 runs $5 input, $25 output. It's the best complex reasoning available. You want to use it for high-value interactive tasks. Sonnet 4.6 is $3 input, $15 output, strong all around, and the best default for daily interactive use. Haiku 4.5 comes in at $1 input, $5 output. Excellent for structured automation. This is your heartbeat model. GPT-4o Mini is 15 cents input, 60 cents output. It's the budget king. It's even cheaper than Haiku for background tasks. Gemini 2.5 Flash Lite is 10 cents input, 40 cents output. It's Google's ultra cheap option, and it's worth testing for high volume automation. And then local, as we discussed yesterday, via Ollama is $0. It's free forever. Now the trade-off is capability, but for heartbeat tasks, a good local model is more than sufficient. Llama 3.2 comes in at 1B and 3B text models, plus 11 billion and 90 billion vision variants. The 3B is what you get with the Llama Pull, Llama 3.2, and it's pretty capable for its size. The pattern is clear. For background automation, you have options that are 10 to 50 times cheaper than frontier models, with negligible quality difference for structured tasks. Let me show you what all of this looks like in practice with a real before and after comparison. Before optimization, let's say you're running everything on Opus 4.6. 30-minute heartbeat, bloated prompts, the monthly cost comes to $70.80. That breaks down to about $25 in heartbeat costs and $45 in interactive use and significant overhead from prompt bloat. Now let's say you watched day 4, you took the tips from today and you implemented it. After optimization, you're using Haiku for the heartbeat, Sonnet for the interactive use, with 60-minute heartbeat intervals, a pruned sole markdown file, and memory. Your monthly cost drops to $17. Heartbeat falls to under $3. Your interactive use dropped because Sonnet is cheaper than Opus, and the per call overhead shrank because you trimmed your prompts. That's a 76% reduction with the same agent and same tasks, and same quality where it actually matters. You just stop paying premium prices for commodity work. Optimization isn't a one-time thing. You need visibility into what you're spending on an ongoing basis. OpenClaw gives you 2 tools for this. The dashboard has a cost tab that shows you your token usage broken down by model, by task type, and by time period. You want to check it weekly and look for patterns. Is one particular heartbeat task consuming disproportionate tokens? Is your memory context growing over time? From the command line, you can also run OpenClaw stats with a this month flag for a quick summary of your current month's usage. It's going to show you the total tokens consumed, the estimated cost by provider, and a breakdown of heartbeat versus interactive usage. You can then also set up Telegram cost alerts so your agent notifies you when you've hit certain spending thresholds. A message that says that you've used 50% of your monthly budget at mid-month is a lot better than a surprise bill at the end. Build a habit of checking your costs weekly for the first month. After that, once you understand your patterns, monthly is fine, but the first month is when you want to catch any misconfiguration or unexpected usage. Now, this is an advanced optimization and it can really reduce your costs if your agent is making repeated calls with similar prompts. Prompt caching lets the API provider store your system prompt and reuse it across calls instead of reprocessing it every time. Since your system prompt is identical on every heartbeat cycle, this is a perfect fit for agent workloads. Anthropic offers a 90% discount on cached input tokens. That's massive, right? You do need to add cache control markers to tell the API what to cache. There are 2 TTL tiers. You have a 5-minute cache that costs 1.25 times the base input price to write, and a 1-hour cache that costs 2 times the base input price to write. For heartbeat cycles, the 1-hour TTL is the right call. You pay more upfront to create the cache entry, but every heartbeat read within the hour gets the 90% discount. Over 48 cycles a day, the math is overwhelmingly in your favor. OpenAI handles caching differently. It's automatic with no markers needed. Any prompt prefix that's longer than 1024 tokens is going to get cached automatically. The discount is 50% on cache tokens, which is less aggressive than Anthropic's 90%, but requires absolutely zero configuration on your end. If your system prompt is 2000 tokens and you're running 48 heartbeat cycles a day, caching can save you the equivalent of tens of thousands of input tokens per day. On Opus pricing, that can be a lot of money. Here is your action checklist. Do all of these and you'll hit that 70% plus reduction. First, add a secondary model. Set your heartbeat to use Haiku or 40 Mini. That is the single biggest lever. Second, you want to extend heartbeat to 60 minutes. So change the every field in your heartbeat config from 30M to 60M. It's half the calls, thus half the cost. Third, you want to prune that sole markdown file. Cut it down to the essential directives only. Every token you remove is going to save money on every call. Fourth, you want to run OpenClaw memory stats and cleanup. Remove those duplicates, condense your verbose entries, and delete that outdated information. Fifth, you want to set spending limits on your API provider, $10 to $20 to start. Raise it when you understand the patterns. Sixth, you want to use the dashboard cost tab and check it weekly. Knowledge is power here. You can't optimize what you don't measure. And so that's it. There's 6 concrete actions. None of them reduce the quality of your agent's output for the tasks that actually matter. All of them reduce your bill. 4 things before day 5. First up, you want to configure the dual model setup. Add the secondary model key to your config, set the primary to your premium model, and the secondary to Haiku or 40 Mini. Restart the gateway and verify that both models are being used by checking the dashboard. Next, you want to change your heartbeat interval to 60 minutes. Update the heartbeat config to use every 60M. Confirm that it's working by watching the dashboard for a new cycle timing. Then audit your sol.md and your memory. Read through that sol markdown file and trim anything verbose or redundant. Run OpenClaw memory stats and prune the old entries. Then note how many tokens you've saved. Finally, you want to check your spending so far, so run OpenClaw stats this month and look at your current usage. Set a spending limit if you haven't already, and screenshot your current costs so you can compare after a week of optimized configuration. The goal is that by day 5, your agent is running the optimized 2-tier setup, and you have baseline cost data to measure against. That's day 4. So let's think about the progression for a sec. Day 1 was concepts, day 2 was installation, 3 was understanding the models, today was making them work for you economically. You now have an agent that's smart about how it spends, cheap model for the routine stuff, premium model for the real conversations with lean prompts, sensible monitoring intervals, and guardrails in place. The cost difference between an unoptimized and optimized OpenClaw deployment is pretty insane. We went from $70 to $17, and that's the difference between this is an expensive hobby and this costs less than Netflix. On day 5, we shift gears entirely. We're going deep on the channels. So Telegram, WhatsApp, Discord, iMessage, Slack, and the built-in web chat. Your agent is running an optimized. Now it needs to live where you already are. We connect every surface and cover security, formatting differences, and which channel to reach for in which situation, and I'll see you there. Welcome to day 5 of the OpenClaw Bootcamp. I'm Adhiraj, and today is the day your agent stops living in one place and starts living everywhere. So here's where we are. Day 1 was the big picture, so what your OpenClaw actually is, why it's fundamentally different from every other AI tool. Day 2 was hands-on installation, where you did the first message and that first Telegram connection. Day 3, you learned the full model landscape, cloud and local. Day 4, you cut your bill by 70% without losing any quality. Today is the payoff for all of that. Your agent's running, it's optimized, and now it needs to live where you already are. Not where it's convenient for the software, but where it's convenient for you. That means Telegram, WhatsApp, Discord, iMessage, Slack, and the built-in web chat. 6 services, 1 agent. Today you're going to connect them. Here's what we're covering. We're going to start off with the core concept of what a channel actually is and why the abstraction matters. Then we're going to go deep on Telegram, not just the day 2 basics, but the full feature set. Then WhatsApp, Discord, iMessage, Slack, and web chat. After the channel by channel section, we're going to look at security and access control. This is because a Telegram bot with no allow list is open to anyone on the internet who finds it, and that's both a privacy problem and an API cost problem. We're going to close with a formatting reference table, a channel selection guide so you know which surface to reach for in which situation, homework, and then a preview of day 6. So 3 concrete outcomes for today. First, at least 2 channels are going to be connected and working. They should be actually sending and receiving messages. Telegram you already have, so today you're going to add a second one. Next, a clear mental model of how channels plug into the gateway. This matters because all of your channels share the same memory, the same identity, the same model config, so understanding the architecture is going to prevent a lot of confusion when you're switching between services mid-conversation. And third, you're going to have whitelisting configured, so only you or whoever you explicitly choose can reach your agent. This is absolutely non-negotiable, and we're going to cover exactly how to set it up for each channel. Quick foundation check before we start building. On day 4, you set up the dual model routing. So that meant cheap model for the heartbeat and background automation, whereas you use the premium model for the interactive conversations. You also extended the heartbeat interval to 60 minutes, cutting the per cycle cost in half. You also set spending limits on your API provider dashboards and then enabled cost monitoring through the dashboard and the command line interface. The result from all of that was a deployment that went from roughly $70 a month to roughly $17. So you still have the same agent, the same work, but a dramatically lower cost. The reason that matters for today is that adding channels adds interactive usage. And so more channels means more conversations, and that means more API calls. But because you have that 2-tier setup from yesterday in place, that growth is manageable. And so now you're not paying these Opus prices for every quick question that you want to ask through WhatsApp. Before we go platform by platform, let's nail that mental model. Because if you actually understand what a channel is architecturally, everything else is going to make much more sense. All a channel is a messaging interface connected to your gateway. That's it. Your agent doesn't live in Telegram or Discord, but it lives in the gateway. And the gateway, all it is a process running on your machine or your server. Like Telegram, Discord, WhatsApp. Think of these as just doors into that gateway. They're adapters that translate between the platform's protocol and the gateway's internal message format. So here's what that actually means, right? Send a message on Telegram, the Telegram adapter receives it, converts it to the gateway's internal format, and then passes it on to the session manager. The session manager is going to retrieve your conversation context and memory, assemble that full prompt, and then call your AI model. The response comes back, goes through that Telegram adapter, and then arrives in your Telegram chat. WhatsApp, Discord, iMessage, all of these have an identical flow, but they just use a different adapter. Now, the big implication here is that all these channels, right, they share the same memory, the same soul, the same model configuration. If you switch from Telegram on your phone to Discord on your laptop mid-conversation, it's all good. Your agent's going to remember everything. Context is in the gateway, not in the channel, because the channel is stateless. All right, so full picture of what's available. Telegram is the absolute easiest channel to set up, free API, works on every platform, and it's the default first channel for most users, and the one most people end up keeping as their primary. WhatsApp has 2 billion active users worldwide, highest reach of any channel. OpenClaw connects to it via the Bailey's protocol. It's a linked device protocol, same as WhatsApp Web. You scan a QR code once and your agent's going to run as a linked device on your existing number. Then Discord is the choice for power users and mainly communities. So you can use slash commands, thread-based conversations, and server-level role gating. It's the best channel if you want to share your agent with a team or community. iMessage is macOS only. Your agent's going to respond through the native Messages app on your Mac. You just text your own number. It's going to require the Mac to be running, but if that's your setup, it's zero friction. Slack is a plugin-based workspace integration that uses Slack's Bolt SDK. It's ideal if you're in Slack all day for work, and socket mode means that there's no public URL required. WebChat is the built-in browser interface that you've been using since day 2 at localhost port 18789. It's already running, you've been using it. There's no extra setup needed here. You don't need credentials, and there's no link limits. Now let's make the architecture crystal clear. At the top, you have your channels. So you have Telegram, WhatsApp, Discord, and iMessage. These are the external services. Each one's going to connect inbound and outbound through its specific adapter. Those adapters all feed into that gateway at port 18789. Inside the gateway, we have 3 things here. You have the channel adapters themselves. You have the session manager, which tracks conversation context per channel. And you have the memory router, which loads relevant memory files from your sole markdown file and your memory markdown file. Below the gateway are the components that it calls out to. So those are the AI model, your memory storage, and your tools configuration. The key thing here is that the channels are at the top, not at the bottom, because they are inputs. Everything that makes your agent smart, like the model, the memory, and the tools, is in that gateway layer below. So channels are how you talk to the gateway. They don't change what the gateway knows. You already have Telegram set up from day 2, and so your bot token is in the credentials, the adapter is enabled in your config, and you've already been messaging your agent from your phone since then. So today we're going to go deeper. We're not going to redo that day 2 setup, but we're going to look at that full Telegram feature set. So there are 4 areas worth understanding over here: bot commands, group mode, media handling, and proactive notifications. Let's go through each one. First up is bot commands. You can register /commands with BotFather using the set commands command. You can define things like status to get a quick agent status, tasks to see your current task list, or briefing for a morning summary. Once these are registered, these will appear as autocomplete suggestions in the Telegram UI when users start typing a /. Commands enable you to create a much faster interaction pattern than typing full questions for routine checks. Next up is group mode and privacy mode. You can add your bot to a Telegram group, and this is useful for shared family or team accounts. Telegram's privacy mode is on by default for all bots, and in privacy mode, your bot only sees messages that start with that / command or actually mention the bot. OpenClaw does respect this, and so your agent won't interrupt every group message. It's only going to respond to commands directed at it and direct mentions only. Third up is media handling, so you can send photos, voice notes, documents, and locations to your agent. OpenClaw passes image data to vision-capable models. Voice notes are transcribed through Whisper before the agent processes them. Your agent sends back formatted replies with Telegram Markdown, inline keyboards, and file attachments, and this media support is bidirectional. And lastly, we have proactive notifications, and in my opinion, this is one of the most powerful parts of the Telegram integration. Your agent can send messages to your Telegram chat at any time, not just in response to you, and this is exactly how these heartbeat alerts, morning briefings, task reminders, and monitoring notifications are reaching you. So there's no polling on your end. The agent just pushes it directly to you. The Telegram config block in your openclaw.json is going to look like this. Under channels, Telegram, you have enabled set to true, bot token referencing your environment variable, and DM policy and groups. 2 things to note here specifically. First, you want to set that Telegram bot token environment variable, or use the token file config option to point to a file on disk. Either way, the literal token never goes in openclaw.json. Next up, second, the DM policy. The default is pairing, which means that unknown senders are going to get a short code, and the bot ignores their message until you approve them. You can run OpenClaw pairing approve Telegram with code in brackets to let someone in. To find your own user ID, just message your bot and then run OpenClaw logs -- follow and read the from.id field. Add that to allow from to allow list yourself directly. The 2 billion user channel. So WhatsApp is the channel with the biggest reach and the most setup friction. If you're in a context where everyone you want to reach is on WhatsApp, which is most of the world outside the States, this is worth the extra setup time. OpenClaw connects to WhatsApp through Bailey's, which is the same linked device protocol that WhatsApp web uses. You run OpenClaw plugins install at OpenClaw /WhatsApp, and then OpenClaw channels login -- channel WhatsApp, and a QR code appears in your terminal. You want to open up WhatsApp on your phone, go to settings, link devices, link a device, scan that code, and then you're connected. Then you want to run OpenClaw Gateway, and your agent is live on your existing number. Couple requirements here. You're going to need an existing WhatsApp account, whether it's personal or business, and a phone to scan that QR code. Now, what's going to work once you're all set up is text messages, images, documents, voice notes, and location sharing. The same proactive notification mechanism that Telegram has, where your agent can message you without being asked, is also on WhatsApp. The WhatsApp config block follows the same pattern as Telegram. Under channels, WhatsApp, you have enabled DM policy and allow from. DM policy defaults to pairing, same as Telegram, and unknown senders are going to get a code. Allow from is your E164 formatted phone number, +, country code, number, with no spaces or dashes. In terms of the setup sequence, you want to run OpenClaw plugins install at OpenClaw / WhatsApp, and then run OpenClaw channels login -- channel WhatsApp, and then scan that QR code that appears from WhatsApp on your phone under settings and linked devices. Just went over this. Then you want to run OpenClaw Gateway to bring that connection live. Now for the power users and communities, we have Discord. If you run a server, work on a team that lives in Discord, or prefer it as your primary messaging environment, this is the natural fit for you. Set up in 3 steps here. First, you want to create the bot, so go to discord.com/developers, create an application, go to the bot tab, and then add a bot. Copy that bot token. Then you want to set the scopes and permissions. So in OAuth 2 and then URL generator, select the bot as your scope. If you want / commands, also add applications.commands. Then in the bot permissions section below, you want to check the permissions that your bot needs. So send messages, read message history, embed links. Scopes and permissions are 2 different things in Discord's model. Scopes define what type of thing your OAuth token grants access to, like a bot is a scope, whereas permissions define what that bot can actually do within a server, so don't conflate them. Third, you want to invite that bot to your server. So use that generated invite URL from the URL generator to add your bot to your server. Copy your server ID from the Discord settings, and you're going to need developer mode enabled here. Once it's in your server, what do you get? You're going to get / commands with autocomplete in any channel, thread-based conversations, role-gated access, and multiple server support. One critical thing here is you want to enable that message content intent in the Discord developer portal under bot settings. Without it, your bot's not going to be able to read the message text and servers. It can only read DMs. It's off by default, and the bot will silently fail to process messages without it. The Discord config block is right here. You have the token DM policy and a guilds map keyed by the server ID. Your server ID is that unique identifier. So right-click the server name in Discord and select copy server ID, and you're going to need developer mode enabled first. Go to Discord, settings, advanced, and then toggle developer mode on. Inside the guilds map, each server entry lets you set a require mention, a user's allow list, a roles allow list, and a channels map where you control which channels the bot can respond in. By default, the guild policy is set to allow list, so the bot only responds where you explicitly allow it to. DMs use the same DM policy and allow from pattern as every other channel, and pairing is the default. iMessage is the most seamless channel if you're already in the Apple ecosystem. Your Mac is running and you have an iPhone in your pocket, all you need to do is text your own number. OpenClaw connects through the iMessage command line interface tool, and it uses the legacy approach, which is blue bubbles, which is the recommended option for the new setups. The gateway is going to communicate with the Messages app over JSON RPC. From your phone, it looks like you're just texting yourself. It is macOS only, and there's no equivalent on Windows or Linux. Your Mac needs to stay awake, so this works best for a Mac running as a home server. You're going to need to grant full disk access to the gateway process in system settings, privacy and security, and then enable full disk access. And this is just so it can read your whole messages database. The upside is that once it's configured, it's genuinely frictionless. You can open messages on your phone, see your own conversation thread, and your agent's right there. You don't need to switch apps, and there's no separate contact to remember. If your Mac is always on and you're deep in the Apple ecosystem, this is the cleanest mobile experience of any channel. Slack is the enterprise channel. If you're in a workspace or community where Slack is the default communications tool, having your agent there eliminates context switching entirely. The technical setup uses Slack's Bolt SDK as the adapter. You create a Slack app at api.slack.com/apps, enable socket mode, grab 2 tokens. You're going to need the app token, which starts with XApp, and the bot token, which starts with XOXB. Add both of those to your OpenClaw credentials, and socket mode connects outbound to Slack servers through a persistent WebSocket, and so no public URL is needed. The signing secret is only needed if you use HTTP events mode instead of socket mode. Slack will give you direct messages to your agent with an @mention in any channel. / commands become available workspace wide, and you get rich message formatting with the block kit, as well as the ability for your agent to post proactively to channels. One thing to be honest about here is Slack is best for work contexts where you are already in Slack all day. For personal use, Telegram is simpler to set up, simpler to maintain, and just has a better mobile experience. The complexity of the Slack setup is worth it when your team is already there. It's not worth it as a personal channel when you'd have to open Slack specifically to talk to your agent. So in Slack, you get direct messages to your agent, you get an @mention in any channel, / commands available workspace wide, and rich message formatting with the block kit. Also, you get the ability for your agent to post proactively to channels. Web chat is the channel that you've been using since day 2 without actually thinking about it as a channel. The dashboard at localhost port 18789 has a built-in chat interface. It has full markdown rendering with syntax highlighted code blocks, with file uploads, and no message length limits. It's already running, so you don't need to configure anything. The dashboard is also where you have that cost tab, the memory viewer, and the heartbeat log. Everything is there in one place for you. For long-term work, web chat is better than any mobile channel. You get a bigger screen, no length limits, and full formatting. The practical pattern that I've seen most people land on is Telegram for quick questions on the go, and web chat for anything that benefits from a full desktop interface. That combo covers probably 90% of agent interactions. One note on security over here is that web chat does bind to localhost 127.0.0.1 by default, so it's not reachable from other devices on your network. If you intentionally expose that port externally, you want to set a password in the config block. One quick note on security here is that web chat does bind to localhost by default. It's not reachable from other devices on your network, but if you do intentionally expose port 18789 externally, you want to set a password in the web chat config block. That's a choice that you're going to have to make. It's not going to happen by default. Here's what the full channels block looks like when everything is configured. Under channels in OpenClaw.json, you have each channel as a key. The pattern is identical, as you can see across all of them. You have the enabled Boolean, then channel-specific credential references and options. Telegram and web chat are enabled true in a fresh setup. Everything starts as false, and you enable them as you add them. Credentials should never be stored as literal strings in this file. You want to use those environment variables, the token file option, or secret ref providers to keep secrets out of the config. WhatsApp session credentials are stored automatically under OpenClaw credentials WhatsApp, and other channel tokens go through the environment variables or your secret provider of choice. Restart the gateway after any config change, and we do this because the gateway reads config at startup, and edits to OpenClaw.json don't take effect until you restart. You can absolutely run all 6 channels at once because your agent handles conversations from Telegram, Discord, and web chat in parallel. Each conversation is independent. And so here's what's shared across all your channels, right? You have your sole markdown file, which defines your agent's identity. It's the same everywhere. The long-term memory is in memory.md, is also the same. And the model configuration, which AI model you're using, is also the same. And as you can probably guess, heartbeat and schedule tasks are the same as well. Now, here's what's different per channel. You have the session context, which is the specific conversation history within a specific channel. The message format can be different because Telegram Markdown and Discord Markdown and Slack Markdown are different dialects, and the adapters handle translation. The media capabilities, like what each platform supports, are different, and the allowed user lists can be different. The cross-channel memory test in today's homework illustrates this directly. Tell your agent something on Telegram, ask about it on web chat, and you'll see that long-term memory transfers while the conversation history is separate. That's the architecture working as intended. Each channel has different formatting capabilities. The adapters handle most of the translations automatically, but it's worth knowing every single one so you can set appropriate expectations in your sole markdown file. Telegram is going to support full markdown, bold, italic code blocks, inline URLs, and spoilers. The character limit is 4096 per message, and the longest messages get split across multiple messages automatically. The WhatsApp formatting is its own dialect, so bold is asterisk, italics underscores, strike through is tildes. The inline monospace and triple backtick code blocks are both supported. The links are URL only, so no hyperlink text. WhatsApp does have a 4000 character chunk limit by default. Discord is going to support full markdown, including fenced code blocks with syntax highlighting. The messages are capped at 2000 characters, but these bots can send multiple messages for longer responses. iMessage is plain text, so no formatting supported. The links auto preview natively in the Messages app, and there's no hard character limit from the API side. Slack uses its own markdown format rather than using the standard markdown. The block kit provides rich formatting with sections, buttons, and structured layouts, and has a 40K character limit. Web chat has absolutely no limitations. It's full markdown syntax highlighting with no length cap. OpenClaw's adapters translate your agent's markdown output to the appropriate format for each channel automatically. You don't need to write channel-specific prompts, but you can instruct your agent in the sole markdown file to keep responses concise for mobile channels if you want. Beyond text, here's what you can send and receive per channel. Images work on Telegram, WhatsApp, Discord, and web chat. When you send an image to any of those channels, OpenClaw passes the image data to your primary model, and this is assuming that it's a vision-capable model like Claude Sonnet or GPT-4o. Your secondary cheat model is not used for vision tasks because most cheat models aren't vision capable. Vision always goes to the primary. Voice notes are supported natively on Telegram and WhatsApp. They're transcribed through Whisper before the agent's going to process them. Discord accepts voice note uploads, but web chat doesn't support voice currently. Documents like PDFs, text files, and code files work across Discord, Telegram, WhatsApp, and web chat, your agent can process and read those contents. Location sharing works on Telegram and WhatsApp natively, whereas Discord and web chat handle it as text only. The voice note workflow I think is particularly powerful. Say you're commuting and you have a question, you can send a 30-second voice note instead of typing. Your agent's going to transcribe it and respond as if you typed it out. So it's hands-free interaction on mobile. I want to spend a moment on security because it's easy to skip and the consequences are real. The default risk is that a Telegram bot or Discord bot with no allow list is open to anyone who finds it. Anyone who messages your bot is talking to your agent, which means they're burning your API budget and can potentially access whatever information that your agent has in its memory. This is a real risk because Telegram bots are discoverable by username. If your username is something like myagent_bot, someone can easily find it and start talking to it. The default DM policy is pairing, so unknown senders get a code and your agent ignores them until you approve. That's the right default. Don't change it to open on a public-facing bot. For Telegram, find your user ID by messaging your bot, and then running OpenClaw logs --follow, and then reading the from.id field. Add that to the allow from in your config to allow this yourself directly. For WhatsApp, the allow from takes E164 formatted numbers, +, country code, number with no spaces or dashes. For Discord, you have two options: the user ID allow list or server level role restrictions. Creating a role and restricting a bot's channel visibility to users with that role is the more scalable approach for a shared server. For iMessage, the channel is inherently private, so only your Apple ID can trigger the bridge to the Messages app, so you don't need an allow list here. The web chat's going to bind to localhost by default, and there's nothing to configure unless you expose it externally. Now let me give you a decision framework so you're not guessing which one to use. For quick on-the-go questions, you want to use Telegram. It's fast, works on every platform with reliable push notifications. If you're already living in WhatsApp, then use WhatsApp. There's no contact switching, and your agent is in the same app that you use for everything else. For long coding or research sessions, use web chat, so you get full markdown with no link limits, file uploads, and everything is visible for you in the same interface, your cost tab, and your memory viewer. For shared team assistant, you want to use Discord or Slack with role-gated access, thread support, and multi-user conversation management. If you're iPhone first and your Mac is always on, use iMessage. There's a native app, there's no bot account, and the texts are going to feel like you're texting yourself. There's zero friction once it's configured. Then for proactive alerts and briefing, use Telegram or WhatsApp. Both already deliver push notifications reliably on mobile. For heartbeat alerts, morning briefings, and task reminders, these all land better on a channel that your phone actively notifies you about. The combination that most people end up landing on is Telegram and WhatsApp. Telegram for mobile and web chat for desktop work sessions. Those two cover the vast majority of agent interactions. 4 things before day 6. First, you want to verify that your Telegram is secured. So message your bot, run OpenClaw logs --follow, and grab your from. Confirm that it's in allow from in your config, send a test message from your phone, and confirm the response comes back. This is just verification, but you should already have this from day 2. Second, you want to connect a second channel, so pick a channel that you don't already have, like Discord, WhatsApp, or Slack. Follow the setup steps for that channel, add the credentials, enable it in the config, restart the gateway, and then send your first message through it. Confirm that the response comes back correctly. Third, you want to test cross-channel memory. So tell your agent something specific on Telegram, like remember that I prefer bullet point summaries, and then open web chat and then ask it, what do you know about my formatting preferences? You should see the memory carry over, and this is what makes the architecture real. Memory lives in the gateway, not in the channel. Fourth, send a voice note. So on Telegram or WhatsApp, record a short voice note, like any question, literally any question you have, and then send it to the agent. Confirm that you get a transcription-based response back. This is how hands-free mobile interaction works, and it's surprisingly useful once you start using it regularly. That's day 5, and so here's where we are in the progression. Day 1 was understanding what OpenClaw is, day 2 was installation first run, day 3 was model landscape, day 4 was cost optimization, and day 5, today, was channels. You now has a voice on every channel that matters to you. You've built the infrastructure layer, you have a running agent, optimized costs, and it's reachable from anywhere. Day 6 is going to shift us from reactive to proactive. So up until now, your agent responds when you ask it something. On day 6, we teach you to act without being asked. The heartbeat markdown file is how you define what your agent checks on a schedule. Proactively, right? Whether you're online or asleep. Your channels are now the delivery mechanism for everything your agent will do autonomously. So finish your homework and I'll see you on day 6. Welcome back. This is day 6. I'm Adhiraj and you're in the OpenClaw bootcamp. Let me ask you something. When was the last time your agent did something useful without you asking it to? The answer is never, because up until now, it can't. You open up Telegram, you send a message, you get a response, and that's it. Close the app, and then nothing's going to happen. Your agent just waits. Today, we're going to fix that. You're going to write a single file called the heartbeat markdown file, and it's going to teach your agent to act on its own, on a schedule, proactively, whether you're around or not. Tomorrow morning, you'll wake up to a briefing that you never requested. Let's build it. Let's start out with the mental model like we always do. So first off, reactive versus proactive and why that distinction matters architecturally. Then the heartbeat loop itself, how the tick cycle works, and where the heartbeat markdown file fits inside it. Then the anatomy of the file. So what to write, what not to write, and the built-in silence mechanism that keeps your phone from buzzing every 30 minutes. After that, we cover the 4 real examples: morning briefing, a task queue monitor, system monitoring, and a daily research summary. We look at the time-aware instructions and how to write conditions that the agent actually understands. Then cost and safety, because a badly written file can get expensive fast. And finally, debugging, so how to read the heartbeat log and fix a setup that isn't firing. All right, so 3 concrete outcomes by the end of today. First, a working heartbeat markdown file that sends you a morning briefing automatically. It shouldn't be configured or waiting. It should actually just be sending it to you. And you're going to test it before you go to sleep tonight. Second off, a clear mental model of the loop. So the tick interval, file read, task execution, and channel delivery. You should be able to draw this on a whiteboard by the end of today. And third, a super lean file. So under 25 lines, so that doesn't burn tokens every tick. Leanness here isn't a stylistic preference, but it's cost and a reliability decision. All right, quick check on where we came from. So on day 5, you connected the channels. Telegram is secured with your numeric user ID, the allow list. At least 1 second channel is live and tested, whether that's Discord, WhatsApp, iMessage, or Slack. You verified that the cross-channel memory works, so something told the agent on Telegram shows up in web chat, and then you send a voice note and confirmed the transcription-based response. And here's why day 5 directly unlocks today, day 6. Your channels are the delivery mechanism for everything this heartbeat markdown file is going to trigger. When your agent sends a morning briefing, it's going to go through Telegram. When it fires an alert, it's going to route through whatever channel that you configure. Day 5 built the pipes. Day 6 is just what flows through. Before we touch any configuration, I want to make this mental model super crisp. It's literally the thing that's going to make everything else click. Days 1 through 5, your agent was reactive, so every interaction followed the same pattern. You initiate and your agent responds. You send a message, it replies. Nothing happens without you, and so the agent is always waiting. Day 6 changes that flow completely. So the gateway runs on a timer. Every 30 minutes or 60 seconds, this is whatever interval you set, then the tick will fire. On each tick, the gateway loads the heartbeat markdown file, hands it to the agent as the task context, and the agent decides what to do. If there's something to report, it sends it through your channels, and if there's nothing, it's just going to stay silent. So you're not involved, and you don't ever have to ask it when you do this. That's the difference between a chatbot and an autonomous agent. It's not a technical one, but it's an architectural one. It all comes down to this one file. Now let's make the loop super concrete with these 4 steps. Step 1, the timer is going to fire. The info is set in your OpenClaw.json under Agents.defaults.heartbeat in the every 30 minutes, 60 minutes, it's whatever you chose on day 4. It's just a clock ticking in the background. Step 2 is the gateway is going to read that heartbeat markdown file. It's going to load the file from this file path shown on the screen as the agent's task context for this tick. And the default prompt the agent receives is literally read heartbeat markdown file if it exists and follow it strictly. If nothing needs attention, reply heartbeat_OK. That's built in and you don't need to write it yourself. Step 3 is the agent's going to decide and act. So it evaluates the conditions in the file, calls tools if needed like web search or memory read or shell commands, composes a message if there's something to say, and then packages a response. Step 4, it's going to deliver through a channel. So if the agent decided to say something, it's going to route through whichever channel you specified in the target config. If it decided there's nothing to report, it's just going to reply with heartbeat OK, and the gateway strips that and drops it silently. There's no message sent, and no notification reaches your phone. Now there's the cost side of things. So you must set the model key in the heartbeat config to a cheap model like Haiku or GPT-4o Mini. Without an explicit override, the heartbeat uses your default agent model, which could be expensive. You also want to set light context to true and isolated session to true, and these are going to dramatically reduce the token load per tick. Light context keeps only the heartbeat markdown file from the workspace bootstrap files instead of loading everything. Isolated session is going to run each heartbeat in a fresh session with no conversation history. They can take you from 100,000 tokens per tick to 2 to 5,000. All right, now this is the most important distinction to get right before you start writing anything. OpenClaw.json controls when. The heartbeat block in your config lives in Agents.defaults.heartbeat. Here's what it looks like, right? So the every field is your interval. So 30 minutes or 60 minutes or 1 hour or 2 hours. The model field is the cheap model you're using. The target field is going to control which channel receives the output. You can set it to last for your last active channel, or a specific channel name like Telegram or WhatsApp, or none to suppress delivery entirely. Then there's 2 critical cost flags. light context true, and then isolated session true, and then ACK max charge at 300. This is how many characters the gateway allows after a heartbeat OK token before it decides to deliver the message anyways. One important thing here, the target defaults to none. That means if you don't explicitly set it, your heartbeat's going to run but send nothing. You need to set target to Telegram or Last, or whichever channel you want output delivered to. Don't skip this, or you'll wonder why your briefings never arrive. Also worth knowing here is there's an active hours block that you can add with start, end, and time zone fields. This lets you restrict heartbeat runs to specific hours, say 8 a.m. to midnight, so you're not getting alerts at 3 in the morning. You can also set the time zone to your IANA time zone like America, New York, so the agent isn't using your server's UTC clock. The heartbeat file controls the what. So the file is in plain English. You can throw bullet points in there, markdown headers, whatever structure works for you. The agents can read it as natural language instructions and decide which actions to take. The heartbeat file has zero scheduling power on its own. It's just a task list that gets read when the clock fires. A lot of people try to put timing inside their file, writing things like run every day at 8 a.m., and that works as a time condition that the agent evaluates, but the tick interval is always in the config. The heartbeat markdown file is where you write what to do when the interval fires, including the time conditions the agent can check using the current time. Now let me show you what the file actually looks like. It's going to live at OpenClaw workspace heartbeat.markdown. It's a markdown file, right? As you probably know already. It's short, it's plain English. You can use headers to group related tasks, bullet points for individual items, and also comments to remind yourself what things to do. One thing the doc support that's worth knowing is you can also use a structured tasks block with per task intervals. That looks like a YAML block at the top, with each task having a name, an interval, and a prompt. When you use this format, OpenClaw parses the block and only includes tasks that are actually due on a given tick. If no tasks are due, the heartbeat is skipped entirely, and there's no API call made at all, and that's the most cost-efficient way to run multiple tasks at different frequencies. But for most people starting out, plain English bullet points work perfectly. The agents can read them, evaluate each one, and act accordingly. Now, what belongs in here, right? Time conditions written as plain English, like if it's between 8 a.m. and 8:30. Also channel directives like send to Telegram, references to memory like check memory markdown file, conditional logic written naturally like if a task is overdue. You want to keep it under 20 lines, ideally under 15. Every word in the file costs tokens on every single tick, so bloated files are directly expensive. Now, what doesn't belong here? Scheduling syntax. Any kind of cron expression or interval notation is wrong here. That lives in your openclaw.json. Long paragraphs don't belong here. Tasks that require your real-time input do not belong here. And anything that your agent can't do autonomously with the tools you've given it do not belong here. One more thing. If the file is empty or contains only blank lines and headers, OpenClaw skips the heartbeat run entirely to save API calls. That's intentional, and so an empty heartbeat markdown file means nothing to do and costs you nothing. I want to spend a full slide on this because it's the mechanism that keeps your phone from buzzing 48 times a day. This is how it works under the hood. So the default heartbeat prompt already tells the agent, if nothing needs attention, reply heartbeat OK. You don't need to write this in your file. It's built into the system prompt that the gateway sends with every single tick. When the agent replies with heartbeat OK at the start or end of its response, the gateway strips that token out, and if the remaining content is under your ACK max chars, which defaults to 300 characters, the gateway drops the message entirely. So nothing gets delivered to your channel, and thus the phone stays silent. Now here's what happens without this system. The agent is wired by training to be helpful. When it receives the task context and evaluates the conditions, its default behavior is to produce a response, even if that response is, I checked everything and there's nothing to report. Without this heartbeat OK suppression, your agent would message you every 30 minutes, confirming that nothing happened. And so it's literally 48 minutes a day. Your phone would be buzzing constantly and you turn off your notifications. And then the moment you do that, your agent's alerts become invisible, including the ones that actually matter. Then you've broken your own monitoring system. With the heartbeat OK, the agent only reaches out when it has something real and important to say. The channels stay quiet, and so when a message arrives, you pay attention because you know that it's actual signal. That's the value, and here silence is the feature. You can actually go ahead and reinforce this in your heartbeat markdown file by adding a line at the end. If nothing needs attention, stay completely silent. The system already handles it, but the extra instruction doesn't hurt, and some people find that it makes the agent more reliably quiet. Let's build out the first real example. So the morning briefing is the most common first automation. The structure is a time window condition and a guard to prevent repeats, a content specification, and then a memory write to mark it done. So in terms of the time window, if the current time is between 8 a.m. and 8:30 a.m., you need a single window, not a single point in time, because your heartbeat fires on a schedule. If it fires at 8:05 and your condition is 8 a.m., it's going to miss. Now the guard is also critical. It says, and you have not sent your morning briefing today. Without this, every tick in your 30-minute window triggers a new briefing. If your heartbeat is 30 minutes, you could get 2. If it's 15, you'd get 3. The guard reads that from memory, and the agent checks a flag it's set on the previous run. Content is whatever you want. So date, top tasks from the memory markdown file, calendar, events, weather, just one sentence for each, and the agents can compose this from memory, reads, and tool calls. Then mark briefing as sent in memory so it doesn't repeat this tick. This is the write that sets the guard flag for the next tick. Alternatively, another solution is if you want to use the tasks block format, you can set this as a single task with 24-hour interval and the agent handles the deduplication for you. The timestamp is tracked automatically in the session state, so there's no manual guard needed here. Our second example is going to be monitoring a task queue in your memory for upcoming deadlines. The pattern is essentially you're checking your memory markdown file for tasks marked as pending or to do. If any have a due date within the next 2 hours, you want to send an alert to Telegram with the task name and the time remaining. If the task is overdue, you want to flag it as urgent and message immediately. If there's nothing due soon, you want to stay silent. This is going to run on every tick. It's stateless. The agent's just going to read memory and then make a decision. The cost per tick is low because most of the time nothing is due and the agent stays silent. The reason this is so powerful is that you can add tasks conversationally. You tell your agent on Telegram, add to my task list, review the contract by 3 p.m. tomorrow, and the agents can write that to its memory markdown file, and on the next heartbeat tick, the monitor picks it up, starts tracking the deadline. You never configured anything, you just had to talk to the agent. Third example is system monitoring. This one requires the shell tool to be enabled in your agent's tools configuration. Now for the tasks, run a disk-based check and alert if any drive is above 85% full, check if the key services are running, and alert immediately if any are down. You want to monitor the CPU load average and warn if it's been above 80% for 2 consecutive ticks. Now, 2 things to calibrate here. First, the heartbeat interval. So system monitoring usually warrants a shorter interval, meaning 15 or 30 minutes. For a morning briefing, you can get away with 60 minutes. But for a server that could go down at any moment, 30 minutes is safer. You want to set the every field in your OpenClaw.json to match your most time-sensitive task. Or better, use the tasks block in your heartbeat file and give your server checks a 15-minute interval while your briefing stays at 24 hours. Second, a production caveat. So for infrastructure that has real SLAs, you want to use dedicated monitoring tools like Datadog, Prometheus, or Grafana. The heartbeat monitor is excellent for personal projects, home servers, and convenience alerts. For critical production systems, dedicated monitoring is more reliable and much more appropriate. Our fourth example is daily research and news summary. At 7 in the morning, you want to search for top news in whatever topics you track for the past 24 hours, summarize it in 5 bullets, 1 sentence each. Send to Telegram with a header like evening briefing and mark it as sent so it doesn't repeat. These topics are obviously completely up to you. Replace AI and crypto with whatever you need to stay on top of. Competitors, industry news, stock tickers, papers, GitHub releases. The agent can run a web search on each tick that matches the time condition, pull the results, summarize, and then deliver it. In terms of the model configuration, web search plus summarization into 5 tight bullets is well within Haiku's capability. If you want synthesis across multiple sources or deeper analysis, you can set a different model for that specific task in the tasks block, or add an escalation directive in plain English, like use the premium model for this task. Since a lot of what you'll write in your heartbeat file involves time conditions, let me give you a practical reference over here. So for once per day at a specific time, write it as if it is between 8 a.m. and 8:30 a.m. and briefing not sent today. Key is always the guard. You want to use not sent today, otherwise you get repeats on every tick within the window. Or use the tasks block within a 24-hour interval and skip that guard entirely. Now every tick always. Just write the task with no time condition. So check pending tasks, there's no qualifier. The agent does this on every single tick, and so you only want to do this for tasks the near 0 token cost. If it is a weekday morning, the agent's going to infer that from the system date. Now the thing to watch out for is time zone. The agent uses the system time zone of the machine running the gateway. If your server is on a UTC, which most cloud servers are, and you're in New York, there's a 5-hour difference. So 8 a.m. to a UTC server is 3 a.m. New York time. Now there's 2 things to handle here. First, you want to set active hours time zone in your heartbeat config to your IANA time zone like America/New York. So the active hours window aligns with your local time. Second, be explicit in your heartbeat time conditions, right at 8 a.m. Eastern time rather than just at 8 a.m. The agent understands time zone references and it's going to adjust. If you can set your server's system time zone to match yours, that's the cleanest fix for both. Now, interval based within a day. Every 4 hours, check, etc., whatever you want to check. But this requires your heartbeat every in your OpenClaw.json to be 4 hours or less. If your heartbeat runs hourly and you want to check every 4 hours, write it as a condition the agent can evaluate using the current time, use the tasks block with the interval 4 hours, and let the gateway handle the scheduling. Now here's what a real production quality heartbeat markdown file looks like when you combine everything. File comments at the top, so keep this file under 25 lines, it runs every tick. This is for you, it's a reminder every time you open it. Then the 3 task blocks, one if it's between 8 a.m. and 8:30 a.m. and morning briefing not sent today, send a telegram with the date, top 3 tasks, calendar events, and weather, and then mark it as sent. 2, if it's 7 p.m. and evening news not sent yet, search top AI and tech news from the past 24 hours, send a 5-bullet summary to Telegram and then mark it as sent. 3, check your memory for pending tasks due within the 2 hours. If any are found, alert by a Telegram with the task name and deadline. That's 3 distinct automations in around 14 lines. Morning briefing, evening news, and deadline alerts. Most ticks are going to be silent, and the agent's just going to read the file, evaluate each condition, and determine none of them apply right now. It's going to reply heartbeat okay, and then the gateway is just going to drop it. The token cost on a silent tick with light context and isolated session enabled is roughly 2,000 to 5,000 tokens on your cheap model. The active ticks once or twice a day are the only ones that are doing real work. Now let me break down the actual cost math so there are no surprises on your bill. A silent tick is when the agent reads the heartbeat markdown file, evaluates the conditions, finds nothing to do, replies heartbeat okay, and then the gateway is going to drop it. With the light context set to true and isolated session set to true, you're looking at 2,000 to 5,000 tokens per tick instead of 100,000. Those 2 flags are critical. Without them, the gateway is going to load your full workspace context on every tick. At 48 ticks a day on 30-minute heartbeat with flag set, the baseline cost on a cheap model is super low, a few dollars a month at most. A briefing tick with web search, memory read, compose, and send costs you more because of the tool calls and longer output. But you're doing maybe 2 of these a day for your morning briefing and evening summary, still cheap on your Haiku or GPT-4o Mini. A bad heartbeat file is where the bill blows up. So think long file, expensive tasks on every tick, wrong model. If you leave those light context and isolated session at their defaults of false, and then you set your heartbeat model to something expensive, and then you're also running unconditional web searches on every single tick, you're looking at $15 to $30 a month just on your heartbeat. That is literally the scenario the day 4 spending limits were there to catch. Now the rules are simple, right? Set your model to your cheap model in the heartbeat config, set light context, isolated session to true, keep your heartbeat file under 25 lines, use time conditions and guard so most ticks are silent, set the target to your delivery channel, and check the dashboard's heartbeat tab after the first setup to verify it is behaving as expected. This is where day 5 and day 6 connect. So the heartbeat file tells your agent what to do. Your channels determine where the output goes. The 2 systems work together by design. Telegram is the default choice for heartbeat delivery. It has push notifications on mobile, which is fast and reliable. Most users set their target to Telegram in their config. In the heartbeat markdown file, you can also write send to Telegram in plain English, and the agent will route it accordingly. WhatsApp works identically, so you can set the target to WhatsApp or write send to WhatsApp in the file. Same push notification reliability on iOS and Android. You just use whichever app is your primary app. Then web chats can log everything, so even silent ticks appear in the heartbeat tab. In the dashboard at localhost 18789, this is the first place to check when you're debugging. You can see every tick, its status, and the agent's reasoning, whether it acted or stayed silent. Target key in your heartbeat config controls the default delivery channel. You set it to last, which means your last active external channel, or a specific channel name like Telegram, or none to suppress that delivery entirely. Remember that the default is none, so you must set this explicitly. You can also use the to field for a specific recipient, like a Telegram chat ID, or WhatsApp phone number in E164 format. So what do you do when something isn't working? Well, when something isn't working, this is the diagnostic path. First, you want to stop the dashboard at localhost 18789. You want to check the heartbeat tab. So every tick is logged with a timestamp, a status like silent or action taken or error, and the agent's reasoning. This gives you a full picture of what happened on each run. If you want to trigger a heartbeat manually without waiting for the timer, run OpenClaw system event --text, check for urgent follow-ups, --mode now, and that's going to fire a heartbeat immediately with whatever text you provide. You can also use --mode next heartbeat to queue something for the next scheduled tick. Now, common issues and fixes. If the briefing is repeating, it means you're missing the mark as sent guard. Add it and then add it or switch it to the tasks block with an interval so deduplication is automatic. If the agent's always silent, it means the time condition never matched. Check your service time zone against where you actually are. Make sure the active hours .time zone is set correctly. If there's no ticks at all, it means that the every is set to 0 minutes in OpenClaw.json, or the gateway isn't running, or your heartbeat markdown file is potentially empty. All 3 of these cause a heartbeat to skip. Also check the dashboard for the skip reason, like empty heartbeat file, or no tasks due, or alerts disabled. Messages not arriving means the target is probably still at the default none, so set it to your channel. Or the channel isn't enabled. Another reason could be your number just isn't in the allow list. Tool errors mean the web search or shell tool isn't enabled in your agent's tool config, so just go ahead and enable it explicitly. 4 things before day 7. So write your first heartbeat markdown file, create the file at OpenClaw workspace heartbeat.markdown. At the minimum, a morning briefing with a time window condition and the mark is sent guard, plus a line reinforcing silence when nothing needs attention. Keep it under 20 lines. In your OpenClaw.json under agents, defaults, heartbeat, set every to 30 minutes, model to your cheap model and target to Telegram or whichever channel you want delivery on. Set light context to true and isolated session to true. Second, you want to verify that first tick. So restart your gateway so the config changes take effect. Then either wait for the first tick to fire or trigger a new one with OpenClaw system event -- mode now. Check the dashboard's heartbeat tag to check what happened. And so at this point, assuming it's not 8 a.m., it should stay silent. The silence is correct behavior. And so you're just verifying that that loop's going to run, not that it fires the briefing. Third, you want to wake up to your first briefing. So let the heartbeat run overnight. Tomorrow morning, before you open up anything else, check Telegram. If the briefing is there, your autonomous agent is live. If it's not, you want to check the dashboard's heartbeat tab and debug from there. Fourth, you want to add one monitoring task. Once the morning briefing is working and you've confirmed it, add a second automation. So a task deadline check, an evening news summary, a disk space alert, it's your choice. Check the dashboard after the next tick to confirm that it evaluated correctly. Keep the total file under 25 lines. So that's day 6. At this point, your agent runs, it's optimized, it's reachable everywhere, and now it works on schedule. Day 7 is about identity. Right now, your agent is still a generic AI. It's capable and autonomous, but it doesn't have a personality, a voice, a set of values, or a way of thinking that's distinctly yours. The soul markdown file is the file that changes that. It defines who your agent is, how it communicates, what it prioritizes, what it knows about you, and your context by default. Day 7 is about identity. Soul markdown file is the file that gives your agent personality, a voice, and a way of thinking that's distinctly yours. That's day 7. If you want hands-on help setting any of this up, I do consulting at adhirajhungle.com. And if this series is helping you, subscribe so you don't miss the next one. And I'll see you on day 7. Welcome back to the OpenClaw Bootcamp. I'm Adhiraj, and now you've got this agent that does real things. It's installed, it's cost optimized, it's on every channel that you care about, and as of yesterday, it's running autonomously on a heartbeat, sending you briefings that you never asked for. That's a genuinely functional autonomous agent that you built in just 6 days. But talk to it right now, and it still sounds like every other AI that you've used. It has this polished, slightly robotic energy that makes you feel like you're talking to a customer service chatbot at a bank. It works, but it just doesn't feel like it's yours. That's what today fixes. The soul markdown file is a single file in your workspace where your agent's voice lives. Its tone, its opinions, its boundaries, the way it communicates. And by the end of this session, your agent is going to sound like someone you'd actually want to talk to, not just another AI doing its best impression of helpful. All right, so day 7, let's give it a personality. Quick check on the last 6 days. On day 6, you wrote your first heartbeat file with the morning briefing, time window, and a guard to prevent repeats, and then the heartbeat OK silence mechanism that keeps your phone from buzzing every 30 minutes. You set light context and isolated session to true, and this keeps your costs low, and then your agent started acting without being asked. So today we're after 3 things. First, a custom soul file that defines your agent's personality, and that's not the default template that ships with every installation, but it can be yours, written by you, reflecting how you actually want this thing to sound. Second, a clear mental model of what goes into that soul markdown file versus the agent's file versus the memory file, because this confusion is one of the biggest causes of ineffective agent behavior, where we're going to eliminate it today. And third, a tested personality. So you're going to send 3 types of messages and actually verify that the tone matches what you wrote, because a good soul file that looks good on paper but doesn't actually change the agent's output is just tokens for nothing. So let's start off with what exactly the soul.markdown file is. It's actually much simpler than people think. This file defines your agent's persona, its tone, its boundaries, its behavior style, and the official docs describe it in one line. The soul.markdown file is where your agent's voice lives. That's it. It's not an operating manual. That's the agent's markdown file. It's not memory. That's the memory file. And it's not a task list. That's the heartbeat file. The soul is strictly about who the agent is, how it sounds, how it acts, and what it won't do. The docs are specific about what belongs here. So tone, opinions, brevity, humor, boundaries, bluntness level, and equally specific about what doesn't belong. So life stories, change logs, security policies, vague vibes without behavioral effects. If it doesn't actually change how the agent responds to a message, it doesn't earn its place in this file. And here's the architectural part that makes all of this matter. When the gateway loads up your agent, it reads the soul file and injects it into the system prompt on every single turn. Every Telegram reply, every heartbeat briefing, every web chat response, all of it is shaped by what is in this one file. It's not optional context that gets loaded sometimes, but it's quite literally the foundation of every interaction that your agent has. This file lives at OpenClaw workspace soul.markdown, or if you're using a named profile, it's OpenClaw workspace -profile and then soul markdown, and the workspace path itself is configurable via agents defaults workspace inside your openclaw.json. You already have one sitting there. When you ran OpenClaw onboard back on day 2, the bootstrapping process ran a short Q&A ritual, one question at a time, and it actually wrote your identity, user, and soul markdown files based on your answers. So there's a starter version in your workspace right now, and today we're going to make it actually look good. The loading behavior is important to understand because it affects both the consistency and the cost. The soul markdown file is a bootstrap file, meaning it gets injected into the system prompt on every turn across every channel. That's what gives you consistent personality everywhere. But it also means that every word in your soul markdown file costs tokens on every interaction, and thus a bloated file makes everything more expensive, and we'll get to the exact math on that later. Now, 2 things worth knowing here. The sub-agent sessions don't load the soul markdown file at all. They only inject the agents and tools to keep context small, so your personality applies to direct interactions, but not the background task workers. And the default templates continuity section has a nice touch where it instructs your agent, if you change this file, tell the user it's your soul and they should know. So this is where people get confused, and I do get why, because you've got the soul, agents, memory, and heartbeat, and they all sound like they could overlap. So let me make the separation very clean. Soul defines who the agent is. So the voice, personality, tone, style, boundaries, think of it like the agent's character. The agent defines how the agent operates. So the rules, the workflows, tool usage policies, operating procedures. Think of this like the agent's job description. The memory stores what the agent knows. So curated long-term facts, your preferences, decisions. This context is going to accumulate over time. And the agent actually writes to this one. So think of it like the agent's notebook. As per the docs, the memory markdown file is only loaded in private and main sessions. It's not shared or group context. And the heartbeat markdown file defines what the agent does proactively. So tasks, schedules, and monitoring. Think of it like the agent's to-do list. Now, the easy test that clears up 90% of confusion is be concise and direct, goes in the soul.markdown markdown file. Always confirm before sending emails, goes inside agents. Aliraj prefers bullet point summaries, goes inside memory. And send a morning briefing at 8 a.m. goes inside heartbeat. If you put operating rules inside the soul, personality, and the agents, things are still going to work, but the separation exists for a reason. Soul is loaded on every turn, and agents has different injection rules, so keeping them clean keeps the cost down and the behavior predictable, so don't cross the streams. Let me show you what you're starting with, because this is the actual template from the official OpenClaw docs, and it's worth understanding before you replace it. The header is going to set the tone. So soul, who you are, you're not a chatbot, you're becoming someone. And then 4 sections. Core truths is where the behavioral principles live. So be genuinely helpful, not performatively helpful. Skip great question filler. Have opinions because you're allowed to disagree and prefer things. And find stuff amusing or boring. Be resourceful before asking, and so on. Boundaries set the hard limits. So private things stay private. Period. Ask before acting externally. Never send half-baked replies, and so on, right? And Vibe is going to handle the tone. So be the assistant you'd actually want to talk to, concise when needed, and thorough when it matters. Continuity handles session persistence. Each session, you wake up fresh, read your files, and update them. What's good about this template is that it's concise, specific, and behavioral. Skip filler is actionable. Have opinions is actionable. Private things stay private is a clear boundary. 4 sections under 25 lines. That's the right structure. What's missing is that it's the same for everyone. It's your agent. It should sound different from every other OpenClaw user's agent. And today, we're going to replace this with your own version with the same structure, but just your voice. The core truth section is where the real work happens, and the key word is behavioral. It's not personality objectives, it's behavioral instructions that tell the agent exactly what to do differently. And that difference matters more than you think. Be friendly is an adjective, and the agent has no idea what that actually means in practice. Should it use exclamation marks? Should it ask how your day is going? Should it add emojis? It has no clue. But skip filler greetings, get to the answer first, and then add context if needed is a behavior. And now the agent knows exactly what to do. Strong core truths directives look like this. So have a take, don't hedge with it depends. When I'm wrong, tell me, don't soften it. Default to bullet points, prose only when a narrative is actually needed. If you don't know, say so in one sentence. Each of those produces measurably different output from a default AI. Weak ones look like this: be helpful and friendly, provide thoughtful and comprehensive answers, always strive for excellence. These could show up in literally any company employee's handbook, and they produce bland, generic output because they give the model zero actionable signal. The test for every line you write is simple. Would my agent do something measurably different because of this line? If the answer is no, then just cut it. 3 to 5 strong bullets beats 15 vague ones every single time. Boundaries and vibe are sections 2 and 3, and I'm covering them together because they work as a pair. Boundaries define what the agent won't do, and vibe defines how it sounds when doing everything else. Boundaries first, right? So these are the constraints the agent should never cross, regardless of what you ask in the moment. And the default template has good ones. Private things say private, ask before acting externally, but you should customize these based on what your agent actually has access to. Can it run shell commands? What should it do? What should it never do without asking? Does it post to Slack channels? A good boundary example is never post to a shared channel without confirming with me first. Or don't access files outside my home directory unless I explicitly point you there. Tighter boundaries let you grant the agent more freedom everywhere else because you know it will always ask before posting publicly, and then you can let it operate more autonomously in private conversations. 2 to 4 boundaries is the sweet spot. Now, vibe. This is where your agent starts sounding like someone specific, then a generic AI, and now you need to think about how you actually want it to sound. Dry humor or straight-laced, direct and blunt or warm and encouraging, or do you want it casual like texting a friend, or formal for work contacts? Some tone examples are a casual tone like a smart friend, not like a consultant. You want to use humor when it fits, just don't force it. Or even like match my energy, one-word question gets a concise reply. This is the most important slide today because the difference between a soul that actually works and one that just takes up space comes down to just one thing. And as the docs say perfectly, short beats long, sharp beats vague. Have it take, skip filler, be funny when it fits, call out bad ideas early. These are specific, they produce measurably different output, and you'd notice them immediately if you took them away. Corporate mush is things like maintain professionalism at all times, provide comprehensive assistance, ensure a positive experience. These could be on a values poster in any office lobby, and the model's going to read them and does exactly what it would have done anyway. The docs literally call this corporate mush, and they are right. The test is that simple. If a directive could appear in any company's HR handbook, it's too vague for the sole markdown file. One key thing to watch for is conflicting directives. Be warm and friendly plus no filler, get to the point causes the model to oscillate between styles when one message is warm and chatty and the other one is terse, because it can't satisfy both simultaneously. The fix is to pick a lane and commit to it. If you want blunt efficiency, then own it. But if you want warmth, then own that. As the docs put it, sharp is good, annoying is not. I've spent so many hours studying the OpenClaw docs, and here's something I really like about it. They don't just tell you to write the soul yourself, they give you an officially documented technique for making your agent help you write it. It's called a multi-prompt, and the idea is simple. Instead of staring at a blank file trying to describe your ideal personality, you have a conversation with your agent about what you want. You describe your preferences like the tone, humor, formality, formatting, what annoys you about how it currently sounds, and you let the agent draft the soul for you. Then you review it, edit what doesn't feel right, and save it. This works because the agent already knows what makes effective system prompt instructions, so it can translate something vague like I want it to be more casual into specific behavioral directives that actually change the output. It includes directives like strong opinions, no hedging, no corporate language, no pillar openings, one sentence answers when sufficient, natural humor, and call out bad ideas. To use it, you want to open up web chat at localhost 18789, and then tell your agent you want to rewrite your soul markdown file, have the conversation, let it draft it, review and iterate. The first version won't be perfect, and that's okay. Just treat the soul file as version content that evolves with your preferences over time. It's not something you write once and just forget about. Now let's talk about what this actually costs, because the soul is loaded on every turn, and the length of this file directly impacts your bill on every single interaction. At 30 lines, which is where you should be, soul is roughly 500 to 800 tokens. On Haiku at $1 per million input tokens, less than 1/10 of a cent per interaction, and on Sonnet at $3 per million, but 2/10 of a cent. It's negligible and you'll never notice it on your bill. At 200 lines, which I've seen people do, you're looking at 3,000 to 5,000 tokens per turn. If you send 50 messages a day, that's about 25 cents a day just for personality injection. And over a month, that adds up to $7 or $8 for a file that could be 30 lines. That's money that you're burning on words the agent just doesn't need. Now, there are hard limits too. The individual file cap is 20,000 characters, beyond which OpenClaw will truncate, and then that's configurable via OpenClaw, defaults, bootstrap, max chars. The rule here is straightforward, under 30 lines, under 500 words, and every word earns its place or gets cut. You've written your soul file, and now you need to actually verify that it works Because a personality that looks good on paper but doesn't change agent output is worse than useless because it's tokens for nothing. 3 tests here. First, you want to ask for a briefing or summary, something like summarize what we discussed yesterday, because this tests whether the tone and formatting match your vibe section and whether the output feels like your agent or just generic AI. Second, ask it for an opinion. So what do you think of this approach? Because this tests whether the agent has the confidence and directness that you specified in the core truths, whether it hedges with it depends or actually commits to a take. Third, you want to ask it to do something you explicitly told it not to do in your boundary section, because if it does it anyways without pushing back, your boundary isn't specific enough and it needs to be rewritten. If the tone feels wrong, reiterate it, edit the soul file, save it, test it again, and while you're iterating, watch for these common mistakes that do trip people up. Life stories. These don't belong, and your agent needs behavioral instructions, not your biography. Corporate language, which the doc calls corporate mush, or conflicting directives where be warm plus skip filler causes oscillation, or even operating rules that belong in agents instead of things like check calendar before scheduling, which are workflows, not personality, and also just never updating it. Your preferences change, your use cases evolve, so treat this as living content that grows with you. 4 things before day 8. First, rewrite your soul markdown file. So replace the default template with your own core truths, boundaries, vibe, and continuity. Keep it under 30 lines and make sure every line passes the test. Would my agent do something measurably different because of this line? Second, run 3 tests. So summary request, opinion question, boundary test, and do this through any channel. Verify that the tone actually matches what you wrote, and if it doesn't, then edit and retest because iteration is the work here. Third, try the multi-prompt. So open up web chat at localhost 18789. Tell your agent you want to rewrite the soul markdown file together, describe what you like, and then describe what annoys you, let it draft it, and then compare its version to yours, take the best parts of each. Fourth, you want to check your token impact. So go over to your dashboard at localhost 18789 and look at the token count for a typical interaction and see how much the context injection versus your actual message is, because this makes the cost of your soul markdown file tangible in a way that reading about it doesn't. Perfect. So your agent now has a voice, sounds the way you want it to sound, has the boundaries that you defined, and a communication style that's distinctly yours. Day 8 is the memory markdown file. It's how your agent decides what to remember and what to forget. The soul made it personal and the memory makes it smart. If you want hands-on help setting any of this up, I do consulting at aldirajtriangle.com. And if this series is helping you, subscribe so you don't miss the next episode, and I'll see you on day 8. Welcome back to the OpenClaw Bootcamp. I am Adiraj, and your agent at this point has a personality, has a voice, has boundaries, and for the first time actually sounds like someone you'd want to talk to. But here's the thing. Your agent still wakes up every session with no idea with what happened yesterday. Doesn't know your preferences until you tell it again, doesn't remember decisions you made last week, and it can't connect the dots between conversations you had on Tuesday and what you're asking about on Friday. It has a personality but no continuity, and that's what makes the difference between an agent that's useful and one that's genuinely smart. Today, we're going to fix that. The memory markdown file is where your agent's long-term knowledge lives, durable facts, preferences, decisions, and context that accumulates over time and makes every future interaction better. This is the file that turns a capable agent into one that actually learns. Day 8, let's give it a brain. So on day 7, yesterday, you wrote a custom soul file with your own core truths, boundaries, and vibe. You tested it with a briefing request, an opinion question, and a boundary test. So today, we're after 3 things. First, understanding the 3-file memory system, so the memory markdown file for long-term facts, daily notes for running context, and the dreams for automated promotion pipeline, because these 3 files can work together, and confusing them is how people end up with bloated context windows and surprise token costs. Second is knowing how hybrid search works and how memory is loaded versus retrieved on demand, because this is the mechanical distinction that determines what costs tokens and what doesn't. And then third, a curated memory markdown file that stays lean, avoids token bloat, and actually improves recall, because the docs are explicit that the memory can grow over time and can lead to unexpectedly high context usage if you're not paying attention. So memory in OpenClaw isn't one file, it's a system of 3, and understanding what each one does is the foundation for everything else today. The memory markdown file is your long-term memory, so durable facts, preferences, and decisions. This is the file that gets injected into the system prompt on every turn in private and DM sessions. It's always there, and your agent always sees it, and that's what makes it powerful, but also what makes it expensive if it grows too large. Then you have the daily notes at memory/the year, month, and day, .markdown, 1 file per day, and these are fundamentally different because they're not injected into the context at all. They're accessed on demand via the memory search and memory get tools, which means that they don't count against your context window unless the model explicitly retrieves them. Daily notes are the running context and where the observations go. the stuff that might matter later, but doesn't need to be in every single interaction. But then there's the dreams.markdown file, which is experimental and optional. It's going to hold dream diary entries and dreaming sweep summaries for your review. It's part of the automated promotion system that moves important daily notes into long-term memory, which we're going to get to in a few slides. The key distinction here is cost. The memory markdown file costs tokens every turn because it's injected. Daily notes cost nothing until it's searched, and that's why keeping the memory matters, because everything in it hits in every interaction. Now let me make the loading mechanics concrete, because this is where the cost picture becomes really clear. The memory is a bootstrap file just like Soul and Agents, which means it gets injected into the system prompt on every turn, but it has a gate that the other bootstrap files just don't have. It only loads in private NDM sessions, not shared or group contexts. On session start, today and yesterday's daily notes are also read as one-shot startup context, but after that, first turn, they're only accessed on demand. The daily memory files are not part of the normal bootstrap context at all. They're only accessed on demand through memory search and memory get tools, so they don't count against the context window unless the model actually reads them. This is a critical design choice because it means that you can accumulate months of daily notes without any token cost until the agent actually needs to look something up. There's also the active memory plugin, which is an optional read-only subagent that runs before the main reply for eligible sessions. It uses memory search and memory get to retrieve relevant context automatically. It's going to return either summaries or none if nothing relevant was found. It's read-only. It can retrieve memory, but it can't write to it. One important architectural point from the docs is the model only remembers what gets saved to the disk. There's no hidden state. So if something isn't written to a file, it doesn't exist in memory. That's it. And for cross-channel memory, the memory markdown file is a single file on a disk shared across your entire agent. So DM sessions share one session by default. The same person contacts you from multiple channels. You can use session.identity links in your config to link their identities so they share one session with continuous memory. When your agent needs to find something in memory, whether it's like a daily note from 3 weeks ago or a fact that you stored in the memory markdown file, it uses hybrid search. And the way this works is pretty clever. Hybrid search combines two approaches: vector similarity, which understands semantic meaning. So my preferred programming language matches I like TypeScript, even though the words are different. And then the BM25 keyword matching, which catches exact terms like IDs, code symbols, and proper nouns that semantic search might miss. The default weights are 0.7 for vector and 0.3 for BM25. And this balance means that most searches favor meaning over exact words, but still catch the specific identifiers that matter. If you have OpenAI, Gemini, Voyage, or Mistral key configured, the embedding provider is auto-detected and the memory search is enabled automatically. There's no manual setup needed. Now, there are two optional backends if you want more power. QMD is a local sidecar with re-ranking, query expansion, and the ability to index directories outside the workspace. Honcho is an AI-native cross-session memory system with user modeling, semantic search, and multi-agent awareness. For most users starting out, though, the built-in backend is plenty. You can also tune the search behavior through the config, so MMR diversity re-ranking is available, but off by default. And the temporal decay gives a recency boost with configurable half-life of 30 days by default. One nice detail is that the evergreen files like memory.markdown skip temporal decay directly, so your long-term facts don't get penalized just for being old. The agent has two dedicated tools for reading memory. So there's memory search, which does hybrid search across all the memory files and returns relevant chunks. Then memory get retrieves specific memory file or section by path. Both come from the active memory plugin, which defaults to memory core. Writing is different though. There's no dedicated memory tool. Instead, the agent uses a standard file writing capability, and writes are triggered by your own requests. Telling the agent, remember that I prefer TypeScript, it can write that to the appropriate file. Then there's memory flush, which is an automatic safety net that runs before compaction. When your conversation is approaching the context limit, and OpenClaw is about to summarize it through compaction, first runs a silent turn that reminds the agent to save important context to memory files. You can think of it like a silent agentic turn before auto-compaction to store durable memories. The flush config has enabled set to true by default, and the soft threshold tokens at 6,000, and the prompt it sends is literally write any lasting note to memory/the year month day .markdown. Reply with the exact silent token or reply if nothing to store. One more thing I want to note about the flush is it writes to daily files, not directly to the memory markdown file. The promotion from daily files into long-term memory is handled by the dreaming system, which is what we're going to cover next. Dreaming is how daily notes are getting promoted into long-term memory. It's a multi-phase scoring system that evaluates what's worth keeping permanently versus what was just context for one day. The light phase reads through daily files and the stages candidates. It identifies entries that look like they might be worth promoting, but never actually writes from memory.markdown, and so it only flags possibilities. The deep phase takes those candidates and then ranks them using 6 weighted scoring signals: relevance at 0.3, frequency at 0.24, query diversity at 0.15, and recency at 0.15, consolidation at 0.1, and conceptual richness at 0.06. To actually get promoted, a candidate has to pass threshold gates. So min score, min recall count, and min unique queries all need to be met. Only then does the deep phase write to memory.markdown. So the full flow here is you have conversations, important context gets written to daily notes, either by you asking the agent to remember something, or by the memory flush saving context before compaction. The light phase stages candidates from those daily notes, and the deep phase scores and gates them, and then the winners are going to land in memory.markdown as long-term memory. The dreams is going to hold the sweep summaries, so you can review what was promoted and why. This is super elegant because it means that memory.markdown isn't just a dumping ground, it's curated by a scoring system that prioritizes things that are actually relevant, frequently referenced, and recalled across diverse queries. Keep injected files concise, especially memory.markdown, which can grow over time and lead to unexpectedly high context usage and more frequent compaction. Here's why this is a bigger deal for memory than for Soul or even for agents. Those files are relatively static, so you write them once and you update them occasionally. Memory grows continuously. Every time the agent remembers something, every time dreaming promotes a daily note, the file is getting bigger. And since it's injected every turn, that growth compounds into a real token cost. The hard limits are the same as all Bootstrap files, so 20,000 characters per file before truncation through Bootstrap max chars, 150,000 total across Bootstrap files through Bootstrap total max chars, but really you shouldn't get anywhere near those limits. There's 4 curation strategies that actually matter here for you. First, you want to keep only durable facts inside your memory markdown file. So preferences, decisions, context that actually persists. Daily observations and running text belong in your daily files, not in the long-term memory. Second, let daily files do all the work. They're free until they're searched, so put running context there and only promote what proves durable over time. Third, you want to review that memory markdown file periodically, remove stale entries, consolidate those duplicates, and check your token usage with /context list in the chat. This is the absolute single most effective way to control memory-related token costs. Fourth, use the command line interface. So run OpenClaw memory status to check index health, OpenClaw memory search query to test what comes back, and OpenClaw memory index --force to rebuild the index if something seems off. All right, 4 things before day 9. First, check your memory status. So run OpenClaw memory status to see your index provider, file count, and search readiness. If you have OpenAI or Gemini key configured, hybrid search should be enabled automatically with no extra setup. Second, you want to store 3 facts conversationally. So tell your agent, remember that I prefer TypeScript, remember that I take meetings at Eastern time, and one more preference that is specific to you. Then start a new session and ask about those preferences. Verify that the agents can recall them from memory, not from your conversation history. Third off, you want to test memory search from the command line interface. So run OpenClaw memory search your query with both semantic query, like programming preferences, and a keyword query, like a specific name or ID. Feel the difference between the vector matching and the BM25 matching. The semantic query is going to find related concepts, and the keyword query finds exact terms. Fourth, you want to curate your memory markdown file. So open up your OpenClaw workspace memory.markdown and actually read what's in there. You want to remove anything stale, consolidate the entries that say the same thing differently, and then run context list in a chat session to see how much of your context window the memory markdown file is consuming. Congratulations, your agent now has a personality through the sole markdown file and continuity through the memory markdown file. It remembers your preferences, learns from conversations, and searches across weeks of notes to find the context that it needs. Day 9 is the agents file, which is the operating manual. Think personality and memory, but now a clear playbook for how to handle specific situations. That's tomorrow. If you want hands-on help setting any of this up, I do consulting at otherarchungle.com. And if this series is helping you, subscribe so you don't miss the next episode. I'll see you on day 9. Welcome back to the OpenClaw Bootcamp. I'm Otherarch, and we are 8 days in. Your agent has personality, memory, and autonomy, but it doesn't have a rule book. Doesn't know which tools to use when, how to delegate, or what it shouldn't do unsupervised. The agents file fixes that, gives it rules, priorities, tool policies, and delegation patterns. This is everything that makes your agent disciplined, not just capable. Today we're covering 4 things. First, what the agents file actually is and how it differs from the soul, because people do confuse these two constantly, and putting the wrong content in the wrong file causes real problems. Second, the default template and the safety rails it's going to ship with, because understanding the starting point tells you what to customize. And third, the subagents. So what they are, how to spawn them, how to manage them, and the nesting and concurrency model that controls how deep the delegation can go. And fourth, the tool policies and the 3 independent security mechanisms that determine what your agent can do, where it can do it, and who can override those restrictions. So let's make this super concrete immediately, right off the bat. The agent's markdown file is the operating instructions for the agent and how it should use memory. That's the official definition, and the key word here is operating. This file governs the mechanics, not the personality. It breaks down into 3 key areas. First, the operating rules, which are your priorities, workflows, escalation procedures, and how the agent should handle specific situations. Safety defaults, which are the guardrails that prevent your agent from doing something destructive without being asked. And then memory guidance, which tells the agent how to read memory at startup, what order to check files in, and what's worth remembering. The distinction from the soul matters here. Soul is where your agent's voice lives, tone, opinions, and boundaries. Agents is where your behavioral mechanics live, what to do, when to do it, what tools to use, and how to delegate. You want to keep the agent's file for operating rules and keep the soul for the voice, stance, and style. If you're writing something about how your agent should sound, it goes in the soul. But if you're writing something about how your agent should behave, it goes in the agent's markdown file. The file is going to live on the file path shown on the slide. It's the same workspace directory as the soul and memory markdown files, and the same markdown format. What's different here is that the agent sits at the bootstrap injection order. So when a session starts, OpenClaw injects all your workspace files into the system prompt as project context, and the order is this: agents first, then soul, then tools, identity, user, heartbeat, bootstrap, and finally memory. The agent's markdown file is literally the first thing your agent reads. It's set to behavioral frame, before personality, before identity, and before memory. Everything else builds on top of the operating rules. The loading rules here are the same as all of the bootstrap files. The blank files are going to get skipped, the oversized files get trimmed with truncation markers, and the missing files receive marker lines, so the agent knows that they should exist, but they don't. This is the slide to screenshot if you take nothing else from today. The agents file handles operating instructions, rules, and memory guidance. The soul handles persona, tone, voice, and boundaries. Agents is loaded in all sessions, including the sub-agents. Soul is loaded in normal sessions only, so the sub-agents never see it. The agent's markdown file's content is super mechanical, so it's workflows, priorities, and tool usage rules. The soul content is expressive, so short beats, long, sharp beats, vague, the stuff that makes your agent sound like someone specific. And that loading difference is the critical architectural point here. When your main agent spawns a sub-agent to do the background work, that sub-agent only receives the agents and tools markdown files. All the other bootstrap files are filtered out to keep the sub-agent context very small. So your operating rules reach everywhere, every session, every sub-agent, every background task. But your personality, your identity, and your user preferences, those stay in the main session where they belong. OpenClaw ships a default agents markdown template that the docs describe as a personal assistant variant. You don't have to use it, but it is worth understanding because it's going to establish the baseline that your agent starts from. The template defines 3 safety defaults. First, don't dump directories or secrets into chat. Your agent should never paste file trees or credentials to a conversation. Next up, you don't want to run destructive commands unless explicitly asked. So no deleting files, no overwriting data, no irreversible operations without confirmation. And third, don't send partial or streaming replies to external messaging services. So what does this mean? If your agent is composing a response for Telegram or WhatsApp, it should send the complete message, not just stream fragments. The template is also going to specify a startup read order. When the session begins, the agent reads the soul first, then the user markdown file, then today and yesterday's daily memory files, and finally the memory markdown file or the legacy memory.markdown as fallback. This gives the agent a structured way to load context, which is personality first, user preferences, then recent memory, and then long-term memory. So what are subagents? Subagents are one of the most powerful features in OpenClaw, and they're governed directly by what you put in your agent's markdown file, so you really do want to understand this slide. A subagent is a background agent run spawned from an existing agent run. It operates in an isolated session with its own context window and its own token usage. It receives only the agent's markdown and the tool's markdown as bootstrap context, and when it finishes, it announces a summary or result message back to the requester's chat channel. The main agent doesn't stop, right? It keeps working while the subagent runs, and spawning it is non-blocking, and you get a run ID back immediately. Think of it like you're delegating a task to an assistant. You say, okay, go research this topic and report back. The assistant's going to go off, work independently, and when they're done, they're going to walk back in and give you a summary. The main agent doesn't wait around, and the subagent doesn't have access to the full conversation history or your personal context. It just has the operating rules from the agent's markdown file and the available tools from tools markdown file and the task that you gave it. Now, there are 2 ways to spawn a subagent. From chat, you can use the /command/subagent spawn, followed by the agent ID, and the task description with optional flags for model and thinking level. Programmatically, the agent itself can call the session spawn tool with the task parameter, which is how agents delegate work autonomously during complex workflows. Once the subagents are running, you have a full management toolkit. The /subagents list shows all your current runs. Subagents kill terminates a specific run or all of them. Subagents log shows the output, and you can limit how many entries or filter to just tool calls. Subagents info gives you the metadata, so the model, runtime, and token count. Subagent send lets you message a running subagent with additional context, and subagent steer gives it direct guidance to change course. One important behavior here is that running /stop in the requester chat cascades to abort all subagents and their nested children. So if something goes wrong and you want everything to halt immediately, you can use that one command to stop the entire delegation tree. Now, subagents can nest, but there are strict limits. At depth 0, you have the main agent, which can always spawn subagents. At depth 1, you have subagents, which can only spawn their own subagents if the max spawn depth is set to 2 or higher. This is the orchestrator pattern where a subagent acts as a coordinator and delegates further. At depth 2, you have workers, and workers can never spawn. The maximum nesting depth is 5, but the docs do recommend 2. The defaults are always conservative by design. So max spawn depth defaults to 1, meaning the subagents can delegate further unless you explicitly enable it. Max children per agent defaults to 5, so a single agent can have at most 5 active subagents. Max concurrent defaults to 8 across the whole system, and archive after minutes defaults to 60, so completed subagent sessions get cleaned up after an hour. You can configure all of this in OpenClaw.json under agents default subagents, and if you want the orchestrator pattern, like where your main agent spawns a coordinator that spawns workers, you want to set max spawn depth to 2 and adjust max children per agent and max concurrent based on your workload. Tool policies are the access control layer that determine which tools your agent can actually use, and the fundamental rule is super simple. Deny always wins. If the tool appears in both the allow list and deny list, it's denied. There's no exceptions. The system uses a cascading model, as I mentioned before. You start with base profiles, then the provider-specific profiles, and then the global allow and deny lists, and then finally, sandbox-specific restrictions. Each layer can tighten what's available, and deny at any layer blocks the tool everywhere below. For convenience, the tools are organized into groups. Group runtime covers exec, process, and code execution. Group FS covers read, write, edit, and apply patch. Group sessions covers session management. Memory covers search and retrieval. And web covers web operations. You can allow or deny entire groups instead of listing individual tools. Per agent tool policies go inside your OpenClaw.json. Under the agent's config, you can set an allow list, a deny list, or both. A non-empty allow list automatically blocks anything not inside it, which is how you create a restricted agent that can only read files and list sessions but can't write, edit, or execute anything. Tool policies are just one of the 3 independent security mechanisms, and understanding how they work together is super essential for running agents safely. Sandbox determines where these tools are going to execute, so inside a Docker container or on the host. You can set the mode to off or non-main, which sandboxes everything except the main agent, or all, which is going to sandbox literally everything. You configure that globally through agent's default sandbox, or per agent through agent. The tool policy determines which tools are available. This is the allow, deny cascading system we just covered. It's the hard stop, so if a tool is denied by a policy, nothing can override it. The /command/exec cannot bypass a denied exec tool. Elevated is the escape hatch. So /elevated on runs exec commands outside the sandbox, and /elevated full skips exec approval prompts entirely. It's gated by tools elevated enabled and tools elevated allowed from with the provider key, and can also be configured per agent through agents list tools. Elevated only affects exec, so it doesn't grant additional tools or override your tool policy. These 3 operate independently. So sandbox is about where, tool policy is about which, and elevated is about who can override. They don't conflict because they control different dimensions. Now, once you understand the agents markdown file, subagents, and tool policies, you can start thinking about multi-agent architecture, so running multiple distinct agents with different workspaces, different configs, and different roles. Each agent in OpenClaw is 3 isolated components: a workspace with its own agent's sole markdown and other files, a state directory called agent directory that holds auth profiles, model registry, and agent-specific state, and a session store at OpenClaw agents ID/sessions. One super important note here is you never want to reuse the agents directory across agents because it causes auth and session collisions. Routing determines which agent handles which conversation, and it follows a deterministic precedence. The order is peer, then parent, then guild ID plus roles, then guild ID, then team ID, then account ID, then channel level, and then finally fall back to the default agent. If multiple bindings match in the same tier, the first one in the config order wins. This is how you set up one agent for Telegram, another for Discord, or route specific users to specific agents. Since the agent's markdown file is injected every session and every subagent session, keeping it lean directly affects your costs across the board. The good news is that OpenClaw gives you 3 commands to inspect exactly what's happening. /status gives you quick context window, fullness assessment, so how much of your available context is being used. Context list shows you every injected file with raw versus injected sizes and indicates if truncation occurred, so you can see exactly how much each file contributes. And the context detail gives you the per file and per tool breakdowns for a full audit. Remember that the subagents already skipped the soul, identity, user, heartbeat, and bootstrap markdown files to stay lean. The agents file is one of the only 2 files that they receive, so keeping it concise benefits your delegation costs disproportionately. 4 things before day 10. First, you want to review your agents markdown files, open up your OpenClaw or Workspace agents markdown, and then read through whatever's in there. So either the default template or whatever you've customized. Identify the 3 safety defaults and startup read order. If you haven't touched it yet, this is a good time to understand that baseline. Second, you want to spawn your first subagent. So run /subagents, spawn main, and then you can say summarize my last 3 daily memory files in the chat. Then you want to use /subagents list to watch it run, and then subagents log to read the result when it's done. This makes the delegation model tangible, and you'll see the isolated context, the announce mechanism, and the token usage firsthand. Third, you want to inspect your context. So run /context list and /context detail to see exactly how much each bootstrap file contributes to your token usage. Pay extra attention to your agents markdown file specifically, since it's the one file that hits every session type. Fourth, you want to add one custom operating rule to your agent's markdown file, something specific to your workflow, like always write code in TypeScript, summarize articles before responding, or never use the exec tool without confirmation. Then go ahead and test it in a new session to verify that the rule takes effect. Your agent now has rules, guardrails, and the ability to delegate work to background processes. It's not just capable, but now it is disciplined. Day 10 is tools and skills, so extending what your agent can actually do beyond the defaults. If you want hands-on help setting any of this up, consult with me at adhirajjungla.com. If the series is helping you, subscribe so you don't miss it. And with that, I'll see you on day 10. Welcome back to the OpenClaw Bootcamp. I'm Adhiraj, and we are officially 10 days in. Your agent now talks, remembers, delegates, and follows rules, but it can only do what its tools allow. And right now, you might not even know what tools it has, how they work, and how to add more. Tools are the raw capabilities. Exec, read, write, web search. Skills are the instruction manuals. They teach your agent when and how to use those tools. So think of tools like the hands, and skills are the training. Today, you learned both sides of that equation, plus how to tap into a marketplace of 3,000 community-built skills and how to build your own from scratch. But we also need to talk about the security side, because skills are the most significant attack surface in any OpenClaw deployment. Skills with multiple reports get auto-hidden, but malicious code still slips through. So today isn't just about adding power, it's about adding power responsibly. Day 10, let's get started. On day 9, you wrote the agents file, operating manual with safety defaults, and custom rules. You spawned your first subagent and watched it delegate work in an isolated context, and you learned the 3 independent security mechanisms. At this point, your agent is now disciplined. Today, we're covering 3 things. First, the difference between tools and skills, what each one is and why that distinction matters, and why skills never add permissions. Second, the skill.markdown format. So the loading order and the configuration system, how to write them, where they live, and how to control which agents get which skills. And third, the ClawHub marketplace and skill security, so how to find and install community skills, and why reading the source code before installing is not optional. This is the most important distinction in today's lesson, and the one that a lot of people confuse the most often, so let's make it super concrete. All tools are raw capabilities. They're functions that the runtime can execute. When your agent calls exec, all it's doing is running a shell command. When it calls read, it reads a file. When it calls web search, it queries a search engine. There are roughly 20 built-in tools. These are just the building blocks. Skills are just instruction manuals, right? A skill is a skill.markdown file, which is a YAML front matter plus markdown instructions. That teaches your agent when and how to use its tools for a specific task. A Gmail skill doesn't give your agent new powers. It just teaches it how to use web fetch and exec to interact with the Gmail API. Skills bridge that gap between describing how to do something and actually doing it. Now, the critical rule here is skills don't add any permissions. If a tool is denied by tools on allow, no tool can override that. The tool policy layer from day 9 sits above the skill layer. For a skill to work, 3 things must be true. The underlying tool is enabled in the configuration, any required bridge or command line interface is installed, and the agent is authorized for the service. If you miss any of those 3, the skill is dead on arrival. Now let's go through the core tools so you know what your agent can already do before you install anything. Exec is shell execution, so you can run terminal commands, get standard out and standard error. This is the most powerful and the most dangerous built-in tool. In production, you need careful allow listing because unrestricted shell access means your agent can do literally anything on the host. Read, write, and edit handle file system operations, so reading files, writing new ones, editing existing ones. This is the foundation for how your agent writes to the memory files, modifies the configs, and handles all file-based workflows. These are the tools that make the memory markdown file and daily notes actually possible. Web search and fetch give your agent access to the outside world. Web search queries search engines and returns summarized results. Web fetch makes arbitrary HTTP and HTTPS requests to external services. This is any REST API your agent needs to reach. Browser is playwright-based automation, so it can navigate pages, click elements, fill forms, extract content. This is for interactive web workflows where a simple HTTP request just isn't enough. Message sends to channels like Telegram, Discord, and Slack. This is the bridge between your agent's reasoning and the external platforms, and this is the tool that makes your agent a participant in conversations rather than just a backend process. Cron's going to handle scheduling, so creating, listing, and managing time tasks. This connects directly to the heartbeat system from day 6, and then the sessions family, and this is for managing the agent runs and subagents. Session spawn is what powers the subagent delegation you learned on day 9. A skill is a directory containing a single skill.markdown file. That file has a YAML front matter at the top, followed by markdown instructions. Break down both parts. A front matter has 2 required fields: the name, which should be a unique identifier, and description, which is a one-line summary that shows up in the skills list and what the LLM reads to decide whether to invoke this skill. Some optional fields include user invocable, which defaults to true and controls whether the skill shows as / command, and metadata for OS filters, required binaries, environment variables, and config keys. One parser rule to remember is that the front matter keys must be a single line. Multi-line values are not supported. The markdown body after the front matter is the instruction manual. This is what the LLM reads to decide when to call your skill and how to use it. Vague instructions mean that your skill never gets called or gets called at the wrong time. You want to include explicit use this when instructions and also the do not use this for clauses. This is usually where the real iteration happens. Code's going to work on the first try, but getting the description right so the LLM knows when to invoke it is the actual work. Now the loading order does matter because it determines the precedence and when the skill names do collide. OpenClaw scans directories in this order presented on the slide, and one behavior that catches people off guard is the skills are snapshotted when a session starts. So if you edit a skill mid-session, nothing's going to change until you run /new to start a fresh session or restart your gateway. Changes don't hot reload into existing sessions. The skill configuration lives in openclaw.json and has 3 layers we're going to go over. The first layer is skill.entries, which is the per skill configuration. Each skill gets its own entry keyed by its name, and you can set enable to true or false and provide an API key using the secret ref object that references environment variables securely. The format is source environment and the ID followed by your API key. So these secrets stay in the environment variables and never appear in your config file. Then inject environment variables through the environment field. Those environment variables are scoped per agent run and they're not global. The second layer is loading options. Skill.load.watch defaults to true, meaning the gateway watches for the skill file changes on disk. But remember, skills are snapshotted when a session starts, so changes only take effect after you run /new or restart your gateway. Skill load extra directories lets you point to additional directories beyond the standard 6 loading paths. And skills install node manager lets you pick your package manager, and you can choose from yarn or bun. The third layer is the per agent skill access, and this is where it gets important. Agent's default skill sets the inherited baseline, and this is the skills that every agent gets by default. Agents.list.skills lets you override that for a specific agent. But the rule is that explicit lists replace inherited defaults. They don't ever merge. If you set a skills array on a specific agent, it completely replaces what was in the defaults. So if your defaults include 10 skills and you set a per agent list with 3, that agent gets exactly 3, not 13. And this is how you create specialized agents. A research agent gets web-focused skills, a coding agent gets development skills, customer support agent gets communication skills, and this combination of per agent tool policies from day 9 and the per agent skill access gives you fine-grained control over what each agent can actually do. So what is ClawHub? Well, ClawHub is a web-based marketplace and command line interface registry for OpenClaw skills maintained by the OpenClaw Foundation. There's over 3,000 skills from a bunch of community publishers. Now, it's totally straightforward, right? You just use ClawHub search followed by a keyword to find what you're looking for, ClawHub install with the skill slug to install from the registry, ClawHub update all, which will update everything, ClawHub sync will scan your local skills and publish new or updated ones, and you authenticate with ClawHub login using your GitHub account. And your GitHub account must be at least 1 week old to publish, which is a gate designed to slow abuse. Each ClawHub listing shows the publisher identity and verification status, install counts, and community ratings, whether source code is available, compatibility information, and configuration requirements. The verified publishers have been through a review process, and the unverified ones haven't. And that distinction matters enormously to us, which brings us to our next slide. After installation, skills become available after a /new session or gateway restart. In terms of configuration, like API keys, environment variables, or enable or disable, this goes in openclaw.json under skills.entries. The docs don't mince words here, right? Skills are the most significant attack surface in any OpenClaw deployment. A malicious skill runs with the same permissions as the OpenClaw process itself, which means access to your files, shell, API keys, network connections, everything your agent can touch, a bad skill can also touch. ClawHub runs a built-in dangerous code scanner that blocks critical findings by default, but malicious code can still slip through. NPM lifecycle scripts execute during install, which means installation itself is a code execution. The platform auto-hides skills that receive 3 or more unique user reports, but the first line of defense is always going to be you. Your mitigation strategy is 4 steps here. First, you want to read the source code before installing, or at least put it through Claude Code. Most skills are only 100 to 300 lines long of Markdown, and maybe some supporting scripts, so this is completely feasible. Second, you want to run OpenClaw in a Docker container with network restrictions. This contains that blast radius of anything malicious. Third, you want to verify the publisher's reputation on GitHub. You want to check their profile, their other repos, how long they've been active. And then fourth, you want to never install from unverified direct URLs. Stick to ClawHub or well-known GitHub repositories. Installing a skill is a serious security decision. It's not just a feature decision. Build the habit of auditing your source code before trusting it, because in an agentic system, every skill is code that runs on your behalf with your permissions. 4 things before day 11. First, you want to list your installed skills and check your context. Run context list in the chat to see how much skill definitions contribute to your context window. Every installed skill adds tokens per turn, whether the agent uses it or not. You want to remove anything you're not using. Second, you want to install 1 skill from ClawHub. Run ClawHub search to find something relevant to your workflow. And before installing, read the source code. So check for hard-coded credentials, unexpected outbound connections, and unsanitized inputs. Then install it, start a /new session, and test it in a conversation. Third, build a custom skill markdown file. Create a directory under OpenClaw skills with a skill.markdown file. It can be anything. A unit converter, a random quote generator, or a task formatter. The point is getting the front matter right, writing precise use this when instructions, and then testing that agent actually calls it at the right time. If it doesn't, just iterate on the description. Fourth, do a security audit. So pick any installed skill, built-in or third-party, and read its source code end to end. Check for hard-coded credentials, unexpected network calls, and unsanitized inputs passed to exec. This is the habit that's going to keep you safe as you keep adding more and more capabilities. Your agent can now do things beyond the defaults, can reach external APIs, install community-built integrations from ClawHub, and you know how to build custom skills for anything it doesn't have yet. And just as importantly, you know how to evaluate the security of everything you install. Day 11 is integrations, so connecting your agent to the real-world services that you use every day. If you want hands-on help setting any of this up, consult with me at adirajhungle.com. And if this series is helping you, subscribe so you don't miss it. And with that, I'll see you on day 11. Welcome back to the OpenClaw Bootcamp. I'm Adiraj, and today is day 11. Your agent has channels, personality, memory, roles, tools, and skills. It can talk on WhatsApp, search the web, browse pages, run commands. You've got all the building blocks. But can it check your Gmail? Can it manage your Google Calendar? Can it react when someone pushes code to GitHub? Can it fire off tasks on a schedule without being asked? Today is about wiring those building blocks into real-world services. This is where your agent stops being a conversational tool and becomes embedded in your actual workflow. Stay 11, let's get started. On day 10, you dug into the skills architecture, the difference between tools and skills, the core built-in tools that ship with every installation, ClawHub for community skills, and building your own custom skill from scratch. Today, we're covering 3 things. First, the automation trigger architecture, so webhooks, cron configuration, and how they work alongside the heartbeat system you set up on day 6. Second, the productivity integrations that matter the most with the config details for each. And third, building custom integrations from quick conversational creation to the full 10-link enterprise chain that production deployments use. You've already connected the channels on day 5 and set up your heartbeat on day 6. Your agent can talk on WhatsApp, Telegram, Discord, and it can check in on a schedule. What you haven't done yet is configure the other 2 automation triggers, which are webhooks and cron, or connect the productivity tools that make your agent actually useful for real work. Webhooks let external services wake up your agent, like a GitHub push, a Stripe payment, a form submission that sends an HTTP post. Through those, your agent's going to react. Cron gives you the exact time scheduling, like daily at 8 a.m. or every Monday at noon. And Heartbeat, which you already know, fires on interval. These 3 automation triggers are how your agent works without being asked. The mental model here is channels are where your agent listens and speaks, triggers are what make it act on its own, and today we're going to wire up the triggers and the productivity integrations that make the whole system useful. Now let's break down the 3 automation triggers for their actual configuration, because the difference between them matters, and knowing when to use which saves you from building the wrong thing. Webhooks are event-driven. Something happens in the outside world, and then it sends an HTTP post to your agent's webhook endpoint. Configuration is straightforward, as you can see. Hooks enable turns it on. Hooks token is a secret key for authentication, so random requests can't trigger your agent. Hooks path sets the URL path. Your agent receives the webhook payload as context and responds accordingly. Cron is exact time scheduling. You define when something should happen using the standard cron syntax, like daily at 8 a.m., every Monday at noon, or first of the month. The configuration is cron enabled, cron.max concurrent runs to limit how many cron runs can execute simultaneously, and cron session retention for how many days to keep completed cron session data. Heartbeat is a periodic check-in system defined in the Heartbeat markdown file with heartbeat.every for the interval, heartbeat.target for where to send the output, and direct policy for delivery behavior. Unlike cron, which fires at exact times, Heartbeat fires on interval relative to when the agent started or last checked in. The rule of thumb here is use Heartbeat for recurring agent-initiated work, like morning briefings and monitoring. Use cron for exact time scheduling, like reports and backups. Use webhooks for reacting to external events like deploy notifications and payment alerts. If you're not sure, ask yourself whether the trigger comes from inside the agent, from the clock, or from the outside world. That's going to tell you which mechanism you should use. Google Workspace is probably the single highest impact integration for most people because email and calendar are where the real work lives. OpenClaw is going to handle this through the GOG skill, which has Gmail, Calendar, and Drive in one package. With Gmail, your agent can triage your inbox, draft responses, send emails, and manage labels. Calendar, it can check availability, create events, detect conflicts, and prepare meeting briefs. With Drive, it can create documents, search for files, and extract content. The setup uses OAuth, and the GOG skill handles the authorization flow automatically. First time you use it, your agent walks you through granting access. Tokens get stored securely and refresh as needed. There's no manual API key juggling here. But the key thing I need you to remember is always use a dedicated Gmail account for your agent. Never connect your personal Gmail. Your agent gets full read and write access to whatever account you connect. You can read every email, send as that address, modify your calendar. This is a security boundary that you do not want to blur. Create a separate Google account for the agent, forward what you want it to see, and keep your personal account separate. This is a hard rule for anyone serious about running agents safely. Your agent needs access to the internet to answer questions about current events, research topics, and gather real-time information. OpenClaw supports a wide range of search backends, and the one you pick affects your costs, privacy, and reliability. The recommended option is Agents.md. It's self-hosted, which means zero API costs and no rate limits. You run it on your own infrastructure, and it aggregates results from multiple search engines, and you have full control. You can install it by following the command on the screen or configuring it manually in openclaw.json. Trade-off is you need to host it somewhere, but if you're running OpenClaw on Docker anyways, then adding this to your compose file is trivial. The simple alternative is Brave Search API. Just get an API key and configure it, but the trade-off is usage limits and per query costs, but the setup is minimal. It's a good starting point before you migrate over to SearchNG. But beyond those two, the list is extensive. So you can use DuckDuckGo for free no-key search, Exa for neural research queries, Tavily for AI-optimized results, Firecrawl for web scraping combined with search, and then the model integrated options like Perplexity, Gemini, Grok, Kimi, Minimax, and Ollama Web Search. You can configure your preferred backend in OpenClaw.json, or just tell your agent which one to use and it handles the configuration. My recommendation is start with Brave or DuckDuckGo to get search working immediately, then move to SearchNG when you're comfortable with Docker. Self-hosted search is better in every dimension, except for the initial setup effort. Web search gets you text results, but some things require actually browsing, like filling out forms, interacting with JavaScript-heavy web apps, taking screenshots, extracting data from rendered pages. That's where browser automation comes in. OpenClaw uses Playwright under the hood with Chromium. Your agent gets a full browser control so it can navigate to URLs, click elements, fill up fields, take screenshots, and extract content from fully rendered pages. This is the tool for anything that simple HTTP requests can handle. Setup is super straightforward. So you install Chromium through Playwright. The agent uses a dedicated browser profile completely isolated from your personal browsing. So separate cookies, separate sessions. This is the same principle as the dedicated Gmail account. Never let your agent operate in your personal context. The security feature to know about is SSRF blocking. By default, the browser automation blocks access to private networks, so no browsing to localhost or internal IP ranges. This is super critical because prompt injection attacks could theoretically make your agent browse to internal services and exfiltrate data. The SSRF blocking prevents that by default. If you legitimately need your agent to access an internal service, say you have a local dashboard or an internal API, you could add specific host names to the hostname allow list, and this gives you controlled exceptions without disabling the protection entirely. Whitelist what you need and block everything else. Everything we've covered so far, like channels, webhooks, Google Workspace, search, and browser, these are pre-built configurations. But the real power is building your own, and OpenClaw gives you 3 paths, depending on how much structure you want. First path is building a skill from scratch. You create that skill markdown file with the instructions, find the parameters, and build the handler. This is what you learned on day 10, and gives you full control over every detail. Use it when you know exactly what you want, and the integration has specific requirements. Second path is a conversational shortcut. Do something manually with your agent, like walk it through an API call, show it a workflow, and then say turn what you just did into a skill. The agent's going to package the workflow into a reusable skill automatically. This is remarkably effective for straightforward integrations where the steps are super clear and easy to follow. The third path is guided teaching. So walk the agent through the integration step by step, explain it the API, the auth flow, the data format, and it learns and codifies the workflow. This is somewhere between first two in terms of control and effort. For enterprise integrations, think in terms of a 10-link chain. Input receives data from any channel or trigger, context loads memory or preferences, security validates permissions and sanitizes the input, research gathers external data, extraction parses it and structures it, reasoning analyzes and decides, production generates the output, logic host executes business rules, verification validates before delivery, and analytics logs and measures results. Not every integration needs all 10 links, but knowing the full chain is going to help you design robust systems that handle all sorts of edge cases. 4 things before day 12. First, go ahead and set up web search, install SearchNG, or configure the Brave Search API with your key if you want faster setup. Test it by asking your agent a question about something that happened this week. If it searches the web to answer, your backend is working. Second, connect one productivity tool. Install the GOG skill and connect Gmail or Calendar using a dedicated Google account, not your personal one. Test it with something simple, so check my calendar for tomorrow or summarize my unread emails. Verify that the OAuth flow completes and your agent can actually read and act on the data. Third, create a webhook or cron automation. Set up a cron job that runs daily summary at a specific time, or configure a webhook endpoint and trigger it with a curl command. The goal is to see your agent activate without being asked, so it's automation and not just conversation. Fourth, go ahead and test out the browser automation. So install Chromium through Playwright and ask your agent to browse a real website like LinkedIn and ask it to take a screenshot or extract data from that page. Then test the security boundary and confirm that it refuses to visit localhost or internal IP addresses. Understanding what the agent can and can't browse is super essential before you put this thing into production. At this point, your agent can reach out, touch the real world, and react to it, but everything we've built so far is running on your local machine. It's fine for development, but it's not how you run an agent in production. Day 12 is Docker, so containerizing your agent for reproducible, isolated, production-ready deployment. If you want help building this out, consult with me at alirajjungle.com, and if you want a community of people building and selling AI automations, join the free AI Automation Sprint. The link is in the bio. Subscribe and I'll see you on day 12. Quick question. What happens when a misconfigured skill tries to read your SSH keys? Or a bad exec call starts writing to your home directory? Right now, nothing stops it. Your agent runs bare on your machine with full access to everything. I'm Aliraj and welcome to day 12 of the OpenClaw bootcamp. Today, we're going to fix all that with Docker. It's the same agent, same config, but now it can't accidentally or maliciously touch anything that you didn't actually mount in. And this is the foundation for tomorrow's VPS deployment. Let's containerize. On day 11, you wired up the deeper integrations. So Google Workspace for email and calendar, web search backend configuration, browser automation with SSR protection, webhooks and cron triggers for event-driven and scheduled automation, and custom integration chains. Your agent is now plugged into the services that you actually use. Today, we're covering 3 things. So first, why Docker matters specifically for OpenClaw agents. So isolation, reproducibility, sandboxing, and the security boundary it provides. Second, the practical setup. So the Docker Compose configuration, sandbox modes, volume mounts, and networking. And third, production patterns. So how to run your containerized agent with systemd, log rotation, health checks, backups, and a zero downtime update strategy. Let me make the case for Docker specifically in the context of running an AI agent, because it's different from why you'd containerize a typical web app. First, isolation. Your agent has shell access, file system access, and the ability to make HTTP requests. On a bare host, a misconfigured agent or a malicious skill could touch anything, like your SSH keys, your home directory, your other services. In a container, the blast radius is contained. The agent can only access what you explicitly mount. Second, reproducibility. So pre-built OpenClaw images are available on the GitHub container registry. So you pull an image, you get the same exact environment everywhere. Third, sandboxing is built in directly to OpenClaw's architecture. You can set agents.defaults.sandbox.mode to non-main, and that's going to tell the runtime to spin up per session Docker containers for non-main sessions automatically. Your sub-agents get their own isolated container. You combine this with gvisor for kernel isolation, and you get defense in depth without any custom infrastructure. And fourth, easy rollback. If an update breaks something, you revert to the previous image tag. Your workspace and config live in the volumes, so the agent's state is completely independent of the container image. Getting started is straightforward. You want to install Docker. You can use Docker Desktop on Mac OS or Windows, Docker Engine on Linux, and then you want to create a Docker compose.yaml file. The compose file needs 3 things: the OpenClaw image, which you pull from the official registry, port 18789 exposed, which is the gateway port that channels and clients connect to, and volume mounts for your config and workspace. The critical volume is /OpenClaw. This is where your agent's configuration, credentials, model registry, and session state live. Mount it to the container so everything persists across restarts. Your workspace directory gets its own mount as well. That's where the sole agents and memory markdown files all live. Once that file is ready, use docker compose up/d. That's going to start everything in the background. Your existing config carries over seamlessly through the volume mount. If you've been running OpenClaw locally for 11 days, all that's set up so your personality, your memory, and your operating rules right there in the container. Sandbox modes are where Docker and OpenClaw's runtime intersect, and understanding the 3 modes plus the scope and access settings is essential. The mode setting controls who gets sandboxed. Off means no sandboxing, so everything runs on the host. Non-main means non-main sessions, so sub-agents, background tasks run in the per session Docker containers. The main agent runs on the host. All means every session, including the main agent, runs inside a Docker container. The scope setting controls container sharing. Session gives each session its own isolated container, so that's maximum isolation. Agent means all sessions for a given agent share one container. Shared means that all agents share a single container. Workspace access controls what the sandbox container can see. The default is none, so the sandbox has no access to the workspace at all, just its own file system. RO gives it read-only access, mounted at agent. RW gives it read-write access, mounted at /workspace. And for maximum containment, you can enable gvisor. This is an application kernel that intercepts system calls and adds another isolation layer between the container and the host kernel. This is the paranoid but correct approach for production agents that handle sensitive data. Now let's walk through production-grade Compose configuration, because the quick start version I showed earlier is minimal. Volumes break down into 3 categories. Workspace volumes for your agent files, so your sole agent skills, everything in the workspace directory. credential volumes for the API keys, auth tokens and provider configurations, and session volumes for conversation history and session state, so your agent doesn't lose context when you restart the container. Environment variables are how you pass API keys into the container. Never bake credentials into the image. You want to use environment_file.environment to load from a file that stays out of the version control, or use inline environment blocks for non-sensitive config. For networking, you want to bind to 127.0.0.1 by default with loopback only. That's loopback only. If you need remote access, use tail scale. Do not expose the ports publicly. Health check should hit the gateway port to verify that the agent is responsive, and the restart policies should be set to unless stopped for production. One feature I need you to know is the sandbox.docker.setup command. This lets you run custom setup scripts when the sandbox containers start. You can install additional packages, configure tools, or set up environment-specific dependencies that your agent's skills might need. Docker security for AI agents has a few gotchas that don't apply to typical containerized apps, and the biggest one catches people off guard. Docker bypasses host UFW rules entirely. If you're running on a Linux server and relying on UFW for your firewall, Docker containers can reach the network unfiltered. The fix is to add explicit rules to the Docker user IP tables chain. This is the only chain Docker respects for user-defined filtering. If you skip this step, your containerized agent has unrestricted network access, regardless of what your UFW config says. For container hardening, run as a non-root user inside the container, set the config file permissions to 600 and state directory permissions to 700. You want to require gateway auth for all connections, never run an unauthenticated gateway. Network restrictions go beyond the firewall, so you want to bind to 127.0.0.1 to prevent external access, unless you've explicitly set up a reverse proxy or tailscale. Drop all unnecessary Linux capabilities, so never run in privileged mode, and restrict the outbound traffic to only the API endpoints your agent actually needs, like your LLM provider, any iteration endpoints, and nothing else. Good news here is that when you stack Docker isolation with sandbox mode, tool policies from agents markdown file, and gateway auth, you get 4 independent security layers. Any one of them can fail without compromising the whole system. That's defense in depth. Running Docker in production means handling the things that don't matter in development. So auto start, logging, backups, monitoring, and updates. For auto start, you want to create a systemd service file that runs Docker compose up on boot and Docker compose down on stop. Set restart equals to always with restart sec or seconds up 10 seconds so the container recovers automatically from crashes. This is a standard pattern for any long-running Docker service on Linux. Log rotation is important because agent logs grow very fast. Every conversation, every tool call, every subagent spawn generates output. Configure Docker's logging driver with max size and max file limits so logs don't eat up your disk. Backups are simple because your workspace is just markdown files. Use Git to version control your sole agents and memory files and your daily notes. The key insight here that you need to take away from this is that everything important is in the volumes, not in the container. So your backup strategy is just back up the volumes. For monitoring, you want to use gateway.channel health check minutes to configure how often the gateway checks channel connectivity. Pair this with Docker's native health check to get container level monitoring. If the health check fails, Docker can restart the container automatically. Updates are the cleanest part. Pull the new image with Docker compose pull and then restart with Docker compose up-d. Your workspace and config live in the volumes, so updates are non-destructive. The old container stops, the new one starts with the same mounted data. Pre-built images are available with latest main and version-specific tags, so staying current is just a pull and restart away. 4 things before day 13. First, you want to install Docker, get Docker Desktop on Mac OS or Windows, or Docker Engine on Linux. Second, you want to create a Docker Compose YAML file. This is the file you're going to carry forward to day 13 when we deploy to a VPS. Third, run your agent in a container. So run Docker Compose up-d and verify that your agent is reachable from your configured channels. Fourth, test sandbox mode. Also spawn a subagent and verify that it gets its own Docker container. Check that the subagent can't access the host file system, and this is going to validate that sandboxing is working end to end. Your agent now runs in an isolated, reproducible, production-ready container, but it's still on your local machine. When your laptop sleeps, your agent sleeps. Day 13 is VPS deploy, and so taking this exact Docker setup and running it on a cloud server that never turns off. Your agent is going to be running 24/7, handling messages while you sleep. If you want hands-on help with Docker deployments or anything else in the series, consult with me at otherwatchungle.com. And if you want to build and sell AI automations alongside other builders, join the free AI automation sprint. Links in the bio. Subscribe so you don't miss day 13, and I'll see you tomorrow. Close your laptop. what happens? Everything stops. Your Telegram bot goes silent, your heartbeat tasks don't fire, your scheduled cron jobs miss their window. That's 12 days of building, and it all depends on your machine staying awake. I'm Adhiraj, and welcome to day 13 of the OpenClaw Bootcamp. Today, we put your agent on a server that never turns off. It's a VPS. It's $4 a month, runs 24/7, survives reboots, survives you going on vacation, and by the end of this video, your agent is always on, whether you're at your desk or not. On day 12, you containerize your agent with Docker. Today, we're going after 3 things as usual. First is choosing a VPS provider and understanding the hardware requirements, what specs you need for cloud-only setup versus running local models, and what that costs. Second, installing OpenClaw on a VPS with a daemon autostart so it survives reboots, SSH disconnections, and crashes without you lifting a finger. And third, securing remote access via Tailscale, hardening the gateway, and setting up monitoring so you know your agent is healthy without having to check manually. These are 3 providers that work well for OpenClaw deployments. Hetzer gives you the best price to performance, especially in Europe with strong ARM options. DigitalOcean has the most developer-friendly UI and predictable pricing. Linode, now part of Akamai, is reliable with global data centers and straightforward billing. For specs, if you're running cloud only, meaning your agent calls APIs like Claude, GPT, or Gemini, and doesn't run models locally, you need surprisingly little. 4 or more vCPUs, 8 gigs of RAM with 16 preferred, and 80 gigs of SSD storage. That runs you $5 to $20 a month, depending on the provider and the region. If you want to run local models through Ollama or similar, you're looking at 2 terabytes or more of storage, and ideally a GPU instance, which changes the cost picture significantly. I need you to know that AI installs AI Flow. You can have the Claude Code SSH into your fresh VPS and set up everything. So the dependencies, the OpenClaw installation, the configuration, the daemon, firewall rules. It takes about 15 minutes, and you don't need any DevOps experience. You just watch each step and approve it. There's 3 paths to get OpenClaw running on your VPS, and I'll tell you which one to use. Path 1 is the curl installer, which is the recommended approach for the new VPS deployments. It's literally 1 line, and it handles all the system dependencies, node version management, and permissions. Then you run OpenClaw onboard -- install daemon, which walks you through the configuration and installs a system service in 1 step. This is the most tested path and handles edge cases that manual installs miss. Path 2 is Docker. You already built your Docker Compose setup on day 12. You can deploy the same file on your VPS. Just run Docker Compose up-d and you're running. This is clean if you want container isolation on the server as well. Path 3 is manual. So apt install your dependencies, git clone the repo, npm install, copy the example environment file, configure it, and then do npm start. This gives you the most control, but also the most room for things to go wrong. I'd only recommend it if you have a specific reason the other 2 paths don't work for your setup. For most people, do path 1, curl installer plus onboard with a daemon flag. It's done in 15 minutes. Getting OpenClaw installed is just half the job. The other half is making sure it stays running through reboots, crashes, and SSH disconnections. The easy way is OpenClaw onboard -- install - daemon. This single command installs a systemd service on Linux or a launchd agent on macOS. It creates the service file, enables auto start, and starts the daemon immediately. After this runs, your agent is a system service, just like Postgres. What the daemon actually runs is the gateway, which is OpenClaw's HTTP server that handles all channel connections. It's going to listen on port 18789 by default, and once the daemon is running, you can close that SSH session, shut your laptop, and reboot the VPS, and the agent comes back automatically every time. That's the always on that we're after. Your agent is running on a VPS, and now you need to reach it securely because this thing is on the internet. The gateway has 4 bind modes. Loopback is the default and the safest. It only listens on 127.0.0.1, meaning nothing outside the server can reach it. LAN mode binds to all local interfaces. Telnet mode binds specifically to the Tailscale interface, and custom lets you bind to a specific IP. My strong recommendation here is to keep the gateway on loopback and use Tailscale for remote access. Here's why. Tailscale creates an encrypted WireGuard tunnel between your devices. You install it on the VPS, install it on your laptop and phone, and they can see each other on a private network. The gateway never touches the public internet, so there's 0 port forwarding. It's free for personal use, takes about 2 minutes to set up. If you need HTTPS, say you're building a web UI, talks to the gateway, you can use something like Caddy. Caddy handles TLS certificates automatically, the gateway stays on loopback, and the proxy terminates HTTPS. For authentication, the gateway supports 3 modes. Token authentication using bearer tokens, which is recommended. password mode with username and password, and trusted proxy mode where you delegate off to your reverse proxy. The unauthenticated gateway is an open door to your agent and everything it has access to. Your agent is on the internet now, which means that security isn't optional. OpenClaw is a built-in security audit tool that does most of the work for you. Just run OpenClaw security audit-deep, and it performs a live probe of your running gateway, checking for misconfigurations, exposed endpoints, weak auth, and permission issues. If it finds problems, run OpenClaw security audit-fix, and it auto-remediates what it can, like fixing file permissions and enabling auth requirements, that kind of thing. For the firewall, UFW is the simplest approach on Ubuntu. Default deny incoming, allow SSH so you don't lock yourself out, and allow traffic on the Tailscale interface, and enable. 3 commands, and your VPS only accepts SSH and Tailscale traffic. Now, in terms of the hardening checklist beyond that, you want to always run OpenClaw as a dedicated non-root user, never as root. Set the config directory permissions, enable your gateway auth tokens, enable DM pairing so only authorized users can interact with your agent, and lock your bot father if you're using Telegram. Disable the group ads so nobody can just pull your bot into channels that you never approved. None of this is super difficult, and the security audit tool catches most of it automatically. But it matters because your agent has access to your API keys, your memory files, your tools, and potentially your code. Treat it like you treat any server that handles sensitive data. Your agent is deployed and secured. Now you need to know when something breaks without checking every day. OpenClaw Doctor is your best friend and first diagnostic tool. Checks config validity, API key health, channel connections, memory index status, and daemon health all in one command. Run it after deployment and whenever something seems off. For gateway-specific status, run OpenClaw Gateway Status. That's going to show you what channels are connected, uptime, and request counts. For ongoing monitoring, set gateway channel health check minutes in your config. This just tells the gateway to verify channel connections at the interval that you specify and log warnings when something fails. If your Telegram bot token expires or your Discord connection drops, you'll see it in the logs before your users do. Speaking of logs, they live at temp OpenClaw year month day .log, 1 file per day. On a VPS, you might want to set up a log rotation or pipe them to a persistent location since temp can get cleared. For updates, run OpenClaw update -channel stable. This is going to pull the latest stable release. You can also use the beta or dev channels if you want to test new features. The update command is going to handle the restart. Backup strategy is simple because your workspace is already a Git repo. It contains your sole, agents, memory, daily notes, and config. Push it to a private GitHub or GitLab remote. If your VPS dies, spin up a new one, install OpenClaw, clone the workspace, and you're back in business. All your agent's personality, memory, and configuration travel with that repo. 4 things before day 14. First, provision a VPS. So spin up an instance on Hetzner, DigitalOcean, or Linode with at least 4 vCPUs and 8 gigs of RAM. Second, install OpenClaw. So use that curl installer we went over. Third, configure remote access with Tailscale. Install it both on your VPS and your laptop. Verify that you can reach the gateway through the Tailscale IP on port 18789 and keep the gateway on loopback. So let Tailscale handle the routing. Fourth, run the security audit. So OpenClaw security audit -deep. Fix any findings, set up UFW with default deny, verify those config permissions, and confirm gateway auth is enabled. Your agent is on the public internet now, so treat it accordingly. At this point, your agent is no longer tied to your laptop. It's on a server, secured, monitored, and always available. That's a production deployment. Day 14 is agentic coding. It's using your always-on agent as a development partner, so code generation, PR reviews, debugging, and pair programming. If you want hands-on help with VPS deployments, security hardening, or anything else, consult with me at adhirajhungle.com. And if you want a free community of people building and selling AI automations, join the AI Automation Sprint. Link is in the bio. Subscribe, and I'll see you on day 14. Most people build an OpenClaw agent and use it just to answer questions. That's like buying a race car to drive to the grocery store. This thing has exec, read, write, edit, and browser. It can do everything a developer does at a terminal. Welcome back to the OpenClaw Bootcamp. It's day 14. I'm Adhiraj, and today we stop treating your agent like a chatbot and start treating it like a coding partner. Quick recap. So on day 13, you deployed OpenClaw to a VPS. You set it up as a daemon, configured remote access, and ran a security audit on the whole deployment. Today, there's 3 things on our agenda. First, what agentic coding actually is, and the align before build prompting pattern that makes it work. The difference between useful output and wasteful tokens comes down to how you prompt. Second, build logs and planning. The system that lets your agent work across multiple sessions on the same project without losing context. And the third, sub-agent coding patterns. So how to orchestrate research, implementation, testing, and review agents working together on a single project. Let's get super direct about what agentic coding is and what it isn't. Agentic coding is not autocomplete. It's not GitHub Copilot suggesting the next line. Your agent uses exec, read, write, and edit tools to do full autonomous development. It reads your code base, understands the structure, makes a plan, writes the implementation, and then runs it. Then when it hits errors, it debugs and iterates until it works. The loop looks like this. For read, the agent examines the existing code and context. For plan, it decides what to build and how. For write, it creates or edits files. For test, it runs commands to verify. For fix, it debugs errors and iterates. That's the React loop applied to the software development, and it works because the agent has the same tools that the developer does: terminal, a file system, and the ability to search the web for documentation. The key prompting pattern here is a line before build. You explain your idea, the agent asks clarifying questions, you agree on the approach, and then, and only then, does it start writing code. If you skip the alignment step and you just say build me the thing, you'll get code that technically does run, but it won't match what you actually wanted. Flesh out before executing, that is the golden rule. Now let's go through the tools that your agent actually uses when it codes. Exec is the big one here. It runs any command like npm install, git commit, Python scripts, cargo build, basically whatever your project needs. This is the agent's hands on the keyboard. With exec approval enabled, the agent poses each command and you approve it before it runs. Read, write, and edit are the file operations. The agent reads source code to understand it, writes new files for implementations, and uses edit for surgical changes to existing files. Web search and web fetch let the agent research. It can look up API documentation, find package readmes, check Stack Overflow for patterns. If it doesn't know how a library works, it can literally learn it in real time. That's what makes this more than a code generator, because it can actually do the investigation. Browser lets it test web applications visually. It can open a page, click elements, verify that the UI renders correctly, does end-to-end testing without leaving the agent session. And session spawn delegates subtasks to subagents, but we'll get deep into that on slide 8. The golden rule, as I mentioned earlier, is flesh out before executing. I cannot stress this enough. The number one mistake people make with agentic coding is going straight to build it without alignment. So here's the pattern. Step 1 is explain your idea. Describe what you want built, the constraints, the expected behavior, and what success looks like. Step 2 is let the agent ask questions. Good agents clarify before coding. If your agent jumps straight to writing code without asking anything, that's a red flag because at that point, it's guessing, it's not understanding. Step 3 is agree on the approach. Review the plan before a single line of code is written, and then step 4 is execute on it. Now the agent can build with clarity. Reverse prompting is the advanced move here. Ask the agent questions back, like what edge cases should we handle? What dependencies does this need? What could break? The agent often knows things that you haven't considered because it's read more code base than any single human. And for anything beyond a one-session task, create a build log at memory/build projectname.markdown. This file is going to track progress across sessions, and if a session crashes or you come back the next day, the agent reads the build log and picks up exactly where it left off. The log is the continuity. Any project that takes more than 3 steps or more than 2 hours needs a plan file first. There's no exceptions here. Before writing a single line of code, create memory build projectname.markdown, and the prompt I use every single time is before we build, create this markdown file with the goal, constraints, ordered steps with checkboxes, current status, decisions made, and blocker. That gives the agent a structured document to work from and update as it goes. Now, what goes in the build log? Well, the goal, so what you're building and why, the steps, so ordered tasks with checkboxes that get checked as they're completed, status, which is what step you're on and when it was last updated, decisions, so why you chose approach X over approach Y, so future sessions don't relitigate settled questions, blockers, so what's stuck and what to try next, and then completed items, so what's done with any notes about anything unexpected. The critical discipline you need to drill in is logging every step. After every step completes, the agent should update the build log, so it should check the box, know what happened, and update the status. This pays off every time a session ends unexpectedly, and sessions do this all the time. Context windows fill up, connections drop, you close your laptop, and when you come back and start a new session, the agent's going to read the build log and know exactly where to pick up. Once your agent successfully completes a coding task, you can turn that workflow into a reusable skill. This is how your development setup compounds over time. These are 3 dev-relevant skill categories you should know. The GitHub skill handles repos, pull requests, issues, and code review. Your agent can literally create PRs with this, review diffs, and manage issues directly. Code review skills give you automated review patterns, like consistent style checks, and CI/CD monitoring lets your agent watch builds, report failures, and even trigger deployments. The most powerful pattern is creating skills from completed tasks. After the agent finishes something, say just set up a new Express API with TypeScript, testing, and Docker, you tell it, turn what you just did into a skill. The agent's going to extract the pattern from its own session history and codify it. Next time you need an Express API, it's one command operation instead of a 30-minute conversation. This is where agentic coding gets serious. The orchestrator pattern uses subagents to parallelize development. So a research agent investigates APIs and reads documentation. An implementation agent writes actual code. Testing agent writes and runs test suites. And a review agent does code review and quality checks. The main agent's going to coordinate all of them. The key rule here is you want one discrete feature per spawn. Never just tell it build the whole thing. Subagents are ephemeral, so they get one task. They do it and then they report back. If you try to give a subagent too much scope, it loses focus and produces worse results than doing it in the main session. Keep spawns small and specific. Timing matters a lot too. Space your spawns 20 to 30 minutes apart. Don't flood the system with 5 subagents at once. Each one needs time to complete before the next one can pick up the results. The research agent needs to finish before the implementation agent can use its findings. And here's how the coordination works. The build log is going to persist across all the subagents. So each subagent reads the build log on start, does its work, and updates the log on completion. The log is a shared state between all the agents. The main agent monitors the build log to know when each subagent has finished and what it accomplished. This is not a theoretical pattern, but this is how you build real features. 4 things before day 15. First, you want to create a build log. So pick any project, even a small one, and create that file with the goal, steps, status, and decisions. Practice the discipline before you need it on a real multi-session build. Get comfortable with that format. Second, use your agent to write a small script with exec and write. A file renamer, a log parser, a data formatter, something useful but scope. Use the align before build pattern, so explain the idea, let the agent ask questions, agree on the approach, then execute. Pay attention to how different the result is compared to just saying, write me a script. Third, spawn a subagent for the coding subtask. Use session spawn or subagent spawn to delegate something discrete, like writing tests for existing code, creating documentation, or researching an API you want to integrate. Monitor it with subagents log and see how it reports back. Fourth, turn a completed coding task into a skill. After finishing tasks 2 and 3, tell the agent turn what you just did into a skill. Then review that generated skill definition and think about what other repetitive development tasks you could automate this way. After 14 days, your agent is a legitimate development partner. You can read code, write implementations, run tests, fix errors, coordinate subagents, and maintain continuity across sessions through build logs. That's literally a junior developer who never sleeps and never forgets the plan. Day 15 is multi-agent, so orchestrating multiple specialized agents with different roles, different configs, and different capabilities all working together. You've used subagents for coding tasks. Tomorrow, you learn to architect entire agent teams. If you want help setting up agentic coding workflows or anything from this bootcamp, consult with me at otherwirechanlo.com. And if you're ready to start building and selling AI automations, join the free AI automation sprint. Links in the bio. Subscribe so you don't miss day 15, and I'll see you there. Your agent is a generalist. It handles everything, but it's not optimized for anything. What if your support users got an agent that's fast and friendly, your power users got one with full tool access, and your internal team got one that knows your entire code base? That's not one agent, that's a whole team. I'm Adhiraj, and today I'm going to show you how to build that. You'll set up one gateway with multiple agents behind it, each with its own personality, its own tools, its own workspace, with a routing system that sends every conversation to the right agent automatically. This is multi-agent orchestration. Let's set it up. On day 14, you went deep on agentic coding. The align before build prompting pattern, build logs for multi-session continuity, and subagent patterns for parallelizing development. Your agent became a legitimate coding partner. That was one agent delegating to copies of itself. Today is different. Today is about running genuinely different agents, different personalities, different tools, different workspaces, and routing traffic between them. There's 3 goals for today. First, understand the multi-agent architecture, how each agent gets its own isolated workspace, agent directory, session store, and why those boundaries matter. Second, master routing precedents and channel bindings so you can deterministically control which agent handles which conversation. Third, configure agent-to-agent communication and enforce per-agent security isolation so your agents can collaborate without compromising each other. The core concept is simple. There's one gateway with many agents. Each agent in OpenClaw is 3 isolated components. First, the agent directory holds auth profiles, model registry, and agent-specific state. Under that same path, sessions is going to store the conversation history. Second, the workspace is where the agent's soul, memory, and agents markdown files, tools, and skills all live. It's complete isolation from the other agents. You manage the agents through the command line interface. OpenClaw agents add creates a new agent. OpenClaw agents list shows what you've got. OpenClaw agents delete removes one. It's a clean lifecycle management. And the critical rule that the docs do hammer home is never reuse the agent directory across agents. Each agent must have its own directory. Sharing causes auth collisions and session corruption, and the bugs are silent and extremely difficult to trace. Once you have multiple agents, you need to decide which agent handles which conversation. This is routing, and it's completely deterministic. The precedence order goes peer first, which is an exact user match by kind and ID, then parent peer, then guild ID plus roles, which is a server and role combination, then guild ID alone for server-wide matching, then team ID, then account ID, then channel ID, and then finally the default agent as fallback. First match wins, and if multiple bindings match at the same tier, config order breaks the tie. Whichever binding appears first in openclaw.json takes priority. Bindings are defined in openclaw.json, and the match fields include channel, account ID, peer with kind and ID, guild ID, and roles. When you specify multiple match fields on a single binding, they use AND logic, so all the fields must match. This is exactly how you create precise routing rules, like Discord users with the admin role in this specific server get routed to the admin bot. Each agent gets configured under agents.list in openclaw.json. Key properties here are ID for the unique identifier, name for the display, workspace pointing to the agent's workspace directory, agent directory pointing to the state directory, model for which LLM to use, default as a boolean for the fallback agent, identity for a brief description, and sandbox for the execution environment. Beyond the basics, you configure tools with allow and deny lists, skills with allow lists, group chat.mention patterns for trigger words in group context, and then memory search for configuring which search backend your agent's going to use. For shared config, use agents.defaults. This is going to set a baseline that all models inherit. The model sandbox mode common tool policies. Individual agents override any property that they need to defer on. This keeps your config dry. So you want to set the common stuff once in the defaults and only specify what's unique per agent. And I'll say it again because this is the most common mistake people make. Never reuse the agent directory across agents. Every agent needs its own. Let's get platform specific now. For Discord, there's one bot per agent. You'll need to create a separate bot application for each agent, and message content intent must be enabled. Bind by peer for DM routing to specific users, by guild ID for server-wide routing, or by roles for Discord role-based routing. So admins talk to one agent, and regular members talk to another. Telegram is also one bot per agent, created through BotFather. Each agent token maps to exactly one agent. Bind by peer for DMs, by guild ID for group-wide routing. For WhatsApp, you log in with OpenClaw channels, login -- channel, WhatsApp -- account with your ID in brackets. For multi-account setups, like say you're running agents for multiple phone numbers, define each under channels.whatsapp.accounts with a separate auth directory per account. This is what keeps those auth sessions isolated. The binding patterns work across all channels. Peer bindings have the highest precedence and always win. Server or guild bindings are next, and channel-wide bindings catch everything else. Design your routing from the most specific to the most general. By default, agents can't talk to each other. This is a deliberate security choice, and you have to opt in explicitly. To enable it, configure tools.agent to agent on the agent that needs to initiate the conversation. Set enable to true and provide an allow list of agent IDs that this agent is permitted to contact. If an agent isn't on the allow list, then communication is blocked. For cross-agent memory, you use agents.list.memory search.qmd.extract collections. This lets one agent search another agent's memory store without sharing session context. It's read-only, so agent A can search agent B's memory, but it can't write to it. Session isolation is maintained through the key format, which is agent ID main key. Each agent keeps its own conversation history, even when two agents handle the same user. There's no bleed through between agents. The design principle here is that the communication is explicit and auditable. You can see exactly which agents talk to which, exactly what memory was shared, and exactly where the boundaries are. There's no implicit sharing, and there's no hidden state transfer. Security in a multi-agent system comes down to per agent controls. Each agent gets its own sandbox mode, off, non-main, or all, and each agent gets its own tool allow or deny lists. Each agent gets its own skill allow list, and critically, each agent gets its own auth profiles.json. DM sessions collapse to main per agent, meaning each agent sees only its own session history for a given user. Cross-agent sessions are keyed separately, so even when two agents handle the same person, their conversation histories never bleed into each other. For maximum isolation, the pattern is one agent per person, so each user gets a dedicated agent with its own workspace, memory, session store, and all. This is the absolute gold standard when data separation is legally or contractually required. Two things to watch for here. First, never share your agent directory. I've said it 3 times now, and that's because it's the single most common multi-agent misconfiguration. Second, relative paths stay inside the workspace, but absolute paths breach the sandbox. If an agent can write to an absolute path outside its workspace, your sandbox isolation is useless. Audit your tool configs to make sure nothing allows the absolute path access. 4 tasks before day 16. First, add a second agent. So run OpenClaw agents add and create a new agent with its own ID, workspace, and agent directory. Verify it shows up in the OpenClaw agents list and triple check that the agent directory is unique. Second, bind it to a different channel. Configure a binding in OpenClaw.json so your new agent handles a specific channel, server, or user. Test that messages actually route to the correct agent based on your binding rules. Third, configure different tools and skills per agent. Give each agent a different tool allow deny list and different skill allow lists. One agent might have a full exec access while the other is read only. Verify the restrictions hold by trying to use a denied tool. Fourth, test routing end to end, send messages from different channels, users, or roles, and confirm the routing precedence matches what you configured. Also check that your default agent catches unmatched traffic as expected. Here is where you stand after 15 days. You've built personality, memory, tools, skills, heartbeats, subagents, and now multi-agent orchestration. Your system isn't just one capable agent, it's a coordinated team of specialized agents, each with its own workspace, its own security boundary, and its own role. Day 16 is the finale, which is workspace files. Every file, every config, every interaction, we're going to cover it. It's one definitive guide to running your OpenClaw system in production. It ties everything from the past 15 days into a single reference you'll come back to over and over again. If you want help setting up multi-agent architecture for your team or business, consult with me at aliradtrumbull.com. And if you want to be around other people building and selling AI automations, join the free AI automation sprint. The link is in the bio. Subscribe so you don't miss the finale, and I'll see you on day 16. 16 days, you went from what is OpenClaw to a production deployed multi-agent system running on a VPS with Docker, handling messages across every channel while you sleep. I'm Adiraj. Welcome back to the OpenClaw Bootcamp. This is the last one, and day 16 is a new features. It's the complete map. This is the reference you'll come back to every time you need to change something or debug something or explain your setup to someone else. And with that, let's dive into it. On day 15, you set up multi-agent orchestration, routing messages to specialized agents, binding agents to channels, configuring agent-to-agent communication, and enforcing per-agent security isolation. That was the last major capability layer. Today, we're after 3 things. First, mapping every workspace file and understanding exactly what it does, because after 15 days of building these files one at a time, it's worth seeing them all laid out together. Second, understanding the full bootstrap injection order and the complete OpenClaw.json config reference, because when something isn't working the way you expect, knowing the load order and the config surface area is usually how you find the problem. And third, seeing how every system connects end to end in the full architecture with the message routing, bootstrap injection, tool execution, memory, heartbeat, cron, subagents, all of it in one picture. Everything lives in OpenClaw/workspace. Let's walk through every file. Soul.markdown is the personality. It's the agent's voice, core truths, boundaries, and vibe. This is who your agent is. We built this on day 7. The user markdown file is all about you, your preferences, your background. It's context about who the agent is talking to. Memory is the long-term memory, so durable facts, preferences, and decisions that get injected into context every turn in private sessions. We did this on day 8. Agents is the operating manual, so workflow rules, tool usage policies, escalation procedures, and behavioral guardrails. That was day 9. And then tools, which was day 10. The tools markdown file holds addresses, references, API endpoints, and external resources the agent needs to do its job. That was day 10. And then heartbeat is the proactive checklist, so the tasks your agent runs on its own schedule without being asked. We covered that day 6. Identity defines the agent's identity, and bootstrap holds any extra context you want injected. Then there are 2 directories, skills for custom skill definitions and memory for daily note files, which is 1 per day. The beautiful thing about all of this is that it's just Markdown. There's no database, there's no proprietary format. You can version control all of it with Git, edit it in any text editor, and then back it up by copying a folder. When a session starts, OpenClaw loads these files in a specific order, and that order matters because it determines what the model sees first and how context stacks up. The sequence is agents, then soul, then tools, then identity, then user, then heartbeat, then bootstrap, and finally memory. Agents loads first because operating rules need to be established before anything else. The model needs to know how to behave before it knows who it is or what it remembers. Two hard limits to know here. The per file cap is 20,000 characters, controlled by Bootstrap max chars. Total across all Bootstrap files is 150,000 characters, controlled by Bootstrap total max chars. If a file is blank, it's skipped entirely, so there's no token cost. If a file exceeds the per file cap, it's going to get trimmed silently. And the key architectural detail here for your multi-agent setups is that subagents only receive the agents and tools marked on files. They don't get the soul and they don't get the memory, and they don't get any of the other Bootstrap files. This keeps subagents focused and isolated as they only get the operating rules and the resource references, and that's it. The other half of the reference is openclaw.json, which controls everything that isn't a Markdown workspace file. Let me walk you through every top-level section. Agents defines your agent's defaults and the agent list, which is model selection, temperature, and system prompt overrides. Channel is the per provider configuration for Discord, Slack, Telegram, Matrix, and anything else you've got connected. Session controls VM scope, reset mode, and thread bindings for thread level isolation. Gateway handles the server itself, so port, auth, bind address, and reload mode. Tools manages the tool profile, so the allow and deny lists, exec permissions, elevated permissions, and file system access. Skills configures skill entries and load paths for custom skill directories. Cron defines schedule tasks. Hooks sets up the lifecycle hooks for pre and post actions. Heartbeat controls a proactive schedule, so the interval enabled flag, quiet hours. Environment holds the environment variables, and logging configures the log level and format. It's the full config surface. When something isn't working, it lives in one of these sections. Sessions are how OpenClaw manages conversation state, and the session.dm scope setting controls how granular that isolation gets. There's 4 options here. Main gives you a single shared session for everyone. Per peer creates 1 session per user, so every person gets their own conversation context. Per channel peer isolates per user per channel, so the same person on Discord and Slack gets separate sessions. And per account channel peer is full isolation, so every combination of account, channel, and user is a separate session. Session reset mode, set to daily, means sessions reset every day. Thread bindings enable thread level isolation within channels, so different threads in the same Discord channel get their own session context. For the day-to-day operations, you have chat commands. So status shows current session info, new will start a fresh session, reset clears the current one. Compact will trigger compaction manually. For debugging, you can use /think with a level sets reasoning depth, verbose toggles verbose output, trace toggles trace logging, usage shows your token consumption. These are the tools you'll reach for when something isn't behaving the way you expect. Now let's go through the complete flow end to end, because this is the picture that ties every day of the bootcamp together. A message arrives from any connected channel, like Discord, Slack, Telegram, doesn't matter. The gateway receives it and uses channel bindings and routing rules to determine which agent handles it. That's the gateway and channels config. Then the selected agent's bootstrap files get injected in order. So the agents, soul, tools, identity, user, heartbeat, bootstrap, and then memory. That's the system prompt that the model sees. The model processes the message with all that context, reasons about what to do, and then invokes tools as needed. The tool results get fed back into the conversation, and the model reasons again if needed, and then eventually produces a final response. That response gets delivered back to the originating channel. Now, what's insane is running in parallel to all this is a heartbeat and cron trigger proactive actions on their own schedules. They're checking feeds, they're running tasks, they're setting updates without anyone asking. The subagents spawn their own isolated sessions with scoped bootstrap when the main agent delegates work, and memory persists across sessions through files on disk. So the memory markdown file for long-term facts, daily notes for running context, and the dreaming system for automated promotion. That is the whole architecture, every piece we built over 16 days, all connected together. That's the full architecture, every piece we built over 16 days, all connected together. Once your agent is running in production, you need to keep it healthy. Few key commands here. OpenClaw Doctor runs a full system health check. It'll tell you if anything is misconfigured, missing, or broken. OpenClaw Security Audit --deep does a thorough security scan of your setup, Run both of those periodically, especially after making config changes. For updates, OpenClaw update -- channel stable, pull stacked releases. This is what you want for production. -- channel beta gets you pre-releases if you want to test upcoming features. Channel dev pulls directly from main branch, which is bleeding edge and not recommended for production. Config reload is controlled by gateway reload mode. The default is hybrid, which does smart reloading. Hot does live reload without a restart. Restart is a full restart on any config change. And off means manual restart only. For backups, your workspace is just markdown files and a JSON config. Put it in Git. Treat your agent configuration like code because it is code. If something breaks, you can roll back to a previous commit and be running again in seconds. Let's take a second and just look at what you've done. Day 1, you understood what OpenClaw is. Day 2, you installed it. Day 3, you mapped the model landscape. Day 4, you learned to control the costs. Day 5, you connected to every channel. Day 6, you made it proactive with a heartbeat. Day 7, you gave it a personality. Day 8, you gave it memory. Day 9, you wrote the operating manual. Day 10, you added tools and skills. Day 11, you built integrations. Day 12, you containerized it with Docker. Day 13, you deployed it to a VPS. Day 14, you set up coding workflows. Day 15, you orchestrated multiple agents. And day 16, today, you mapped the complete system. You started with nothing and built a fully autonomous AI agent from scratch. It has a personality, memory, operating rules, tools, channel integrations, containerized deployment, and multi-agent orchestration. That is a full production system. That's the bootcamp, 16 days from zero to a production-ready autonomous AI agent. Every workspace file, every config section, the full bootstrap pipeline, the complete system architecture, you know all of it now. If you want expert help taking this further, custom builds, enterprise deployments, or ongoing optimization, consult with me at aliradjungle.com. And if you want to keep building alongside a community of people shipping AI automations, join the free AI automation sprint. And if this series helped you, subscribe and share it with someone who needs it. I'm Aliraj. This has been so much fun. Go build something incredible.